এটা তো দেখলাম দেখে হুম, এদিকে হাইড্রোলজিক্যাল হ্যাঁ হ্যাঁ এটা দিয়া হয়েছে কি না ইয়েরে
এটা পরে দিয়া হବ এটা পরে ଲାଷ୍ଟ ହଁ ଏବେ ଏଟା ଦେଇ ଦିଅନ୍ତୁ।
ପାଇପ୍ ପଳେଇଗଲେ ଏଠି ଗଲା ପରେ ଏଠି ଖାଲି ପିପିଟା ଆଡ୍ କରିବାର ଅଛି। ହଁ
ଡିସପ୍ଲେରେ କଣ ଶୋ କରୁଛି ଦେଖନ୍ତୁ ଡିସପ୍ଲେ ନା ନା
ଓ ଯୋଉ ଏଠି
ଡିସପ୍ଲେ ସେଟିଂଟା କରନ୍ତୁ ସିନ୍ ଟୁ ଦିଅନ୍ତୁ
ଓ
ଏଇଟା ହଉଛି ଥମ୍ବନେଲଟା।
ଲାଇଭରେ ତ
ହୁଁ ହୁଁ
ଏଇଟା ହଉଛି ଲାଇଭରେ ହେଲା
ହୁଁ
ଏଇଠି ଆଉ ଗୋଟେ
ହୁଁ
ଏଇଟା ଆଡ୍ କରିବାର
ହଁ
ଅଛି।
ଗୋଟେ ସିନ୍ ଟା କରନ୍ତୁ
ସିନ୍ ଟା ଅଛି ଠିକ ଅଛି
ଡିସପ୍ଲେ ନା ନା
ସିନ୍ ଠିକ ଅଛି।
ହଁ ସରି ସରି ହଁ ଡିସପ୍ଲେ କ୍ୟାପଚର କରନ୍ତୁ। ଓକେ
ସ୍କ୍ରିନ୍ ସେୟାରିଂ କହୁଛୁ ତ
ହଁ
ଏବେଠୁ ସ୍କ୍ରିନ୍ ସେୟାରିଂ କରିକି କିଛି ଲାଭ ନାହିଁ।
ନା ନା ମୁଁ କହୁଛି କି ଅଲରେଡି ସେଟ୍ କରି ରଖିଦିଅନ୍ତୁ ବାସ୍ ସ୍କ୍ରିନରେ ଯାହା ଶୋ କରିବ ତ କିନ୍ତୁ ଆମେ
ନା 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 ସେଟା ଭୁଲ ହବ। ଧର ବ୍ୟାକଗ୍ରାଉଣ୍ଡ କିଛି କରିହବ ବୁଝିପାରୁଛୁ କି ନାହିଁ ସେଟା
ହଁ
କଲେ ଭୁଲ ହବ।
ହଁ ତ ହଁ ତାପରେ ସିନ୍ କରିକି କରିଦେବ
ମୁଁ ସ୍ୱାଇପ କରିଦେବି ଏବେ ଦେଖ ଧର ସପୋଜ ଧର
ଶୁଣନ୍ତୁ
ଏ ଦେଖ ମୁଁ ଧର ଏଇଟା କଲି ହେଲା ଏଇଟାକୁ ମୁଁ ଲାଇଭ ରେ ଦେଖିବାକୁ ଚାହୁଁଛି।
ମିନିମାଇଜ କରୁନ
ନାଇଁ ନାଇଁ କାଲି ହେଇଥିଲା ତାର ୱିଣ୍ଡୋଜରେ କାଲି ସେଇଆ ହିଁ କରିଥିଲି। ନାଇଁ କାଲି ହଉଥିଲା ସବୁ ଥର ହେଲେ ତ ବହୁତ ପ୍ରୋବ୍ଲେମ ହେଇଯିବ।
ଡିସପ୍ଲେ ତ ରହିବ ଡିସପ୍ଲେ ଆପଣ ଖାଲି ସ୍କ୍ରିନରେ ଶୋ କରିବେ ନା ଆପଣ ଡିସପ୍ଲେ ଯୋଉଟା ଅଛି
କାଲି ସ୍କ୍ରିନ୍ ସେୟାର ନଥିଲା କାଲି ସ୍କ୍ରିନ୍ ସେୟାର ନଥିଲା ଅଧିକା କରିଦେବାର ଅଛି ସାର୍ ଦେ ଭିଡ଼ିଓ କ୍ୟାପଚର ଡିସପ୍ଲେ କ୍ୟାପଚର ତ ଓକେ
ମିନିମାଇଜ କଲେ ଏଟା ଦେଖି ହଁ ଲାଇଭରେ କଣ ଶୋ କରୁଛି
ସେ ଡିଲେ ହୁଏ। ଏମିତି ନାହିଁ।
ଆଉ ସେଇଟା ଆଣନ୍ତୁ ଆଗକୁ କୋଉଟା କ୍ୟାମେରାଟା ଆଣନ୍ତୁ ସାଇଡରେ କ୍ୟାମେରାଟା ଆଣନ୍ତୁ ହଁ OBS
ଏଇପାଇଁ
ବୋଲା ପରେ ଠିକ ଅଛି ଏବେ ମିନିମାଇଜ କଲେ ଆପଣ ଆଉ ମିନିମାଇଜ କଲେ ଏମିତି ହଁ ଏମିତି ଛାଡିଦେବେ ହଁ ହେଲେ ଆପଣ ଯାହା କରିବେ ଶୋ କରିବେ ମାନେ ଗୋଟେ ସ୍କ୍ରିନ୍ ଅଫ୍ କରିକି OBS ଯାଆନ୍ତୁ
ଛୁଇଁ ଯାଇନି କିଲୋ ସେଇ ଫୋଲ୍ଡରରେ ସବୁ ରହିବ।
OBS ଯାଆନ୍ତୁ OBS ଯାଆନ୍ତୁ
ସିଓର
ହଁ
ସିଓର ସିଓର
ସିନ୍ କଲେ ହଁ ଆଉ ମିନିମାଇଜ କଲେ ମିନିମାଇଜ କଲେ ଲାଇଭ ଠିକ ଅଛି ହେଲା ମାନେ ବୁଝିଲେ ତ ଯଦି ମାନେ ଆଉ କିଛି କରିବାର ଅଛି ତ ମାନେ ଲାଇଭ ଟୁ କାଟି ସିନ୍ ମାରିକି ତ କଲେ ଏଇଟା ଦେଖଉଥିବ ବାକି ଆମେ ମାନେ ଯାହା କରିବା କଥା ଏମିତି ଆମେ କରିପାରିବା
ସିନ୍ ଟା ଚେଞ୍ଜ କରିକି
ସେଇଟା ଚେଞ୍ଜ କରିକି ମାନେ ସୋର୍ସ ଯାହା କରିବା
କାଲି ଥିଲା ହେଲା ଡିସପ୍ଲେ କ୍ୟାପଚର ନ କରିକି ସ୍କ୍ରିନ୍ ଟା ସେୟାର ମାନେ
ଆଉ ଗୋଟେ
ଇଏ
ସ୍କ୍ରିନ୍ ଥିଲା
ନା 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 ନା
ଏମିତି
ଏଇଠି
ଥିଲା
କରିକି ସ୍ୱାଇପ ଇଏ କଲା ବେଳକୁ କହୁଥିଲା କିଛି କଣ ପାଇଁ ହିଁ ବୁଝିପାରିଲିନି।
ଠିକ ଅଛି ହେଇଲା ତ କଟିଗଲା କଟିଗଲା
ସେଟା ତ ଛାଡ ଇଏ କରିଦବ ରହିଯା।
ମାଇକ୍ ଟା ଅଫ୍ ମାନେ ସେଇ ଲର୍ନିଂ ରେ ଦିଆ ହବ ମାଇକ୍ ମାଇକ୍ ହଁ
ମୋର
ଆବେ
ତ କିଛି
ଶୁଣ ଆକ୍ଚୁଆଲି ଏଇଠି ଇଭେଣ୍ଟ ଟା ହଉନି ହ୍ୟାଲୋ
ହଁ ହଁ
ମାନେ
ହଁ
ଦେଖିକି
ଆଚ୍ଛା
ସେଟା ପାଇଁ
ହଁ।
Join us someday. There is still no social life without a spiritual life. Let's start a function that brings Almighty. The second of fresh. I would like to welcome you on a simple conversation of everything. Today, we have one speaker with us. First of all, I would like to request Engineer Asifus Dar, EIC Conservation Secretary, Interstate Issue, Government of Odisha, to deliver his speech, and also his service for the society vigorously. He is an expert in GIS. So, in the views of our for Engineer Asifus Das, please welcome to advise. Engineer Asifus Das.
এটা করতে হবে? একটু ঠিক করে যাবে। So microphone is yeah, when the microphone no. Sir, if you print as a copy but knowledge of the copy. Copy career purpose, I will be taking out some of the slides. Because many confidentiality. Okay. And officially not allowed. Many restrictions. Yeah, but there are copy career fully behave copy करते हैं मतलब जैसे डेस्कटॉप पे रखी दो then I can just for खाली just like just for like no it's okay এটা আপনি গোটে লাইভ করো না বেটার এটা মোর সেনসিটিভ এরিয়াটা
नहीं नहीं ठीक है सर
এটা তো লাইভ বন্ধ করে
कोर्ट मैटर का
স্যার লাইভ বন্ধ করে দিও স্যার লাইভ কালকে কি ঢুকছে কোথায় ইউটিউব রে স্যার লাইভ জাস্ট এটা ইউটিউব ইউটিউব লাইভ
ତାହେଲେ
ସେ
ସାର୍
ଗୋଟେ
ଗୋଟେ କାମ କରନ୍ତୁ ଖାଲି ଗୋଟେ ଲାଇନଟେ କହିଦେବା ଯେ ଆମେ ଡ୍ୟୁ ଟୁ କିଛି ମେଟେରିଆଲ ଅଛି ଆମେ ସେଟାକୁ ୟୁଟ୍ୟୁବରେ ଲାଇଭ ଦେଇପାରୁନି ସେ ଜିନିଷଟା ମଧ୍ୟ ଥାଉ କାରଣ ସେ ପଚାରିବ ପୁଣି ସେଠି ଆମେ ବି
ହେଲେ ସାର୍ ପିପିଟା ସାର୍ ସାର୍ ସେ ଲାଇନଟା କହିଦିଅନ୍ତୁ ସାର୍ ଇଟ୍ ଇଜ ଦ ମାଇକ୍ରୋଫୋନ hello so I'm audible to all of you. So, may I take this opportunity to welcome you all to the second day of this particular program, and also I'm thankful to the organizers for giving me this opportunity to be with such a intellectual mass who are actually keen to learn and keen to share their things also with us. And it's also a rare instance where these field people also get a chance to interact with the academia and with those particular people. It is not that a one-way communication of knowledge, it's a both way thing. We also used to learn many things from you. In the area for today, my topic, the thing which I'm going to discuss, is about future of hydrology. Hydrology itself is future of GIS in hydrology. So GIS, it's a vast subject. Basically, if you look at it, then it has pervaded into the escalated threads of each and every variety of specialization. Maybe the doctors also will have started using it. So starting from them, these oceanographic people, all the things who are using the land, space, and time, and anybody who is interested to have a data compilation in multiple layers, data organization, all those people they are now acquainted with GIS. But as far as hydrology is concerned, GIS has a very specific and special role. And in that, the topic that has been entrusted to me is not only this, it is not future of GIS in hydrology for water estimation purpose. Up to this appears to be a academically very sound thing. But after that is some small clause has been attached. from conflict point of view, especially when the entire water resource of a basin of a particular area is under conflict. There are many stakeholders who want to demand their own share. At that point of time, if you are using GIS as a tool to delineate the things, to demarcate the things, to evaluate the things, to estimate the things, at that point of time, what are the new challenges to come up? This is a typical area where I believe that most of you might not have been that sensitivity to look at, and there I wanted to enter. And obviously, the areas which I'll be discussing somewhere or else, I may have to trade into the area which is live now. Some live conflicts also, maybe sometimes it may come out, and which is not actually permissible also. So as far as possible, 99% I'll be trying to keep me out of that, out of my personal capacity, I'll be telling. But still, on that account, it's not so pure to do a complete live with others, complete live with others. Let us confine to this particular room only. Let us make it a personalized business. सर ये सर लाइव बोले सर कल मूवी शो करेंगे सर वो ये शो करेंगे हम पीपीटी टेस्ट शो करेंगे लाइव पे लाइव बोले no sir little okay I have to see from this yes sir I learned sir. Hmm. Yes, sir. So with that artificial introductory remark, which was a requirement for stopping the life and coming back to a business which is amongst us. Now let me start the topic. This is, as I had already introduced you with the topic, the future of GIS in hydrology in the context of estimation of water resources for resolving interstate issues. Yeah, for resolving some of the conflicts, for resolving the stake of multiple stakeholders from a single pool of resource. So in this context, let us start beginning from water. I am not going to tell you start that pani khale doli re bhai hydrologic cycle. All of us know that. But ଗୋଟେ ବଡ଼ ଜିନିଷ ହଉଛି ପାଣିଟା ଆଜିକା ଦିନରେ ଗୋଟେ ସ୍ପର୍ଶକାତର ପଦାର୍ଥଟେ ହେଇକି ରହିଯାଇଛି. The only reason being is that its spatial and temporal distribution is not unique. It is not available where it is supposed to be. It is not available when it is supposed to be. And the climatic change and other things, they have further shifted and they have made much more erratic equations into this. So what is a very vital and scarce resource, we know. And for any economic development, for industrial requirement, for irrigation, for food security, for environmental purpose, for bringing the ecological balance, whatever you may speak, it is only water. Without water, you cannot think of actually giving a fillip into that. Nowhere it will be possible. On the other hand, the demands initially, if you look at 30, 40, 50 years back, now also for our water source people, how they look at water. Water primarily, this is amount my irrigation requirement. Next is slightly put something for the drinking water, almost over. In, even for industrial requirement, people think that this is so minute that there's no need to keep a provision. But on the other hand, the demands are multifarious now. Many varieties of demands have come up. Now, even the new group of demanders are the environmentalists. ମୋ ମଗର ମାଛ ପାଇଁ ମତେ ଏତିକି ଦରକାର for my spawning of this particular breed I need this much depth of water at this point of river for Chilica I need this much amount of water should flow to maintain the salinity gradient. So like this also many new stakeholders have come up, hence the complexity has increased. And how best we can resolve this? By a proper governance and by bringing in a diplomacy. But in order to reach a governance, in order to develop a protocol, in order to develop a diplomatic relationship between the stakeholders, the primary thing is we must assess how much water is available. Who all are the demand stakeholders? How much is whose share? Then only the governance will come. And in this context, how GIS helps us? GIS, apart from its multifarious roles in multifarious disciplines, as far as hydrology is concerned, primarily we are wedded into this GIS. This hydrologist is a new era phenomena that it has the ability to integrate and to analyze spatial data as well as temporal data from various sources, from different formats. Soil data, then supposing NBSS and LUP has given us something, remote sensing people have given us something, land use, land cover data are coming up, rainfall data IMD is giving from 1901, all those gridded version of data, those particular things are available with us. We are having our own point source data, some pollution data, river network data, joint data, connection data, whatever the data may be. This particular software has a terrific ability to put everything into layers, to put everything into a concocted, into a organized manner. So this GIS represents the hydrological cycle and its components in a dynamic manner and in a comprehensive manner. When I mean dynamic, I believe that long back, maybe in the year 96, while I was doing my first work in artificial neural network, any AI, nowadays it has become a common man thing. Basing on the data, the software has been trained and it is actually producing and giving you a result. If the result is acceptable, then believe today again new data is coming up, automatically it goes and the model recomputes the entire thing. Tomorrow morning a better result comes. So this is a dynamism which has already been built into GIS nowadays. So if at all a model you are able to think of integrating GIS into the main thing, then dynamically it now updates itself and gives us the outputs. It has the terrific ability of visualization, exploration, and evaluating the different scenarios. And so much our eyes are also adjusted to an output. Unless something comes in GIS format, those colors, those pictures, those maps, those visualizations, we feel bored. Normally, these statements and lines, people are no more acquainted with that. They want a realistic thing to be modeled in the screen. In that particular shape and format only people want to see. And who else apart from GIS can give you those sort of visualizations? So this is also area where it helps a lot. And this communicates and disseminates hydrological information and knowledge to various stakeholders by creating interactive maps and charts. I've already told about it. Now, before I'm going to the real subject, just having a broad over outline of what I'm going to speak. Taking all these things into account, nowadays there have been many softwares, many packages have been available. People have started using some particular softwares are having more popularity in Australia, like SWAT model. It has recently started coming in. In last 8 to 10 years, our department has made some ventures of educating our people in SWAT, but they have gone halfway and they have stopped. But once upon a time, Primavera, ଆମେ ଯୋଉଟା କରିଥିଲେ ଆମର 2000 ରେ this water resource and water estimation analysis that we had done, something have become obsolete. Those things are not there. But now the present day, supposing somebody looks at it, this water estimation things, primarily you will be looking at, maybe some of you also will be exposed to this. One is a SWAT, one is a Mike 11. I had been trained in the year 91. Mike 21 came. Now this Mike C model, this system hydrologic European, this some particular format they have given. And the most common thing is now HMS model. HMS, because it's a free software, now the students are also doing it. We have also started employing it. And automatically this also imports the data, the DM and etc. Those particular information sheet imports through the net and automatically processes. So HMS is also having a good amount of popularity amongst people. But the most challenging, the most toughest, the thing which still is a challenge for India, that is the VIC model. This VIC is a variable infiltration capacity model. It is going on improving. Now, if you see in the entire world, starting from Thames River, any big river you see, even Tigris, Euphrates, both these rivers, they have also modeled around almost, I know, more than 10 to 12 I have come across. They have now gone into this VIC model. But VIC demands enormous amount of data, enormous amount of information in a layered manner. And every data is so sensitive, any amount of error in that which you cannot catch once you put it, the how the model will behave, we do not know. This has been developed by a professor and 5 or 6 his students, his PhD scholars. but they also were never aware that this will be having so much of popularity. Primarily, how it operates, let us say this. Once our GIS job is over, we give everything in a graded fashion, then this BIC will be doing the dynamic part of the thing. This operates in three different layers. All the things are pertaining to soil only. The full form, from that only you can know variable infiltration capacity. When the rainfall comes down, something will be a seed flow. Immediately it starts entering. Then the capillary action, some amount will be through the permeability, some will be passing, some will be the soil will be saturated, it will be going down, some will be appearing as base flow, and something automatically flow as in a groundwater fashion from upwards down by obeying the Darcy's law, V is equal to Ki. That's how this VIC model operates. Now they have come to the VIC version 5. It basically operates on a three layer, and we have also started thinking for resolving some of the disputes that Odisha has entered into through VIC. And we are searching for experts, searching for persons. If anybody is having expertise also, they're welcome to tell us. But prior to that, may I tell you, in the year 2017, Central Water Commission had undertaken this water estimation job for around 4 to 5 rivers. Out of that, Mahanadi was one, Godavari was one, Krishna was one, three, another two rivers. Therefore, arriving at the water estimated quantity at different dependabilities, they had adopted the big model. So one can actually check it from the CWC website about this big further depths you can get. But now we'll be very shortly coming down only to focus upon GIS. But after the GIS does its job in a grid-shaped manner, somewhere the vector polygon format, somewhere the point format, somewhere the raster format, as this model demand, once we give, then the GIS job is over. After that, everything is being taken over by these models. Find out that result. And when it comes to the resolving the interstate water issues, basically I can think of hmm, giving you a case study, only with one that I have been acquainted with. One name, Bansodhara and some other rivers, but primarily for today's discussion, let us limit it to only this Mahanadi River basin. Some of the points, how ticklish they have become. Some of the things where your assumptions, how dangerous it can be. Sometimes some negligences you are making, how gravely the particular error emerges out at a point, which otherwise is not visible. Unless somebody has the priori idea, or unless a confronter in front of you tells you that yes, there is an error, you can never get an opportunity to see it. These are the some of those particular things only I shall be discussing with you. Before that, let us look at this particular basin. This is what the Mahanadi Basin is. It's interstate basin. Over the transboundaries, it moves. And here you can see there's a black line over here. This is the boundary. You must be able to see. In this boundary, below part is Odisha, upper part is Chhattisgarh. Apart from these two, there are some other three separate states also, very small state they do have. Who those states are? On this side, there is a Jharkhand, a small portion. At the top, you can see the small portion Madhya Pradesh. Madhya Pradesh is also there. So they are also a stakeholder into this. They have their own claims for that also out of this. Supposing this entire thing is 1,44,000. Out of this 1,44,000, the Odisha saves something around 47%. And Chhattisgarh is 53%, 52.97. Others are also there to put their stake. So from these five different stakeholders putting their claims over the basin, over its water, and for that we have invited GIS as a tool, come and support us. Tell us what is to be done and what is not to be done. And in that, some of the stories which are developed. And IIT Mumbai, IIT Delhi, almost all the GIS unit and professors, 2 or 3 GIS institutes, they have also worked very hard in resolving these particular things in the last 1 to 2 years. So let us see, this problem basin is a transboundary basin that covers many states in India. This spatio-temporal yield is the amount of water available in the basin at different locations at different points of time. Both the things are sensible to us. Total how much amount of water is available. If you want to break it up into months or into monsoon and non-monsoon period, during this period, how much this basin is able to generate, how much this basin carries from the monsoon to the non-monsoon. These are the questions for which we have relied upon GIS for the carryover part. And the tribunal has adopted a GIS-based approach for estimating the spatio-temporal yield. This time, the adjudication process has insisted that because of the technology has advanced, we no more shall be confined to the conventional modalities of conflict resolution. We shall be adopting GIS. Everything should be on the screen, on the paper, in calculation, black and white. So for that, our first challenge came from the projection system. I have heard from Anil that most of you have awareness and exposure to the GIS part. Then you must be aware what is a projection system. What is the projection system normally you adopt when you are going and bringing it in? Normally, what is a projection system? I think most of you are aware. Can somebody raise their hands? What is a projection system? आठटा होची कमला लेंबू परी गोल बट आमे जदि ता देहर जदि बापजुप करबा ये जहा जहा बाहर करबा इट हैज टू बी इन ए 2D फॉर्म बट आर्थ इज नॉट 2D आर्थ इज ए 3D से 3D अगेन कोठी केमती चेपटा 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 कमला लेंबू परी गोल बोधे पिला बेले पाठ पढ़थिले and that at the pole it suppresses down and there is again a flatter area just like a mound. So the pole again is keeping some different challenges. ताकू divide करिचे how they say ଆପଣଙ୍କର latitudes and longitudes. Meridian ପାଖରେ ଆମେ rings ବୁଲେଇ small curvilinear squares you have prepared. So GIS ରେ whenever anything you think of the number one thing is a projection system. ଏମିତିଆ ଜିନିଷର ଖଣ୍ଡେ ଆମେ କାଟୁଛେ ତାକୁ ପ୍ରଥମେ flat କରିବାକୁ ପଡିବ. Unless you make it flat, only make it on the paper, how can you do what is the length, what is the 2D? Because this does not have a length. 3D length and 2D length are different. This is where the projection system comes into picture. Most probably, and most of us, while doing a GIS job, by default, starting from ArcGIS, we go for UTM. Our Google Earth, they have given, do you need the things in UTM projection or a normal 3D projection? So UTM has become a buzzword now. But this UTM, which otherwise anybody who is aware about GIS, everybody must be aware about the UTM. Universal Transversal Mercator projections, a particular methodology is that. But see, in our case also, we started with that. And what are the challenges we faced? So after that, we could come to know that at opposite of 1960, 1970, what it was mentioned, Lambert conical conforming projection system, a word was coming up. Then somebody told some Albert's equal area projection method. Then we got it something like a Robinson method. Robinson method. So many terminologies we got exposed to. But out of this again, what is to be taken? For that, maybe more than 3 months, more than 20 hours of discussions, deliberations. After that, we could confirm that, no, at this, let us settle. Because any app, any application who attempts to do this thing into this thing into this, a 3D into 2D, there is an error. Nothing, a ball, ଗୋଟେ ବଲ୍ ଟାକୁ ଖଣ୍ଡେ କାଟିଦିଅ ତାକୁ ସିଧା କରିବା ପାଇଁ ଚେଷ୍ଟା କର କେବେ ବି ସିଧା ହବ ନାହିଁ ଟିକେ ଟିକେ ଫାଟିବାକୁ ପଡିବ ରବର ଟିକେ ଟିକେ so because I am going to do this particular stretch any projection system is bound to incorporate some of the errors so which particular projection system minimizes the error for my requirement that will be the primary thing you have to think of whenever you are starting a GIS project. Anil, are you able to appreciate what I am telling? So always a map projection causes a distortion and no map projection is flawless. I have already told you. Isn't it if you do a Google, more than 100 types of projections are available. Even you go to ArcGIS or QGIS, they're also giving you many number of projection systems. It's up to you to decide how to know which projection system is best for me. And every algorithm for this projection system attempts to preserve one particular quality. Some attempt to do, supposing my interest is from Rautla up to Sambalpur, the distance, whatever is being now measured through my bicycle, through my motorcycle, exactly that thing my GIS should give. That means my intention, the distance integrity has to be preserved. Somewhere, I want this area Hirakul's reservoir area, that area part has to be remain constant. So area integrity is primary. Direction and length integrity may change. So depending on where I want to put my focus, you have to choose your projection system. The preserved property of a map projection is often included in its name, Lambert conformal conic projection or Albers equal area conic projection. Equal area, that means area part will be kept intact. Directions, some distortions will be there. The shape, some distortion will be there. But as well, the entire area, if you measure, be sure whatever you are getting it measuring 2D, this 3D part also on computation will be giving you the same thing. So there are many issues we have come across. I am just showing you. Primarily theoretically, supposing you look at Earth is a goal thing. आप आई बोले कि जितनी जो 100 different types of projections are there, you can divide them into these three different things. One is a cylindrical projection, one is a conical projection, one is a planar projection. Planar thing means at the bottom you are able to see simply the ball, it is opening up by means of some centralized meridians, it's opening. So this is maybe highest amount of error, supposing big area you will take. And we shall be talking about this cone. से बॉल टाकू एनक्लोज करिके जो कोन पे तैयारी हला ठीक दिस इज द प्राइमरी मेजरमेंट आ देर मु बटन काटी देबी इचु काटी देबी सेट काटी देबी ताको ओपन करी these conical projections are basically too good for simultaneously preserving the directional distortion minimization and area distortion minimization. So basically conicals people prefer. So let us a bit more into the projection system we shall be going. The UTM part I have already told you. This Lambert thing, this also maps the mid-latitude areas. Albers also is more effective. This Albers equal area conical projection method, this is also very effective in this mid-latitude area. And where the entire area is east and west. आ महानदी बेसिन देखिए मोस्टली ईस्ट वेस्ट पार्ट रे ही बेसिकली लंबिकी रही आ जो माने आपनकर जो नॉर्दर्न हेमिस्फियर रो मिड लैटिट्यूड पाखरे जो एरिया गुडा गछंती semanunko case it has been seen now that Albers conical equal area projection method, this actually that minimizes the distortion mechanisms. Let us see UTM. UTM is a default thing. What is a UTM? UTM रे आपण जमन जानिथिबे जे एंटायर पृथ्वी होची 360 डिग्री रो गोटे गोल ताको डिवाइड कर देले 6 डिग्री इंटरवल रे ताको विभिन्न पीसेस 60 नंबर्स ऑफ पीसेस हैव बीन प्रिपेयर्ड एंड स्लाइसेस हैव बीन मेड तापर एपट साइड रे 1 डिग्री 1 डिग्री 1 डिग्री गोटे क्यूब बनै बनै गले हेरी सो फॉर एवरी क्यूब 1 degree is to 6 degrees तापे गोटे फार्मूला तैयारी करदेले सो दिस फिट्स बेस्ट फॉर दिस एटा पे बोले आ टिके मुड़ी जाय छै ठीक आपे आ गोटे फार्मूला करले सो सेति में once you tell UTM projection system where your lat long is it first identifies your square अपन को lat long रे अछंती तापे जो इक्वेशन अछि that equation it puts and your area is almost it gives a very good result. But imagine a case which I am showing you now. If you need to have process a very big area which is not confined into a single UTM zone, because our Odisha and especially our Mahanadi basin, this comes into two zones, UTM zone 44, UTM zone 45. Here also a discussion came up. If this line would have been slightly towards right side, if most part would have come into 44, let us do for UTM 44 and small errors will be there in this lower portion we can manage. But now unfortunately here, this side is also not small. If I am doing UTM 44 equation, the error part in this will be more. If I am doing the UTM 45, error will be accumulated here. So basically, whether to go to UTM, a conventional thing, or should we think of out of 100 from the family of projection, which one to choose? It was a big challenge for us. And see, here also this particular thing we have arrived at. Supposing entire Mahanadi basin, I am doing with UTM 44. Our problem basin is approximately 1,45,000. But if I am doing it one UTM 45, it is 1,45,426, around 400 square kilometers error. It may appear in 1,45,000 square kilometers, 400 square kilometers, very marginal. But this may be from academic point of view. This may be from your PhD and thesis point of view. But from conflict resolution point of view, when each and every bit of area, inch of area is more important. So minimization means fully optimally the error minimization with the best available technology. That is the goal up to which you have to go. Supposing I do it with Lambert conformal conic, This reduces by around 6,000 square kilometers. And no, it's Lambert conformal. Albus conical, it gives 1,44,885. So this projection is just like a Lambert conformal, but the beauty of Albus conical projection is others are having actually they keep a one single reference line, then this area is inserted above that. In the single line is a benchmark for them. They used to calculate always the error should be minimum here. So for some error will be there, some error will be here. Albus conical, what it does, it actually puts one line at the top and one line at the bottom. So two lines, your entire problem area is put inside it. So because these two lines are error free, so most probably the inside area also will be error free or minimal amount of error. That's why finally we had chosen albus conical. And apart from that, here also a big challenge came up. If you have done the projection system, then only you can understand. Anybody only who has been exposed to, they only can know what is the meaning of this false shifting and false nothing. In AutoCAD also, universe normally we say 0, 0, but if my problem area is here, I sometimes shift my axis to that particular point. So this is a false shifting and false nothing. Depending on how much amount you give for false shifting, false nothing, results do differ. It's a very, very, very peculiar thing. ଯଦି ଗୋଟେ ଜାଗାରେ 3 ଅଛି କୋଅର୍ଡିନେଟ୍ 5 ଅଛି, the calculation is 3 3 9 5 5 25 9 plus 25 root over this is the length. But supposing I put a 2 lakh as a false nothing and 2 lakh false listing, এটা হচ্ছে 2 লক্ষ 3, এটা হচ্ছে 2 লক্ষ 9 কি 2 লক্ষ 5 2 লক্ষ 9 তার root over is something different than that of 3 ଆଉ 5. So while choosing the false listing and false nothing, some new things we have learnt, some I have mentioned here, but it should always be as minimal as possible. Don't try to over emphasize these particular values because the error margins will be increasing. After deciding about the projection method, the biggest challenge what came to us is choosing a DEM, the digital elevation model. How many of you are actually have taken the pain of downloading a DEM? How many of you have done? What you have done? Which particular DMs, madam? DEM, what is the source you have adopted? Bhuvan said, Bhuvan is not the authority to give a DEM. Who has done the DEM? USGS is again a platform which actually gives you the Dukan Tasida. Huh? SRTM. Anything else? Anybody else is having any data? You have done Aster? Huh? Based on that, even after so much of development, there are only two different experiments have been done. One is a SRTM in the year 2000, another one is a Aster, where a global DM is available. And Aster actually has come as a leg point entrant to challenge the SRTM. Its accuracy, its resolution is much better. These people are giving you a 30-meter resolution. Aster is also giving 30 meter. They have much more different machineries, but the people for somehow or other are not preferring. In some papers you will be seeing some people prefer Aster, some prefer SRTM. There are many a number of papers who have only purpose in the paper is to compare Aster and SRTM and how much they correlate with the ground reality. And most of them have proved SRTM to be a better option. So what is this? What is this DM, digital elevation model? Any particular point should be, if we know the x coordinate, y coordinate and the z coordinate of it, that means we can do a survey. That is the objective of a survey. So this is the SRTM is almost a buzzword. But this SRTM is also not free from defects. Quite long since 99, since 2001, 2002, we have started using SRTM. By that time, what they were doing? For America, they were giving 30-meter resolution DM. For rest of the world, they were giving free 90-meter DMs. We were working with the 90-meter DMs. Now they have done entire world 90 meters, for America 6 meters. For those particular people, only for America, inside America, you can get for 6 meters. For the rest of the world, you are getting it 30 meters. And this SRTM data, many units, they have taken it, reprocessed it, reconditioned it, and on their platform, they are also giving it. So we are having many opportunities, many places from where you can borrow the data. But the most authentic platform is USGS. So in our case also there is a big challenge come up whether to go for Aster, whether to go for SRTM. Then we went on doing our opponents. They also started doing how it is actually correlating with the ground reality. They are also having their own limitations. Some particular DM gives you better accounting for the total area, no error. Delineation, no error. But for while delineating subbasins, it is giving error. Some actually even subbasin delineation, no error. But while you are analyzing the morphometric property of a basin, how the slope is changing, how the river networks are moving. There, somebody matched well, somebody did not match well. So many parameters one by one after testing, we could conclude that for our problem basin, for somehow in comparison to Aster, SRTM is a better option. But it may be different for your case. So if somebody wants to do it a very detailed thing, please obtain a Aster, obtain a SRTM. You are having from your topo sheet, from your ground realities, you have some particular information. Please have a comparison which is giving you the better result. Adopt that. In our case, what happened? Both the DMs, they almost gave similar results, only with respect to the river network. Slightly SRTM did better, so we went for the SRTM part. And these are the tests we have done there. In order to test it, like this, these are the parameters, mostly some of the morphometric parameters of the basin. You can say some of the area features, some of the length features. I presume that these are the area things you know, like the stream order. While calculating the stream order, the differences we tested, the bifurcation ratio, there also we have tested the drainage density. This is a very important area, very important parameter for a basin, the drainage density. The maturity of a basin is signified by this. If a particular basin is old enough, stable enough, its entirely density pattern is finalized. So drainage density will be a bit higher because each and every land parcel knows ମୋ ଉପରେ ଯଦି ପାଣି ପଡ଼ିବ ମୁଁ କୋଉପଟେ ପାଣି ଛାଡ଼ିବି. It's a defined channel. But if relatively a basin is younger, still many things have to happen, many new channels have to open, many bifurcations have to be made, many distributors have to be made. In that case, Mahanadi Delta is still going on forming. 20 years back, the delta and today's delta, they are different. That also we can observe. We have also done slope, flow direction, aspect maps. In each and every parameter we have tested. Now comes the DM is now available with us. We started processing this a particular sequence. Any hydrology tool you go, step 1, step 2, step 3, one by one, fill sync, then this, then direction raster, this raster, accumulation raster, stream linking. After stream linking, you should delineate. After delineation, what we found that both of us reached at two different sets of results. And our adjudicator, they also were doing it NIT Warangal. By putting those particular, they also started coming up. They have altogether a different result set. So why such a thing happens? And mostly those errors were confined to our portion, not in the upper portion. The lower portion of Mahanadi, those errors got confined. At that point of time, again we went on reading RGIS, the manual, then the RGIS tool, ArcHydro, why the error is coming up, why it is not, we are not confined to that. At that point, we saw that this SRTM data from the original source, if somebody brings, then at some particular small points, the data, there's no data. There are some no data zones, which normally are not visible. I'm showing you here in the right, not going there. I'll be going there just now. There are some voids. What is a void? Normally, any pixel is having a x value, a y value, and a z value. If a particular pixel does not have a x value, y value, and z value, ମୋ time ରେ ମୋତେ ଆଗରୁ କହିଦେବେ 15 ମିନିଟ୍ ଆଗରୁ 20 ମିନିଟ୍ ଆଗରୁ ମୋତେ କହିଦେବେ I'll be completing that. ଯଦି କୌଣସି ଜାଗାରେ value ନାହିଁ, that is called a void. And if a void is there, a null value is there, then the software cannot process that particular point. So anything comes from top being processed, it will stop there. And from the bottom, a new thing will start. So in this way, there is no consistent result of what you are doing and what I am doing. So what you got it, sir. So this void actually, what type of problems we faced, that I want to show you. Here we found out that in the Arc toolbox, there is a, in the image analysis, there's a void fill function. And this for this void, there are two options again, 0 and fill all. Out of that also, suppose if 0 you do, the void filling will be done. Fill all thing, it will be done. But fill all actually does the thing in a synchronized manner. If it is 0, it brings all the values to 0. That is not what we wanted. I am unable to ବୁଝିପାରିଲେ sir? Because there is no value. If you put a fill void option, all the values a particular number it will give, that number is 0. That means 188 ର profile ଅଛି, ଗୋଟେ point ରେ data ନଥିଲା, that point is 0. ଗୋଟେ infinite hole ହେଇଗଲାନି ସେଠି। ତାପରେ ବି ଦେଖିଲୁ ଯେ fill all option ରେ it actually does a algorithm and it computes it. You see a small box I have done in this lower portion of this basin, and in this portion some of the streams that we know, Dahuka, Kusumi, ଏପଟ ସାଇଡ୍ ର ସାପୁଆ, ଯୋଉ ନଦୀ ଗୁଡା ବହୁତ ଆକ୍ୱେଣ୍ଟେଡ୍ ଡେଲ୍ଟାରେ ବୁଲି ବୁଲିକି ଆମେ ରହିଛୁ କରିଛୁ, ସେ ରିଭର ଗୁଡାକ ଆଉ କିଏ କନେକ୍ଟେଡ୍ ହେଲେନି, ଆସିକି ଲାଗିଲେନି। କଣ ପାଇଁ ଲାଗୁନାହାନ୍ତି ଖୋଜୁ we could find ଏଇଟା ବୋଧେ 2000 ଅକ୍ଟୋବର ମାସର 23 ତାରିଖ ଦିନ 24 ତାରିଖ ଦିନ ଯେତେବେଳେ ବୋଧେ ଏପଟେ ସେଟେଲାଇଟ ବୁଲିକିରି ଯାଇଛି ଫର ସମ ରିଜନ, କିଛି କ୍ଲାଉଡ ପାଇଁ କିଛି କଣ ପାଇଁ ଏଇ ଜାଗାରେ କିଛି ପଏଣ୍ଟ ପୃଥିବୀ ସାରା ଥିବ ଆମେ ଜାଣିନୁ। ଆମେ ଏଇଟା ଖୋଜୁ ୱାଇଡ କରୁ ସି 1,44,000 is a very complex DM. It's a very difficult thing to search first ki where actually these voids are there. We went on expanding and expanding. We could find out this culprit. We could identify after say 15 to 20 days of exercise. These are the points. Here some voids are there, the null values are there. So once we got it, then we could resolve it. We could explain to the other side that this is the reason why we are unable to reach you. So what happened that because of a void, you can very much see a typical thing. See, this is stream. This stream was supposed to go down. This particular stream stops here. This particular stream, because there is a void, this stream was unable to getting joined. So some independent river pocket who do not have a beginning and do not have an end, they will be generating. And normally in the left side drawing, from this you cannot study that whether such unlinked stream networks are there or not. ବୁଝିପାରିଲେ sir? ଆପଣ ଜାଣିପାରିବେ ନାହିଁ, ଦିଶିବ ନାହିଁ। So this is a method କୋଉ ମାନୁଆଲରେ ଲେଖା ହେଇନି, କୋଉ ହାଇଡ୍ରୋ ଟୁଲରେ ନାହିଁ ଯେ ଆପଣଙ୍କର void fill function ଫାଷ୍ଟରେ କରିକି ତାପରେ ପ୍ରୋସେସ କରିବେ, but it is obligatory upon us now because of ଏଭଳିଆ difficulty। ଏ difficulty ଦିଶିବ ବି ନାହିଁ ବାହାରକୁ, ଫଳରେ କଣ ହବ, ଦି ଷ୍ଟ୍ରିମ୍ସ ଅଲଗା ଷ୍ଟ୍ରିମ୍ସ ବି ତିଆରି ହେଇଛନ୍ତି କିନ୍ତୁ ଯୋଡି ହେଇନାହାନ୍ତି, କଣ୍ଟିନ୍ୟୁଟି ସେମାନଙ୍କ ଭିତରେ ନାହିଁ। The length part will be changing, drainage density concept will be changing, stream orders ରେ reflection ଆସିଗଲା, at many different places reflect କରିବ ଏଇଟାକୁ। So you need to have a void fill function in this place। And see after the continuity is a pre-processing ଆମେ କଲୁ ଏଠି, କଲା ପରେ ଆମେ ଦେଖିଲୁ at many places the things got resolved। we could get a continuity ଯାହାକୁ ଧରିଲେ ମଧ୍ୟ ସେ ଯାଇକି ପଢିବା କଥା lower order ଆସିକି higher order ଯାଇ and the river network ଆମେ ପାଇଲୁ, and discontinuity part is lost excepting one or two। but prior to that you see ଆମେ ଜାଣିଲୁ କେମିତି, ମାନେ how could we come to know that ଏମିତି ଗୋଟେ ଛୋଟ ଗୋଟେ ରହିଯାଇଛି କିଛି ସ୍ନାକ୍ସ ଭିତରେ ଯୋଉଥିପାଇଁ ପ୍ରୋବ୍ଲେମ ହେଲା। ଏ ତିନିଟା ଏରିଆରେ ଆମେ ଦେଖିଲୁ ଯେ around 2,400 square kilometers of area is not coming within the basin। overall boundary ମାପିଲେ ଦେଖଉଛି, but ଏମାନଙ୍କର କାଲକୁଲେସନ କରିକି ଆସିଲା ବେଳକୁ there is a gap, because ଏ ଯୋଉ ସାପୁଆ ଲେଫ୍ଟ ବ୍ୟାଙ୍କ ଗୋଟେ ରିଭର ଅଛି ସାପୁଆ, ଏପଟେ ତଳେ ଥିଲା ଗୋଟେ ଡାହୁକା କୁସୁମୀ, ଆପଣ ସହିତ ରିଲେଟ କରିପାରୁଥିବେ ମାଇଣ୍ଡରେ, ଏଇ ପାଖରେ ଯୋଉ ରିଭର, ଏଇ ରିଭରଟା ଦିଟା ଏଇ ଷ୍ଟ୍ରିମଟା, ଏମାନେ ଯାଇକି କନେକ୍ଟେଡ ହଉନାହାନ୍ତି, ଖଣ୍ଡିଆ ହେଇକି ପଡିଯାଇଛନ୍ତି। ତାର ଟୋଟାଲ ଯେତିକି ଏରିଆ ସେମାନେ ଆକାଉଣ୍ଟେଡ, ଏନି ପ୍ରୋବ୍ଲେମ ଅନିଲ, ଯୋଉମାନେ accounted for ହେଇପାରିଲେନି, ଆମେ ଦେଖିଲା ବେଳକୁ approximately in these areas around 2,400 square kilometers of catchment was not accounted for। then again we went back to a much earlier stage, identify, discuss, rediscuss, filled up the voids, most of the problems it resolved, but one problem still remained, that is the sapua part। at this point a new concept we have been exposed to। ମୁଁ ଗୋଟେ ପରେ ଆପଣଙ୍କ ପାଖକୁ ଆସୁଛି ଏଠିକି, ତାପରେ ଯିବା। let me speak only। ଏଇ କଣ୍ଡିସନରେ ହେଇଛି କଣ, ଯୋଉ ସାପୁଆ ବୋଲି ଗୋଟେ ରିଭର ଅଛି ଯୋଉଟା ଆସିକିରି ଆମର କୋଉ ପାଖରେ ନରାଜର ଜଷ୍ଟ ଉପରେ, ନରାଜ ବ୍ୟାରେଜ, ନରାଜ ଇଜ ଏ ପଏଣ୍ଟ ଇନ ମହାନଦୀ ଯୋଉଟା ଆମ ଡେଲ୍ଟା ସିଷ୍ଟମ ଷ୍ଟାର୍ଟ ହଉଛି, କାଠଯୋଡି ଆରମ୍ଭ ହେଇଯାଉଛି, ବାଙ୍କି ଭିତରେ ଆସିକି ଜଷ୍ଟ ସେ ପାଖରେ ନରାଜ ଉପରେ ସେ ନଦୀଟା ଆସି ପଡିଛି। ଆପଣ ଗୋଟେ ମ୍ୟାପଟେ ଅଛି ଆଗରେ ମୁଁ ଦେଖେଇବି, ହାର୍ଡଲି 3 to 4 slides ahead what nuisance the software is doing। ସେ ପାର୍ଟଟା ଦେଖେଇବୁ, କିନ୍ତୁ ଫର୍ଷ୍ଟ ଯେତେ ଚେଷ୍ଟା କଲା ପରେ ମଧ୍ୟ ଆମେ ଦେଖିଲୁ ସେ ନଦୀ ଆସୁଛି, ଆସିକି ଯୋଉଠି ପଡିବା କଥା ସେ ପାଖରୁ ବୁଲି ପଡୁଛି, ବୁଲିକି ଯାଇକିରି ହାର୍ଡଲି 3-4 କିଲୋମିଟର ତଳେ ଆଉ ଗୋଟେ ଜାଗାରେ ହିଁ ଯାଇକି ଜବରଦସ୍ତି ପଡୁଛି, ଏଇ ପାଖରେ ଆଉ ପଡୁନି। and that is hardly this much distance। ଆରେ ଏତିକି ଡିଷ୍ଟାନ୍ସ 30 meters or 40 meter distance, ଏଡ ବିରାଟ ମହାନଦୀ ଭିତରେ, but what is the problem? ସାପୁଆର catchment ହଉଛି imagine ସାପୁଆର catchment ହଉଛି 900 square kilometers 893 square kilometer ପାଣି ଧରିକି ଆସୁଛି ଆସିକି ଯୋଉଠି ପଡିବା କଥା ସେଇଠି ନ ପଡିକିରି ଟିକେ ଆଗରୁ ବୁଲି ପଡିକି ଯାଇକି 4 କିଲୋମିଟର ତଳେ ପଡୁଛି and what is the fuck କଣ ସେ ତ ନଦୀରେ ପଡିଲା ନା it may be coming to your mind but see this is Naraj above Naraj this entire Mahanadi basin is having a tributary nature what is a tributary nature of a basin ପାଣି ଗୋଟେ ପଡେ ତା ବଡ ନଦୀକି ଯାଏ ତାପରେ ଆଉ ଗୋଟେ ବଡ ନଦୀ ଯାଏ ତାର ମହାନଦୀକି ଆସେ ବଟ୍ ଡେଲ୍ଟା ଯୋଉଠୁ ବିଗିନ ହେଲା ପାଣି ଯୋଉଠୁ ଆସେ ସେଠୁ ଗୋଟେ ଭାଗ ହୁଏ ତାପରେ ଆଉ ଥରେ ଭାଗ ହୁଏ this anabranching what is this anabranching and anastomizing okay এটা খুলি ଯାଏ so ପାଣି ଯଦି ଉପରେ ପଡୁଛି it's accountable for ପାଣି ପାଣି ଯଦି ତଳେ ପଡୁଛି ସେ ଡେଲ୍ଟା ଭିତର ପାଣି ସେ କୁଆଡେ ଫାଟିବ କୁଆଡେ ଯିବ nobody knows so this is a point of argument tomorrow morning it may come delta ର behavior is different mainstream behavior is different so ସେମାନେ ଲାଗିଛନ୍ତି ଉପରେ ପଡୁଛି ଉପରେ ପଡିବା ଦରକାର software କହୁଛି ତଳେ ପଡୁଛି ହେଲା ଆଗ ପଛ ଭିତରେ many rounds of visits we have made to resolve what is to be done ଦେଖିଲା ବେଳକୁ ହେଇଛି କଣ ତା ପଛରେ ଗୋଟେ ବିରାଟ କାହାଣୀ ଅଛି can I take 2 minutes now ବୋର ହେବା ପାଇଁ ବୋଲିକି କଣ ହେଇଛି କଣ ନାହିଁ ଦେଖିଲା ବେଳକୁ କଣ ଗୋଟେ ଦେବତା କିଏ ଥିଲେ ସିଏ ଗୋଟେ କଣ ଋଷିଙ୍କୁ କଣ କଲେ ସିଏ ଅଭିଶାପ ଦେଲେ ସିଏ ଗୋଟେ ସାପ ହେଇକି ଥିଲେ ସିଏ ଯେତେବେଳେ ବିମୁକ୍ତ ହେବେ ମୁକ୍ତ ହବା ପୂର୍ବରୁ କହିଥିଲେ ଯେ ଗୋଟେ ବହୁତ ଦିନ ପରେ ଏଇଠି ଶ୍ରୀକୃଷ୍ଣ ଆଉ ଅର୍ଜୁନ କଣ ଭୀମ ଆସିକି ପହଞ୍ଚିବେ ସେମାନେ ଯଦି ତୋତେ ଆଶୀର୍ବାଦ ଦେବେ ତାହେଲେ ତୁ ସେଇଠୁ ଯିବୁ କଲା ପରେ ଭୀମକୁ ପଠେଇଥିଲେ ଶ୍ରୀକୃଷ୍ଣ କଣ ସେ ଯୋଉ ମହାନଦୀ ସେପଟୁ ସେ ଜଙ୍ଗଲରୁ କାଠ ଆଣିବା ପାଇଁ ଇଏ ତାଙ୍କୁ ଦେଖିଲା ଚିହ୍ନିଲା କଲା ପରେ ସେ ତାକୁ ପ୍ରତିଜ୍ଞା କରେଇଲେ ଯେ ତୁ ଯଦି ମୁଁ ଆସିଲା ପର୍ଯ୍ୟନ୍ତ ଯଦି ଶବ୍ଦ ମାନେ ମୋ ପଛରେ ପଛରେ ଆସିବୁ ଆସିକି ମୁଁ ତତେ ନେଇକି ଯିବି ମୁଁ ପଛକୁ ଅନେଇବିନି ସେ କହିଲା ମତେ ଦେଖିବାକୁ ହବନି ତାକୁ କି ଦେଖିଦେଲେ ତାର କଣ ଆଉ କେତେ ଅୟୁତ ବର୍ଷ ନା ଲକ୍ଷ ବର୍ଷ କେତେ ତାର ଥରେ କଣ ଅଭିଶାପ ବଢି ଯାଉଥିଲା ସୋ ସାପ ହେଇକି ସେ ଆସୁଥିଲା ଇଟ ୱାଜ କମିଂ ଲାଇକ ଏ ସ୍ନେକ୍ ଶବ୍ଦ ଶୁଭିଲାନି ଇଏ ପଛକୁ ଅନେଇ ଦେଲେ ଯେମିତି ପଛକୁ ଅନେଇ ଦେଲେ ସେ ସାପ ସେଇଠି ହେଇକି ରହିଗଲା ସେ ଯୋଉ ତାର ଯୋଉ ମୁଭମେଣ୍ଟ ଯୋଉଟା ହେଲା ତାପରେ କୃଷ୍ଣ ଆସିକି ଆଉଁସି ଦେଲେ ସାପ ପଳେଇଲା ତାର ଯୋଉ ଟ୍ରାକ୍ ଟା ଅଛି ଦ ଟ୍ରାକ୍ ଇଜ କଲ୍ଡ ଦି ସାପୁଆ ପ୍ରକୃତ ତା ନାଁ ହଉଛି ସାପୁଆ and after 3 or 4 slides I will take you ବୋଧେ ଆସିବ ସେଇଟା ନହେଲେ ଗୁଗଲ କରି ଦେଖିଦବ ଏବେ ସାପୁଆ ରିଭର ଏକ୍ଜାକ୍ଟଲି ଲାଇକ ଏ ସ୍ନେକ୍ ଗୋଟେ ଅଳ୍ପ ଟିକେ ଡିଷ୍ଟାନ୍ସ ଭିତରେ ବିନା କାରଣରେ ଗୋଟେ ନଦୀଟେ ପୁରା ଏମିତି ସାପ ହେଇ ଆସି ପଡିଛି ସେ ଯୋଉଠି ପଡିବା କଥା ସେଇଠି କଣ କରୁଛି ବିଚାରା ଆମର ଆରଜିଆଇଏସ୍ ତାକୁ ସେଇଠି ନ ପକେଇ ତଳକୁ ଠେଲି ଦଉଛି ତାକୁ ବି କାହିଁ ଠେଲୁଛି ଆଇ ୱିଲ୍ ବି ଟେଲିଂ ୟୁ ଦ୍ୟାଟ୍ ପର୍ଟିକୁଲାର ଷ୍ଟୋରି ସୋ ଏଇଠି ବର୍ତ୍ତମାନ ହେଲା ଯାହା ହେଲେ ବି ତ ପଡିଲାନି ତାକୁ କଣ କରାଯିବ ସେଇଠୁ ଯଦି ନ ପଡିଲା 895 ସ୍କୋୟାର କିଲୋମିଟର ପାଣିକୁ ବର୍ତ୍ତମାନ ମହାନଦୀ କ୍ୟାପଚର କରିପାରୁନି ଆପରେ ଆମେ ଯିବୁ ଭିକ୍ ମଡେଲ ନହେଲେ ଆପଣଙ୍କର ସ୍ୱାଟ ମଡେଲ ଯୋଉଠିକି ଯଦି ଯିବୁ ସେ ମଡେଲରେ ବି ସେଟା ଆକାଉଣ୍ଟ କରି ହେଇପାରିବନି ଆମେ ତାକୁ ଅଲଗାରେ ମଡେଲରେ ଦେଇପାରିବୁନି ଦିସ୍ ଡିସାଇଡ ହେଲା ଦିସ୍ ସ୍ମଲ୍ ବେସିନକୁ ପ୍ରୋସେସ କରିବା ଅଲଗାରେ ସେ ପାଣିଟା ଆଣିକି ମିଶେଇ ଦବା that also will not be done କେତିକି bifurcate ହବ କେତିକି divide ହବ so at any cost it was a challenge we wrote to the SC RGS କୁ ପଚାରିଲୁ ସେମାନଙ୍କୁ କଣ କଲେ ତମର ହବ ଏଇ ଜିନିଷଟା they told that in our latest version we have added a new concept ki sometimes for some reason if your digital elevation model that you are relying on that is not ours ST ର ନୁହଁ ସେଟା ଆପଣ ଯୋଉ satellite data କୁ rely କରିକି ଆପଣ କାମ କରୁଛନ୍ତି if it is unable to make your reality ground reality at some particular point like ତମ ଘର ସାମ୍ନାରେ ଗୋଟେ ଛୋଟିଆ ନାଳଟେ ତମେ ଖୋଳିକି ଦେଇଛ ତମ ସାଇଟ୍ ଆଗର ମଇଳା ସେପଟେ ଯାଉଛି ପାଣି ଯାଇକି ନଦୀ ପାଖରେ ପଡୁଛି ସେଇଟା ତ ତମର DM ଦେଇପାରିବନି but you want your model to accommodate that how you will be doing that ନା ସେଇଟାକୁ ତମେ ଗୋଟେ ଟ୍ରେସ୍ କରିଦବ ତାକୁ GIS based spatial mode of tracing କରିଦବ ଟ୍ରେସିଂ କରିକି ତମର ଯୋଉ ମଡେଲ ଅଛି ତା ଦେହରେ ତାକୁ ସୁପର ଇମ୍ପୋଜ କରିଦବ କହିକିରି ଯେମିତି ଆମେ ୱେଲ୍ଡିଂ କରୁଛୁ ଲୁହାରେ you ask ArcGIS a model you burn it ଆସ ତାକୁ ଇଣ୍ଟିଗ୍ରେଟ କରିକି ୱେଲ୍ଡିଂ କରିଦେ ସୋ ତମ ଇଚ୍ଛା ଅନୁସାରେ ସେ ଗୋଟେ ନଦୀ ଗୋଟେ ବନେଇକିରି ଯୋଉଠି ଦରକାର ସେ ପାଖରେ ପକଉଛି ହେଲା that is called process of burning got it ଇଜ ଇଟ୍ ଇଣ୍ଟରେଷ୍ଟିଂ ନା ନାଇଁ ଏ ପାର୍ଟଟା ହଁ ସାପୁଆର ଏତେ ବଡ ଚ୍ୟାଲେଞ୍ଜକୁ ରିଜଲ୍ଭ କରିବା ପାଇଁ ଦି ଅପୋନେଣ୍ଟସ୍ ଦେ କେମ୍ ଅପ୍ ୱିଥ୍ ଦିସ୍ ଆଇଡିଆ ଅଫ୍ ବର୍ନିଂ ସେମାନେ କଥା ହେଲେ ଏସ୍ସି ସହିତ କଲେ ଯାହା କଲେଣି ଦେ କେମ୍ ଅପ୍ ୱିଥ୍ ଦ ଆଇଡିଆ ଦିସ୍ ପର୍ଟିକୁଲାର ଥିଙ୍ଗ ଇଜ କମିଂ ଅଣ୍ଡର ରିକଣ୍ଡିସନିଂ ଅଫ୍ ଏ DEM ରିକଣ୍ଡିସନିଂ ସେଇ ଫର୍ମାଟ ଅଣ୍ଡରରେ ବର୍ତ୍ତମାନ ଆଭେଲେବୁଲ ଅଛି RGIS ରେ ଇଏ କିନ୍ତୁ କଣ କରୁଛି ଫିଲ୍ସିଂ ଜାଣିଥିବେ ଆପଣ ମାନେ ଫିଲ୍ସିଂରେ କଣ କରେ ସେ ଯଦି କୌଣସି ଜାଗାରେ ଛୋଟ ପୋଖରୀଟେ ଛୋଟିଆ ଟ୍ୟାଙ୍କଟେ କଣ ଯଦି ରହିଯାଇଛି ଡିପ୍ ହେଇଯାଇଛି ସେଠି କିଛି ପାଣି ଆଗ ଭର୍ତ୍ତି ହବ ତାପରେ ଯାଇକି ପାଣି ବହିବ କିନ୍ତୁ ଆମ ନିୟମ ଅନୁସାରେ at any point when I'm putting a drop of water it should always flow to some direction in order to ensure that ଗୋଟେ ସ୍ମଲ୍ ଗୋଟେ ଆଲଗୋରିଦମ୍ ଡେଭଲପ୍ କରାହେଇଛି ଆର୍ଜିଆଇଏସ୍ ରେ, ଯୋଉ ପାର୍ଟ ଦବିକିରି ଅଛି ତାକୁ ସିଧା କରାହେଇଯାଏ, ମାନେ ସେ ପାର୍ଟ ଉଠେଇ ଦିଏ ସେ ଉପରକୁ। ତାର ଆଡଜେସେଣ୍ଟ ଲେୟରକୁ ଧରିକିରି ଆଇଡିଡବ୍ଲ୍ୟୁ ମେଥଡ ବା କ୍ରିଗିଂ ମେଥଡ କିଛି ଗୋଟେ ମିଶେଇବା ଆଲଗୋରିଦମ୍ ଆଣିକି ତା ସହିତ ମିଶେଇ ଦିଏ, ସୋ ଦ୍ୟାଟ୍ ପାଣି ଯଦି ପଡିଲା ପାଣି ସବୁବେଳେ ଫ୍ଲୋ କରିବ। ଦିସ୍ ବର୍ନିଂ ଇଜ ଆକ୍ଚୁଆଲି ଦ ରିଭର୍ସ ପ୍ରୋସେସ। ଏପଟେ କୌଣସି କାରଣରୁ ନଦୀ ଦେଖଉନି, ମୁଁ ଯଦି କହିଲି ତୁ ବର୍ନ କରେ, ସେ କଣ କରୁଛି ସେଇ ଲାଇନରେ ଖୋଳିଦବ ତଳକୁ। ଇନଷ୍ଟେଡ ଅଫ ଫିଲିଂ ଇଟ୍ ଅପ୍, ସେ ତାକୁ ଡିପ୍ କରି ଗୋଟେ ଖୋଳିଦବ ଚ୍ୟାନେଲଟେ, ୱିଲ୍ ବି ସିଙ୍ଗ ଇଟ୍ ଦ ନେକ୍ସଟ ଏଇଟା ଅଛି ବୋଧେ ନେକ୍ସଟ ସ୍ଲାଇଡରେ ଅଛି। ବଟ୍ ତା ପାଇଁ କଣ ଦରକାର, ୱାନ୍ ମଷ୍ଟ ବି ଭେରି ସିଓର। ଖାଲି ଖାଲିରେ ଗୋଟେ ବେସିନଟାକୁ ଡିଷ୍ଟର୍ବ କରିକି ତମେ ଯୋଉଠି ଗୋଟେ ଗାର ପକେଇଦବ, ସେଇଠି କରିଦବ। ଗୋଟେ ପଏଣ୍ଟ ଆମର ଏମିତି ହେଲା, ଆମ ପାଖରେ ଟୋପୋସିଟ୍ ବେସ୍ଡ ଗୋଟେ ରିଭର ନେଟୱାର୍କ ଅଛି ମହାନଦୀର। ଏତେ କଥା କଣ ତା ସହିତ ଆମର ତ ଏକ୍ଜାକ୍ଟଲି ମ୍ୟାଚ୍ କରୁନି, ସେ ତ ଏମିତି ଯାଉଛି, ଆମର ତ ଏମିତି ଯାଉଛି, କୋଉଠି କୋଉଠି ଫୁଟେ, କୋଉଠି 2 ଫୁଟ, କୋଉଠି 20 ଫୁଟ, କୋଉଠି 50 ଫୁଟ ଉଞ୍ଚୁଛି ନା ଯାହାହେଲେ ମଧ୍ୟ। ସୋ କଣ କରିବା, ଆମର ଟୋପୋସିଟ୍ ବେସ୍ଡ ରିଭର ନେଟୱାର୍କଟାକୁ ପୁରାପୁରି ଦେଇଦବା ମଡେଲକୁ, ପୁରା ବର୍ନ କରିଦେ ବୋଲି କହିବା ଏଣ୍ଟାୟାରଟା, ତାମାନେ କମ୍ପ୍ଲିଟଲି ଡିସଇଣ୍ଟିଗ୍ରେଟ ହେଇଗଲା। ଆଉ ବେସିନର ସାଙ୍କ୍ଟିଟି ନାହିଁ, ଡିଏମ ର ସାଙ୍କ୍ଟିଟି ନାହିଁ, ଡାଟାର ସାଙ୍କ୍ଟିଟି ନାହିଁ। ଆମେ ଅପୋଜ କଲୁ ସେଇଟାକୁ। ଆମେ କହିଲୁ ଯଦି କିଛି କରିବ ଯୋଉଠି ପ୍ରୋବ୍ଲେମ ଏରିଆ ଅଛି, ଏତେ ବଡ ବିରାଟ ବେସିନର ସବୁତକ ସୋ ଅନେଷ୍ଟଲି ଆପଣଙ୍କର ସଫ୍ଟୱେର କଲା, ଏକ୍ସେପ୍ଟିଂ ସାପୁଆର ଗୋଟେ ହାର୍ଡଲି 30 40 50 ମିଟର୍ସ ଜାଗାରେ ସେ ଯୋଡି ପାରୁନି। ସୋ ଯଦି ୱେଲ୍ଡିଂ କରିବ, ପ୍ଲିଜ ୱେଲ୍ଡ ଓନ୍ଲି ଦିସ୍ ମଚ୍। ବୁଝିହଉଛି? ଏଇ କଣ୍ଡିସନରେ ଆମେ ରାଜି ହେବୁ। ନେଇକି ଚାଲିଲା ଯେ ବର୍ତ୍ତମାନ ଛୋଟ ପାର୍ଟଟାକୁ କେମିତି ୱେଲ୍ଡିଂ କରାହବ, ଏଗେନ୍ ୱି ଡିସ୍କସ୍ଡ ୱିଥ୍ ଏସ୍‌ଡି। ତା ସହିତ କଥା ହେଲୁ ଯେ ଆମେ ଗୋଟେ ପାର୍ଟ ଆମେ କରିପାରିବୁ ନା, ଯାହା ତମ ଅପରେସନ ଅଛି ଏଇଟା ପୁରା ପାଇଁ ଅଛି। ଫାଇନାଲି ଦେ ସରେଣ୍ଡର, କହିଲେ ଆପଣ ଯାହା କରୁଛନ୍ତି କରନ୍ତୁ, ଛୋଟ ପାର୍ଟ ଆମେ କରିବୁ, କିନ୍ତୁ ତା ପାଇଁ ବୋଲିକି ଏଣ୍ଟାୟାର ବେସିନକୁ ଆଉ ଥରେ ସଫ୍ଟୱେର ରିକମ୍ପ୍ୟୁଟ କରୁଛି, ଫଳରେ ଟିକେ 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 ଚେଞ୍ଜ, ଚାରିଆଡେ ଚେଞ୍ଜ ଟିକେ ଟିକେ ହେଇଯାଉଛି। ସୋ ବେସିକାଲି ମହାନଦୀ ବେସିନର ଉପରେ ଭାବ, ବସ୍ତର ମଧ୍ୟପ୍ରଦେଶ ରାୟପୁର ପାଖରେ ବି ମୁଁ ସାପୁଆ ପାଖରେ ଏଡିକି ଗୋଟେ 40 ମିଟରରେ ଗାରଟେ ଦେଲି, ଆଇ ୱାଣ୍ଟ ଟୁ ଚେଞ୍ଜ ଇଟ୍, ଆକୁ ଚେଞ୍ଜ କରିବା ପାଇଁ କମ୍ପ୍ୟୁଟରକୁ ଦେଲି, ମୁଁ ଦେଖିଲି ରାୟପୁର ପାଖରେ ମୋର ଭ୍ୟାଲୁ ବଦଳିଲା। ତାମାନେ some sort of algorithm it undertakes, which it has no competency as on date to confine to a small area. ଯଦି ଦେଇଥାନ୍ତା ବଫର ଦେଇଥାନ୍ତା, ଏଇ ବଫର ଭିତରେ ଅପରେସନଟା ତୁ ଅପରେଟ କରେ ବୋଲି, that capacity it does not have. So future of GIS ଆମେ ଏଟା ଲେଖିକି ଦେଇଛୁ, that please incorporate it into next version କହିକି। ବୁଝିହଉଛି? ହଁ? So outwardly appearing as a normal work, but how much exercise had gone inside this? ଏଇଠି ବୋଧେ ଆମେ ଦେଖିଲୁ ଯେ ଏଇଠି ଏଇ ଯୋଉ ବର୍ନିଂ ପ୍ରୋସେସ ମୁଁ ଆଗକୁ ଯିବି କହିବି, ବଟ୍ ପ୍ଲିଜ ଲୁକ୍ ଏଟ୍ ଦ ଲାଷ୍ଟ ଲାଇନ୍ ଅଫ୍ ଇଟ୍। କଣ ହଉଛି ଏଥିରେ, ଓଭରଅଲ୍ ବେସିନର ସ୍ଲୋପରେ ଦେର୍ ଇଜ ଏ ଚେଞ୍ଜ, କର୍ଭେଚରରେ ଚେଞ୍ଜ ହେଇଯାଉଛି, ସେପରେ କିଛି ପରିବର୍ତ୍ତନ ହେଇଯାଉଛି, ଫର୍ ହ୍ୱିଚ୍ ରିଜନ୍ କିଛି ଟପୋଗ୍ରାଫିକାଲ ମେଜରମେଣ୍ଟରେ ପ୍ରୋବ୍ଲେମ ହଉଛି। ଏଣ୍ଡ ଆଉ ଗୋଟେ ହଉଛି ଆମର ଯୋଉ ମର୍ଫୋମେଟ୍ରିକ ପାରାମିଟର ଆମେ ବାହାର କରୁଛୁ, ସ୍ଲୋପ ପାରାମିଟର, ବାଇଫର୍କେସନ ରେସିଓ ପାରାମିଟର, ଡ୍ରେନେଜ ଡେନ୍ସିଟି ପାରାମିଟର, ସେକୁ ଆଫେକ୍ଟ କରୁଛି। ଆମକୁ ଦେଖାଅ ମତେ କେମିତି ଆଫେକ୍ଟ କରୁଛି। ସୋ ଏଗେନ୍ ୱି ହ୍ୟାଡ୍ ଟୁ present all those things. I'll be showing some of the things. This is the methodology how you will go stream burning. ArcSWAT ଗୋଟେ add-on ଅଛି ଏଠି, ArcGIS ଗୋଟେ add-on ଅଛି now, ArcSWAT. So SWAT actually ମାନେ ArcGIS directly କରିନି, SWAT ରେ ଗୋଟେ ArcSWAT ଅଛି। ArcSWAT ଏ problem ଟା identify କଲା ପରେ for ArcGIS it has given a add-on. You can always bring it, this is free. ArcSWAT ଆଣିକି bring in ମାନେ ArcGIS ରେ this tool you can put if you at all want to test, have a test of it. But see what it is doing here. ସେପଟ ଲାଷ୍ଟ ସ୍ଲାଇଡଟା ଦେଖ, ମୁଁ ଯୋଉ କହୁଥିଲି ଯୋଉ ଖୋଳି ଦଉଛି କରିକି, ସପୋଜିଂ ଆଇ ଏମ୍ ଟେଲିଂ, ଏ ଉପରେ ଗୋଟେ ପଏଣ୍ଟ ଦେଇଦେଲି ଯେ ମୁଁ ନଦୀଟା ଏଇପଟେ ଯାଉଛି, ଯୋଉ ଲାଇଟ୍ ଦିସ୍ ଦ ପଏଣ୍ଟ, ମୁଁ ରିଭରର ଗୋଟେ ପର୍ଟିକୁଲାର ପଏଣ୍ଟ, ମୁଁ କହୁଛି ଯେ ଏଇଟା ହଉଛି ମୋର ଗୋଟେ ନଦୀ, ତୁ ମତେ ଦେଖଉନୁ, ଦେଖା ମତେ ବୋଲି। ଯୋଉଠି ମୁଁ ପଏଣ୍ଟ ଦଉଛି ସେ ତାକୁ ଉଭୟ ପଟ ସାଇଡରେ 5 ମିଟର୍ସ 5 ମିଟର୍ସ 10 ମିଟର ଗୋଟେ ଚ୍ୟାନେଲ ବନଉଛି ଏବଂ ଗୋଟେ ଡିପ୍ କରୁଛି ଆକୁ 3000 ମିଟର୍ସ। ଏଇ ଯୋଉ ଡେପ୍ଥଟା ତା ପାଇଁ ତାର ଅପସନ ନାହିଁ। Your software does not have option. If at all you are burning, you are bound, ତମେ ଯୋଉ ଲାଇନ ଦେଖେଇବ ସେ ଲାଇନର ଏପଟେ 5 ମିଟର ସେପଟେ 5 ମିଟର, ଡେପ୍ଥ ହଉଛି 3000 ମିଟରର ଗୋଟେ ଖାଇ ଗୋଟେ ଖୋଳି ଦଉଛି। ବୁଝିଗଲା? ଯଦି ଖୋଳିବ ଇଏ ଯାଇକି ଯୋଉଠି ମିଶିବ ତା ଲେଭେଲ ହଉଛି ଏଇଠି, ଏ 3000 ମିଟର ତଳକୁ ପଳେଇଛି, ସେଠି ପାଣି ପକେଟ ହେଇକି ଏମିତି ଯାଏ, ତା ସହିତ ମିଶୁନି, ମାନେ ଏନି କଷ୍ଟ ତା ସହିତ କମ୍ବାଇନ ହେଇପାରୁନାହିଁ। That also we found. So basically the impact of the stream burning lie ଅଛି, ଗୋଟେ ହଉଛି ୱିଦାଉଟ୍ ବର୍ନିଂ, ଗୋଟେ ହଉଛି ଗୋଟେ ଛୋଟ ପୋର୍ସନରେ ଆମର ବର୍ନିଂ ରିକ୍ୱାରମେଣ୍ଟ ଥିଲା। ଆମେ ଦେଖିବୁ ବର୍ତ୍ତମାନ ଯେ ହ୍ୱାଟ ଆର୍ ଦ ଚେଞ୍ଜେସ୍ ଇନ୍ ଦି ଏଣ୍ଟାୟାର ବେସିନ୍। ସ୍ଲୋପ ମ୍ୟାପରେ ଏ ସାଇଡରେ ତ ପଢି ହଉନଥିବ ଦିସ୍ ପର୍ଟିକୁଲାର ପାରାମିଟର୍ସ, ଆମେ ଯୋଉ ଇକ୍ୱେସନ ଦେଇଛୁ ତଥାପି ଟିକେ ଟିକେ ଜାଣିପାରୁଥିବ ଯେ କୋଉ କୋଉ ଏରିଆରେ slightly changes ହଉଛି। Let us see the mathematical version of it, you can understand in a better way. See what it is doing. Steeper areas become steeper, flatters become flatter. You say 0 to 5 degree slope area manakara. 0 to 5 ମାନେ very light slopes. जोटा हल्का स्लोप टोपोग्राफी जोटा थिला गोटे बेसिन भितरे सेटा आगो एरिया हमर केते थिला 86.62% थिला वर्तमान हे गला 83.44%. माने लाइटर स्लोप एरिया कमी गला और स्टीपर स्लोप एरिया देखो आस्ते आस्ते देखो 2.48 जगह 2.61 हे गला 15 टू 25%, 25 टू 35 टा 0.58% टू 0.65%. This means the areas which were steeper, they have been made more steeper and they have been affected by this 3000 meters of sharp drop. বিভিন্ন জায়গায় যে বর্তমান তার ইকুইভ্যালেন্ট যে ইম্প্যাক্ট অনুসারে স্টিপর হয়ে গেল কোনটা প্রবলেম ହେଲା বেସିନ ଏରିଆ ତ ବେସିନ ଏରିଆ ଥିଲା ପାଣି ତ ବହୁଛି ସବୁ ତ ହଉଛି ପ୍ରୋବ୍ଲେମ ତମର କଣ ପ୍ରୋବ୍ଲେମ ହଉଛି when you are going to vec when you are doing for the variable infiltration capacity soil को पानी भेदिबा ପାଇଁ डार्सिस लॉस ଭିତରେ ପୁରଉଛ ପାଣି ଯଦି ସ୍ଟିପର ହେଲା ପାଣି ଧଡକିନା ପଳେଇବ before it actually recharges the groundwater slightly to some extent এই পানি এই যে পড়িলা পরে ये जो बिहेवियर करी थांता सैचुरेशन जोन को जीवा पूर्व आगे बही पड़ेगा सो स्लोप चेंज है माने मु जो मोर जीआईएस रे प्रॉब्लम नै ए जीआईएस को नै मु जोठी पुरेबी वाटर एनालिसिस करिया पे सेतिर प्रॉब्लम हबो सो वी अपोज्ड इट ए केसटा जेटा हमर अपोजिशन थिला एठी सो स्ट्रीम रिकंडीशनिंग इंक्रीजेस ओवरऑल हाई स्लोप एरिया and stream reconditioning by burning this reduces overall low slope area okay so now ethical discussion pare now I am coming to a platform with which you are already acquainted normally what we do when we go for the delineation business sink fill flow direction flow accumulation then stream linking finally water set delineation so original DM because it contains voids now we have inserted a new thing here we are actually filling up the voids first after that now we will be going to do this business sink filling টা most of you know sink fill रे যদি কোনসি জায়গায় যদি ছোট হোলটে ଅଛି then the software actually artificially erases it so that কোনসি পয়েন্ট রে মধ্যে পানি যদি পড়িলা it has to flow in a particular way in a particular direction it cannot be accumulated at any point in order to ensure this the sink filling ଟା कर दउछु ଏ ଗୋଟେ fill tool ଅଛି ଏଠି sink depression କରିବା ପାଇଁ now this is a flow direction tool this is a very standard mechanism here actually you see aji paryant ame D8 algorithm gote achi amar D8 algorithm what is a D8 algorithm next box ku jauche again I will be coming down ei jo particular jo rectangle ଟେ ମିଟି ଦେଇଛି what is a D8 at any particular point जो पॉइंट हम एनालाइज करू चाहिए ए पानी तक जेतरा बहिबा दरकार है how many places to go either this way or that way or that way or this way or this way or this way so 1 2 3 4 5 6 7 8 only out of this 8 one of the directions your water drop has to choose this is a D8 algorithm normally ଆମେ ଯାହାଟା ବି କରୁ ଏଇ D8 algorithm ରେ କରୁ but this also does not help you sometimes primarily this is more pronounced in case of delta where the slopes are very flat frequently ଗୋଟେ problem ଆସିବ ଦିଟା ଜାଗାରେ same type ର same slope ଆସିବ computer is confused the cell is confused ମୁଁ କୋପଟେ ଯିବି ଏପଟେ ଯିବି ନା ସେପଟେ ଯିବି ତା ପାଇଁ recently they have come up with a new algorithm MFD multi flow direction algorithm आପରେ ବର୍ତ୍ତମାନ ଆଉ ଗୋଟେ ସେମାନେ କାମ କରୁଛନ୍ତି ପରେ ଆସିଛି କି ନାହିଁ D infinity infinity direction ରେ ମଧ୍ୟ ପାଣି ବର୍ତ୍ତମାନ ଗୋଟେ cell ରୁ in many directions the water can flow ସେଠି machine hang ହଉ ନାହିଁ ଆଜିକାଲି but the D infinity takes approximately 3000 more time जोटा तमे एटी घंटा कर प्रोसेस करिवो जदि तमे एमएफडी जदि एल्गोरिथम सेठी पकेइ देलो ताले आज ऑन करके जीवो 5 दिन पर भी आसीबो खाली बैटरी दि चार्ज के 5 दिन पर देखिवो 30% ହେଇଛି 20 days 21 days तम लैपटॉप हाई एंड लैपटॉप को बसई की जाइथिबो तमे 15 दिन 20 दिन पर गोटे गोटे साइकिल तार रन हो सो सेई पार्ट टाकू प्रोसेस करिया पई some of the things they have to work upon we have written so exactly I was here this D8 algorithm we have understood now normally by default out of these 8 directions in one direction the flow has to go it is the MFD and D infinity method these algorithms consumes much more computational power सेमती हमको आमे जथा भी चेष्टा करू वेट करी but it did not give us the beneficial result for our catchment delineation आमे जो problem face कल ताको से देई पारलानी I will be telling you some of those also afterwards Now this is a flow direction. For the people who have understood this, see flow ହେଇଗଲା ପରେ flow direction ରେ how it decides ki କୋଉ ପଟେ flow ଯିବ. The people who know, they know. The people who do not know, this is small mathematics. You can understand the entire here if you understand this particular table. For some reason, the flow path these are the values. Our purpose होची this margin flow, it जो पानी टोपाटा पड़ेছি, this flow now wants to seek a direction. कोउ पटे जिबि से decide करूची. So how it is knowing? That is 1004. So there is a down of 11. 11 नो that मिलुची support. Incentive of 11 to go that side. 80 मिलुची केते plus 8. 80 मिलुची 3 रे मिलुची. ये 1015 रे अछि 1012 रे अछि. 83 रे मिलुची. All these values have been calculated. Calculation ହେଇଗଲା ପରେ this is the elevation value. But then tell me that in which direction the flow will go. এই পানিটা নিয়ম অনুসারে কোপড়ে ଯିବା କଥା হঠাৎ ଏଠି appear 11 ପଟେ ଯିବା କଥା କରି ଏଗାର ସବୁଠୁ ବଡ କିନ୍ତୁ ଦେଖିଲା ବେଳକୁ ଏପଟେ ଗଲେ ସେ diagonally ଯିବ. So it is the one, this is 1, then this is root 2, 1.414. So the gradient is 11 divided by 1.414, which is a slope. And the slope is 1, 8 divided by 1. एक slope है, एक अधिक higher असला, दूसरे दिन float एपटे जाए. So ये वाला हमारे प्रत्येक pixel को computer goes on doing the analysis and it decides in which direction which particular flow should go. So now we are coming to the flow accumulation part. In this flow accumulation जो प्रत्येक जगह जो flow direction मिलिगला से flow direction को लेकरी को जगह रे बहुत जगह सेल रो आसी पहुंचले तार वैल्यू बढ़ला ए वैल्यू जाके आउथरे गोटे जगह रे देला जोटा मेन नदी से पाखरे पाखरे आस्ते 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 बड़ बड़ flow values will be generated for the computer to know that this is my stream, a stream identify करिया ପାଇଁ बोली. Now in order to define a channel, this is again challenging thing, what will be your threshold value? तमे जदि मन भाबो जे गोटे पर्टिकुलर सेल रे जदि 500 सेल 500 नंबर थ्रेशोल्ड वैल्यू ता माने होची इफ मोर देन 500 सेल्स रो पानी जदि ए पाखरे पहुंचुची देन आइडेंटिफाई दिस एज अ पार्ट ऑफ द रिवर. Say for example, at that point of time I must understand what is the size of a cell. गोटे सेल होची 30 मीटर by 30 मीटर. 30 by 30 is 900 square meters. मु कहूची 500. So 500 into 90 is a 45,000 square meters is equal to be not 1 square kilometer भी होनी बदे नहीं 4.5 square kilometers. ସେତିକି ଏରିଆର ପାଣି ଯଦି ଆସି ବୋହିଲା ତାକୁ ଗୋଟେ ନଦୀ ବୋଲି କହିବି ନା ନାଳ ବୋଲି କହିବି ନା ଝରଣା ବୋଲି କହିବି ନା ରିଭୁଲେଟ ବୋଲି କହିବି ଏତେ ଛୋଟ ନେଲେ ଯେତିକି କ୍ଲମ୍ଜି ହେଇଯିବ ମାଇ ମଡେଲ नो लेट मी डू 1000. सो तमर प्रोब्लेम को धरिकी मु महानदी को बाछुची बिगिनिंग रु नेकी भाव मु डेल्टा पर्यंत पकेइबी. सो ता पई व्हिच पर्टिकुलर रिवर शुड आई कंसीडर द मिनिमम आमे डिसाइड करू 2000. So 2000 में 2000 into 30 into 30 एतिकी स्क्वायर मीटर रो पानी जदि गोटे सिंगल सेल रे पहुंचुची दैट क्वालिफाइज टू बी ए नाला ऑफ सम पर्टिकुलर ऑर्डर ता तळकु जोटा एटा से जणा प्रणाम दरकार नै वी डू नॉट वांट टू गो इनटू दैट. So this is also depending on your problem area, depending on your challenge, what resolution you take, that decision you have to take for fixing this threshold value. Now comes the flow accumulation, the another beauty how it does the things. The direction coding part you must be knowing, I should not tell you. This is a 2 to the power n formula जो करंती 1 2 4 8 32 64. Supposing the water goes in that direction एपटे जीवो तार एटा 128 value डायरेक्ट करब एपटे जे जाईची 64 हबो ए से नंबर रो because ultimately it is 0 1 these are the computers of plus minus 0 2 0 2 methodology and this algorithm we need not bother for that. Our challenges are somewhere else. We need not bother for that. Then flow accumulation ta हमको दबो बर्तन गोटे stream accumulate ही गला. Now we are going finally we will be looking at this. से जो पानी जो गला मते stream link दे दूची ताले ये जो particular जो gradually बड़ी जाउचंती एटी जे देखिबो तमे. See it was one thing you know when it has put all the values. This is 7 7 रो पानी नेकी 20 को आसीबो एटी 20 रो से एटी पानी देछन एटी आसला 24 एटी आसला 35 ए गरे से देखि से जॉइन करी मोर आज से जानिबो हाउ दिस stream is delineated from this particular values. So the computer automatically goes on doing it and that exactly almost gets correlated with your ground reality. So this stream link raster, this gives me a stream network. At this point, I do have an opportunity. मुझे toposit जदि background रे पके देली, what my toposit is, then this particular stream network, देखला पर मैं जानिबी जे how accurately it has done, where the errors have been communicated, को stream से छाड़ी देइछि, काले void filling रे मोर problem रहि जाइछि कि then I have to go and redo and find out the things why it is unable to correlate. Basically गोटे stream रो को parameter ଆମେ धरुछु, every stream माने stream is having a length, stream is having a beginning point, stream is having a junction, it falls into something. Individually गोटे stream cannot be there. ଆମର void ପୂର୍ବରୁ जो रहि जाइतला ଆମେ we are over it. A stream link raster includes reaches, junctions, flow directions and an outlet जोटा से drain करूथबो. Now we see this delineation based on pore point. Now comes to find out a catchment area. गोटे केचमेंट एरिया डेलिनेट करिया पे मु कोन करूची मो बेसिन भितरे स्ट्रीम नेटवर्क हला परे मोर जोटा पॉइंट ऑफ इंटरेस्ट मे बी नराज मे बी हिराकुद मे गोटे रिवर जो पर्टिकुलर मे गोटे पर्टिकुलर गां पाखरे एई पाखरे जदि मु गोटे बिंदु जदि नेबी ताहले को एरिया तक मते आकु देखो दउछंती इन ऑर्डर दिस इज कॉल्ड ए कैचमेंट डेलिनेशन प्रोसेस. So this is a pore point. The pore point would them select करेबी then computer automatically goes on searching एई point को के पानी देछति खोजी से गोटे बाउंड्री मो पे बनै के दिए. एथि देखिबा हमर जो वाटर सेट टूल गोटे अछि हमर आरजीएस रे दिस नाउ इट इज दिस सपोर्ट्स ओनली द डी8 टूल मु जो एल्गोरिथम कहली किंतु एमएफडी एपर्यंत भितरे पसिनी डी इन्फिनिटी एल्गोरिथम एपर्यंत भितरे पसिनी जे स्टिल टू कम इन द कमिंग वर्जन्स एपर्यंत आरजीएस पाखरे ए कॉम्पिटेंसी नाही माने हाइड्रोलॉजी पे जो एक्स्ट्रा जो खटिबा कथा से माने खटु नाहांती अदर एरिया रे डेवलपमेंट्स बहुत स्पीडी होची आम एरिया गुडा सो रहि जाइछि दीज आर द बॉटलनेक्स वी आर सफरिंग फ्रॉम स्टिल टुडे. This requires a raster ए सरीगला परे ultimately everything comes in a raster format but more area computation length computation ये सब जहाटा भी करिवे I need a vector format. So raster to बर्तन vector को जिबी this aerial things I have to take into a polygon cell. तो polygon को जिवो polygon तो convert करिथिबो raster to polygon. Many times you might have done those particular exercises. Please try to see what are the new beauties we have got in that. So before going to that, I'm kind of when basically when a big basin is there, it has many number of sub basins. So प्रत्येक sub basin ପାଇଁ ଗୋଟେ mond केलो छोटी केलो कि ଆମର ସାର୍ ହଉଛି ଡାହୁକା ସାପୁଆ ଯେତେ ସବୁ ରିଭର ଷ୍ଟ୍ରିମ୍ ଯେ ଯୋଉଠି ଆସି ପଡିଛି ସେ ପଏଣ୍ଟ ମୁଁ ଯଦି ପୋର ପଏଣ୍ଟ ଦେଇଦେଲି ଦେନ୍ ସିଏ ଦେଖେଇଦବ ଯେ ଏଇଠୁ ଏତିକି ଏରିଆର ପାଣି ଏଠିକି ଆସୁଛି ଦିସ୍ ଇଜ ସବ୍ ବେସିନ୍ ମଣ୍ଡ ନଦୀର ସେଇଠି ଗୋଟେ ସବ୍ ବେସିନ୍ ଯାହା ଯଦି ହସଦେव ଆସି ଯୋଉଠି ପଡିଛି ମହାନଦୀ ପାଖରେ ଦ ଜଂସନ ଯଦି ପାଖରେ ଗୋଟେ ପଏଣ୍ଟ ଦେଲି ଇଟ୍ ଗେଭ୍ ମି that particular sub basin ଏଟା ଯୋଉ ଡିଲିନେଟ୍ କରି ମତେ ଦବ in that for that I need the ଏରିଆ ବାହାର କେମିତି କରିବି ପଲିଗନ ରେ କନଭର୍ଟ କରିବି. This very simple command ଗୋଟେ ଅଛି ଆମର ସେ ଭିତରେ raster to polygon. The boundary is marked by a pore point. The stream network is verified using toposits and satellite imagery. Stream network ଆମେ check କରିଦେଲୁ. Then the pore point is where the main tributaries join the mainstream. जो point ରେ exactly ମିଶୁଛନ୍ତି ସେ point ଟା ଖୋଜିକି ଦବାକୁ ପଡେ in order to be more accurate. The stream network from the DM is inaccurate downstream of the Mundali weir. This is a new story I will be telling you. Delta ପରେ କାହିଁକି so story new stories began and how seriously your GIS fails. ଏବଂ ତମେ ଆଶ୍ଚର୍ଯ୍ୟ ହବ ଦେଖିଲା ପରେ ତାପରେ ଏତେ ବଡ ବିରାଟ ଇନକମ୍ପିଟେନ୍ସି ତା ଆଲଗୋରିଥମ ଭିତରେ ବିଲ୍ଟ ଇନ୍ ହେଇକି ରହିଛି. ଇଟ୍ କ୍ୟାନ୍ ନେଭର ଡୁ ଏନିଥିଙ୍ଗ. ଆମର ମହାନଦୀର ଡେଲ୍ଟା approximately 10,000 square kilometers ତାର GIS analysis ଆମେ ଲିଡାର ପାଖକୁ ଗଲୁ ଇଭେନ୍ ଲିଡାର ଏକ୍ସରସାଇଜ ବି କରାହେଇଛି but nobody can help. And why nobody can help? In spite of whatever the resolution you make, there you find that ଆମର algorithm ହଉଛି D8. ପ୍ରତ୍ୟେକ ପଏଣ୍ଟ ତାର 8 ଜଣ ସାଙ୍ଗଙ୍କ ଭିତରୁ 8ଟା ଯୋଉ ପଏଣ୍ଟ ଅଛି ଇଟ୍ ହାଜ ଟୁ ଟେକ୍ ଏ ଡିସିସନ କି ମୁଁ କୋଉ ପଟେ ଯିବି ଯୋଉ ଫ୍ଲୋ କରିବି ଏବଂ ଫାଇନାଲି ଗୋଟେ ତାଠୁ ବଡକୁ ଯିବ ସେ ତାଠୁ ବଡକୁ ଯିବ ସୋ ଆକୁମୁଲେସନ ଇଜ ଦ ଅବଜେକ୍ଟିଭ ଗୋଟାକୁ ଆଉ ଗୋଟେ ଆକୁମୁଲେଟ ହେଇଯିବ ବଟ୍ ଡିକୁମୁଲେଟ ହବାର ପାଇଁ ଗୋଟେ ପ୍ରୋଭିଜନ ନାହିଁ କିନ୍ତୁ ଆମ ଡେଲ୍ଟାରେ କଣ ହଉଛି ମୋ ଦେହରେ ଆଉ କ୍ୟାରି କରିବା ଶକ୍ତି ନାହିଁ ଏଇଠୁ ମୁଁ ଭାଗ ହେଇଗଲି ଏତିକି ବାଟ କ୍ୟାରି କରିବା ଶକ୍ତି ନାହିଁ ଆଉଥରେ ଭାଗ ହେଇଗଲି ସୋ ଦିସ୍ ପର୍ଟିକୁଲାର ଆନାବ୍ରାଞ୍ଚିଂ କନସେପ୍ଟ ପାଇଁ ଆମର ଆରଜିଆଇଏସ୍ ଭିତରେ ଆଲଗୋରିଦମ ହିଁ ନାହିଁ ଆଜି ପର୍ଯ୍ୟନ୍ତ. It has understood accumulation process. It has not yet understood division process or anabranching process. ସେଥିପାଇଁ କେବେ ହେଲେ ମଧ୍ୟ ଏ ତମକୁ ନେଟୱାର୍କଟା କରେକ୍ଟଲି ଡିପିକ୍ଟ କରିବ ନାହିଁ. ସୋ ଦି ସବବେସିନ୍ ଡେଲିନିଏସନରେ ପ୍ରଥମେ ଉପରୁ କରି ଆଣୁ ଆମେ ଉପରୁ କରି ଆମେ ଡାଉନ ଷ୍ଟ୍ରିମକୁ ଯାଉ ଏଇଠି ବର୍ତ୍ତମାନ ଯଦି ଦେଖିବ there are so many things ଆକୁ ଫାଷ୍ଟ ଟୋପୋସିଟ୍ ବ୍ୟାକଗ୍ରାଉଣ୍ଡ ଦିଆହେଲା ଟୋପୋସିଟ୍ ଦେଲା ପରେ ଆମେ ଆଇଡେଣ୍ଟିଫାଇ କଲୁ ଯେ ଏକ୍ସାକ୍ଟ ଇମେଜ କେମିତି କଲା କୋଉଟା ମୋର ସେଉନା ଫାଷ୍ଟ ଦେ ରଫଲି ମୋ ପାଖରେ ପିକ୍ଚର୍ସ ଅଛି ମାଇଣ୍ଡ ସେଟ୍ ଅଛି ଗ୍ରାଉଣ୍ଡ ରିଆଲିଟି ଅଛି ତାକୁ ନେଇକି ୱେଣ୍ଟ ଅନ୍ ସର୍ଚିଂ ଦିସ୍ ପର୍ଟିକୁଲାର ପଏଣ୍ଟସ୍ এই পয়েন্ট কলা পরে ওয়ান আপ্রোচ ইজ গোটে গোটে সবমেশিন করি যাব ওয়ান ফোর পয়েন্ট ওয়ান সবমেশিন টেক এ পলিগন টেক ইট আউট তারপরে আউ গোটে কিন্তু বর্তমান যে লেটেস্ট ভার্সন অফ আরজিআইএস রে মল্টিপল ফোর পয়েন্ট দেলে মধ্যে উইদাউট এনি এরর উইদাউট বিং হ্যাঙ্গিং যদি প্রসেসিং রে কনফ্यूज हुए एट ए टाइम मल्टीपल हो जाई पारुची वर्तमान इफ यू कैन बी एक्यूरेट इन चूजिंग ऑल योर फोर पॉइंट जोड़ जोड़ जहाँ चाहूछ मल्टीपल फोर पॉइंट रो बास्केट गोटे दे दियो बाय एसएफ फाइल से देला पर से सब जगह प्रोसेस कर एट ए टाइम से तो बास्केट करके दे दोची पॉलीगन रे कन्वर्ट करके एठी वर्तमान हला कर दिलु हमें भी कला परे हाउ इट एक्चुअली चेंज फ्रॉम द ग्राउंड रियलिटी नाउ लेट अस डिस्कस ग्राउंड रियलिटी वर्सेस द डीएम डिराइव्ड टू टोपोग्राफी दिस सबमेशिन्स जोटा आसिला महानदी मेन पार्ट हम कहू जाऊँगी जो पॉलीगन रे कन्वर्ट हम से राष्ट्र किसी पॉइंट से कंप्रोमाइज कर दिए पॉलीगन मान हूँ गार गोटे बॉक्स आगुरी कौन थी गोटे फोटोग्राफ जमी राष्ट्र पॉइंट डाटा थिला ए पॉइंट डाटा को पॉलीगन रे कन्वर्ट कला बेलू किसी डाटा ये छाड़देला ऊपर को नहीं गला किसी तौड़ को नहीं गला बिकज पॉलीगन रे कन्वर्ट करने गोटे एल्गोरिथम इज ऑलवेज कंप्यूटेड से जो एल्गोरिथम रे हमर प्रॉब्लम कहला मु कहूची मेनी स्लाइवर्स हैव बीन क्रिएटेड हैव यू हर्ड अबाउट ए स्लाइवर पॉलीगन बोधे नाइ व्हाट इज ए स्लाइवर काचो ग्लास टा पिउछ हाथ रू पड़ीगला it got converted into many number of slivers टिक 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 पिस जार किसी वैल्यू नाइ फॉर हाईली अनकोरिलेटेड तकिया शोचे तकिया चिरी दियो सब जगह तुला बिछे दियो द स्लाइवर्स माय पिलो हैज बीन कन्वर्टेड टू स्लाइवर्स है सो आम जिते बड़े कौन करुचे जेकोसी कम बुंदी लड्डू बनाऊे लड्डू तक बनीगला लास्ट किसी स्लाइवर्स गुड़ाक चारिपटे रही तार किसी नेसेसिटी ना तो झड़ा झड़ी झाड़ू कराई तड़ू सो सिमिलारली आम यहाँ जापे वेन एवर यू आर कन्वर्टिंग ए रास्टर इनटू ए पॉलीगन ये तुम इंपोर्टेंट देख जान वेन एवर यू आर कन्वर्टिंग जोटा लड्डू बनाओ बुंदी कर देकी हाथ में लड्डू चिपी चिपी जाओ लड्डू है लास्ट को किसी बुंदी लगिगला सीट लगिगला इे रहीगला रही ना तो झाड़ू कर छाड़ुच तुम बाहर को बिकज ताप तो इंपोर्टेंस ना कि ये कौन हो जस्ट आई एम गोइंग टू टेल यू जिते एरो गोटे विराट बेसिन सबुठी रास्टर इमेज अच्छी आई एम गिविंग कमांड रास्टर टू पॉलीगन पॉलीगन से करदेला पॉलीगन करदेला परे से भितर जो टिक 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 है विभिन्न जगह किसी जिनस रहीगले दोज आर कॉल्ड स्लाइवर्स एंड दोज स्लाइवर्स अदरवाइज मैं तुम झाड़ू करके बाहर कर दी था बट व्हाट टाइप ऑफ न्यूसेंस दे कैन क्रिएट दैट आई विल बी शोइंग यू एंड व्हाट इज द माने ताको हम केमती ऑब्विएट कलु केमती बाहर एलु सेठो मूल जिनस हूँ सब गोटे पॉलीगन को सिंप्लीफाई गोटे ऑप्शन अच्छी जिते बड़े आम कमांड टे दौचे रास्टर टू पॉलीगन पर देखिए गोटे विराट जो तले गोटे गोटे एल्गोरिथम सेट आसुनी तुम ऑप्शन देवाई सिंप्लीफाई पॉलीगन बोली डिफॉल्ट रही जाए डिफॉल्ट माने हूँ तुम निजे देखिक गोटे पॉलीगन टे बनाओ विथ सम एक्यूरेसी करी से जो गारोटा सीधा सीधा पकई दूची सेठी तो एरर्स आर बिल्ट इन सो स्मॉल स्मॉल पॉलीगन्स आर क्रिएटेड जे एपट बेसिन रहुनी कि सेपट बेसिन रहुनी लूजली से भितर गोटे पॉलीगन थाउचंती सो नंबर्स बढ़ी जाउचंती एवं दे आर एक्चुअली कंफ्यूजिंग द मॉडल माने आरजीआईएस को कंफ्यूज करूचंती परे मॉडलिंग कला बेले दिस फ्रॉम द पिक्चर यू कैन नो इट मे बी ए पिक्चर देखो बिकॉज़ मु पॉलीगन का स्टेट रे extra portion has been added here a small sliver has been created here this sliver बापा मां के ना neither this belongs to this nor this belongs to that एटी आखिरे भी आ पड़िबन एमती डाटा टे अछि बोली कान गोटे बिंदु गोटे जहा ये भी ता दुस्तव ताकु जदी पूरा जूम करी जीव देखिबो तापर गोटे छोटो ट्रायंगल टे से भीतर अछि बोली बुझी होछि सम ऑफ द थिंग्स व्हिच यू हैव फाउंड बेसिकली कोठी केलो छोटे केलो पाखरे देखिलु मॉन्ट पाखरे देखिलु सेठी प्रॉब्लम हला ए डाटा को नै के प्रोसेस कला बडको सो ओवरलैपिंग हबो कोठी ओमिटेड हबो सो व्हाट इज द बेस्ट मेथड intentionally whenever doing this raster to polygon business go and search and से जो simplify option टाको बंद कर दियो फल रे बाहर को चित्र सुंदर दिसिबनी your picture will look like this but be sure your प्रत्येक the step is one pixel 30 meter 30 meter 30 meter it error हमारा chance ना so you will be getting rid of the slivers and this problem will be solved ऐसे problem टा देखो ता पर मु देखौची कोठी problem टा हला look at this स्पेशली आम जो महानदी मेन टाक बाहर करूँ है हीराकुद पाखे पहुंचला बेलू देर आर सो मेनी अदर रिवर्स केलो छोटी केलो सेवनाथ हसदेव जंक इब मंड आ बाद निजे गोटे नदी अच्छी आम कि जानू मेन नदी कोटा ए टोटाल बेसिन रु मंड को अलग करदेलु जंक को अलग करदेलु इब अलग करदेलु केलो अलग करदेलु सब करदेला बर्तमान टोटाल ए समस्त अलग कला जो खंडिया मंडिया देखते रहा ये तले जो पोर्सन टा এইটা হচ্ছে মেইন মহানদী পাকুর মহানদী বাহারি ଗୋଟେ ଏଇଠି କରିବ ଏଇଠି ଜଏନ୍ କଲା ସେଇଠି ଜଏନ୍ କଲା ଜଏନ୍ କରି ଫାଇନାଲ ଆସିକି ଗୋଟେ ପଡ଼ିବେ ତଳେ ବୁଝିହଉଛି ଏଇଟା ସୋ ଏଇଭଳିଆ କେସରେ ହେଲା କଣ ବର୍ତ୍ତମାନ ଯୋଉ ସ୍ଲାଇଭର୍ସ ଯୋଉଟାକ ରହିଯାଇଥିଲା ଭିତରେ ଭିତରେ ଆର ତାର ସେ ସମସ୍ତେ ଆ ସହିତ ସାଙ୍ଗ ହେଇଗଲେ ଫର ଏକ୍ସାମ୍ପଲ ହ୍ୱାଟ ଇଟ୍ ଲୁକ୍ସ ଲାଇକ୍ ଗୋଟେ ଷ୍ଟ୍ରିମ୍ ଭଳିଆ ରହୁଛି ନୁହଁ ଦିସ୍ ଲୁକ୍ସ ଲାଇକ୍ ଲାଇନ୍ ଗୋଟେ ନଦୀ ଭଳିଆ ଏଇଟା ନଦୀ ନୁହଁ ଆପଣ ଯଦି ଓପେନ୍ କରିବ ପ୍ରତ୍ୟେକ ଜିନିଷ ହଉଛି ଗୋଟେ ଗୋଟେ ସ୍ଲାଇଭର ये जो से आपको जो बाउंड्री को बाहर कला बेलू से बाउंड्री बाहर करके नहीं जाइए से ता बाउंड्री बाहर करके नहीं जाइए ए मझिरे एतिकी स्लाइवर सेठी क्रिएट हो जाइछन्ते जोटा आसी आ सते निश्चय बट अदरवाइज दे शुड हैव गॉन टू दैट पेशेंट एटा दिस इज द न्यूसेंस इट क्रिएट्स जदि तमे सिंप्लीफाई न करबो पॉलीगन दिस टाइप्स ऑफ छोटो छोटो जिंस दे आर क्रिएटिंग ए न्यूसेंस ओवर हियर लाइक छोटो काच खंड पड़थि झाड़ू न करिवो गोटे पसी रक्त बाहरला भलिया सो जदि छोटो ग्लास पीस जदि पड़िछि स्लाइवर्स इट हैज टू बी एड्रेस्ड ठीक सेम जिनस प्रोब्लेम एठी भी हमर हेतला नाउ लेट अस कम इवन ए सबु कला परे भी जेते बेले हमें गलु फाइनली स्ट्रीम एटा को जाय पहुंचली एठी सबमिशन डेलिनेशन पर्यंत पहुंची जाइछु रिवर नेटवर्क पाखरे पहुंची जाइछु सब पहुंचला परे भी हमें देखिलु जे माई हिराकुद इज approximately 720 square kilometers sometimes it expands to 900 or something so confluences many tributaries asiki ता देहरे पडिचंती नहीं कि विभिन्न जगह पढ़ी बट आज के दिन दिस इज वेरी बिग बॉडी एंड ए पोर पॉइंट व्हेन यू से पोर पॉइंट इज ए पॉइंट रो साइज केते गोटे पिक्सेल पिक्सेल साइज केते 30 मीटर पे 30 मीटर बट इन केस ऑफ हिराकुद पूरा तो गोटे डैम ऊपर तुम टांग कर जाउछ 3.5 किलोमीटर 4 किलोमीटर को पॉइंट नबो जो पॉइंट नबो ताको नेकी डिफरेंट डिफरेंट रिजल्ट्स विल कम so what a big reservoir pakhare if at all you want to identify what is the catchment upstream which is at giving water to that choosing a point is a very tricky area very tricky thing SRTM DM treats the reservoir as a flat surface जेहेतु 1953 54 55 रु भाबंतु 57 मसिया आज पर्यंत सब बेले पानी गोटे फ्लैट हेकी रहिला सो ताको पानी बुलियो एसआरटीएम पढ़ी पारलानी 2000 मसिया रे इट कंसीडर दैट्स ए वेरी फ्लैट एरिया जदि एते फ्लैट पानी रो एरियाटा फ्लैट ताल से जानिबो किंतु पानी कोठु कोडे बहिबो सो तमरो सबतक एल्गोरिथम जो तमरो जहा जहा हम डिस्कशन कले इन ए वेरी फ्लैट एरिया ऑल द एल्गोरिथम दे डू फेल जेहेतु से फेल कला देखिबो से तार खातिर किछि डेप्थ जिबार कैपेसिटी अछि सैटेलाइट रो ସେଇଥିରେ ସେ ଇବ୍ ନଦୀକୁ ଚିହ୍ନିଦେଲା ଇବ୍ ନଦୀ କୋପଟେ ଆସି ପହଞ୍ଚିଛି ଇବ୍ ଆମର ପଡିଲାଣି ବହୁତ ଉପରେ ସେ କିନ୍ତୁ ଇବ୍ କୁ ଆଣିକି ହୀରାକୁଦ ଡ୍ୟାମ୍ ପାଖାପାଖି ପର୍ଯ୍ୟନ୍ତ ନେଇ ଆସିଛି ୟୁ ସି ବର୍ତ୍ତମାନ ଏଇଠି ଦେଖିବ when it is blind डाटाକୁ ସେ ପଢି ପାରୁନି ତା ପାଖରେ ଯୋଉ ଆଲଗୋରିଥମ ଆମେ ପଢିଛେ ବୁଝିଛେ ବା ଥିଓରି ସେ ଜିନିଷ କାମ କରୁନି at that point of time what this software does that's a black box ସେ କଣ ସେ ଭିତରେ ବିଲ୍ଟ ଇନ୍ କରେଇଛନ୍ତି ଆମେ ଜାଣିନେ ଆମ ଥିଓରିରେ ବି ନାହିଁ ବଟ୍ we can see the result ଏବଂ ସେ ରିଜଲ୍ଟର ନ୍ୟୁସେନ୍ସକୁ ଦେଖିକି ଆମେ ଜାଣିପାରିବା ଯେ ଏଇଭଳିଆ ଜାଗାରେ ପ୍ରୋବ୍ଲେମ୍ସ କଣ ହୁଏ and how to resolve it with the ground truthing ସେଇଟା ମୁଁ ସେଇ ଜିନିଷଟା ଦେଖେଇଛି ଏଠି ଏ ଯୋଉ ଗ୍ରାଉଣ୍ଡ ରିଏଲିଟି ଭର୍ସେସ୍ ଦ୍ୟାଟ୍ ଯେହେତୁ କନଷ୍ଟାଣ୍ଟ ଏଲିଭେସନ ହେଇଗଲା 188 ମିଟରରେ ଏ ଡିଏମ୍ cannot represent the ground terrain and the default flow direction algorithm ମଧ୍ୟ କାମ କଲାନି the stream network generated in this region this deviates significantly from the ground reality ସେ stream network କୁ ସେ capture ବି କରିପାରିଲା ନାହିଁ ଏଇଠି ବର୍ତ୍ତମାନ ଉପରେ ଆମର ଦେଖିଲୁ କେଲୋ and ଛୋଟେ କେଲୋ ଆପଣ ଦେଖିବ ଯଦି କେଲୋ ନଦୀ ଦେଖିବ ଡ୍ୟାମ୍ ହେଇଛି ଏବେ ସେ ପାଖରେ ଦିଟା ଡିଫରେଣ୍ଟ ଷ୍ଟ୍ରିମ୍ ତାଙ୍କ ଭିତରେ ଆପ୍ରୋକ୍ସିମେଟଲି 100 ମିଟର ଡିଷ୍ଟାନ୍ସ ଅଛି ଇଏ କଣ କଲା ଛୋଟି କେଲୋଟାକୁ ଆଣିକିରି କେଲୋ ଦେହରେ ପକେଇ ଦଉଛି ଆମ ପ୍ରୋବ୍ଲେମ କଣ ହେଲା ଛୋଟି କିଲୋମିଟର ଏରିଆ ଅଛି ଛୋଟି କେଲୋ ଡାଇରେକ୍ଟଲି ଆସିକି ହୀରାକୁଦରେ ପଡୁଛି କିନ୍ତୁ କେଲୋ ପଡିବା ପୂର୍ବରୁ ଜଷ୍ଟ ଗୋଟେ ଡ୍ୟାମ୍ ସେମାନେ ବନେଇ ଦେଇଛନ୍ତି they have constructed a dam so ଯଦି ଛୋଟି କେଲୋ ଯଦି କେଲୋରେ ପଡିଗଲା this particular water also will be processed and after feeding all the dam requirement then only it can come so is a particular error which has been built into DM it was a problematic thing so how to resolve that कौन कला ପରେ ସେ ପାର୍ଟ ଆସିବ should burning be done so burning option पे एठी पे मते आर्गुमेंट हला ବିଭିନ୍ନ ସମୟରେ but these are the confusions how the GIS which upon which you completely rely, standard खाली कोन algorithm दे दे आगु को पढौचे, but what are the areas and how it actually puts you stuck into that, किंतु अटकी जाउची, that is our point of discussion. Here I will be showing you especially हिराकु जदम कहले गोटे 4 point आमे नेलु से रिजर्वर रे ही किछि एरिया से अकाउंट फॉर करि परिला नाही. There are some areas. This is a part of reservoir. एटा से अकाउंट फॉर करला. एटी रहिला रिजर्वर रे किछि पार्ट. ताकु से अकाउंट फॉर करला. थोड़े का पर गले. ये मिडल महाधिवेशन बेसिक. आमे जे भाबिला हिराकु तो ऊपर को 100%, हिराकु तळ को 100%. ताहले मते को ए एरिया एंड ए एरिया ये बत तळ को आसला. So model different way process करिवो किन आमे अलगा असाइनमेंट दोछु हिराकु ऊपर जिंस पे सपोजिंग वी आर फिक्सिंग डिफरेंट पैरामीटर्स मोर लॉजिक डिफरेंट स्ट्रेटजी डिप्लोमेटिक रिलेशनशिप डिविजन पॉलिसी किन तळटा होछि हम हिराकु तळटा हमर माने कर ताक अलगा दोछु बट हियर एदिट एरिया बटन दे सपोर्ट फ्रॉम दैट. So limitations of GIS and on which the future of GIS depends. These are the areas on which they have to work in future. Now I'll be going a bit fast. The low gradient मुंडली पाखरे मु कहि देछि एटा माने मुंडली पाखरु वर्चुअली योर डेल्टा सिस्टम स्टार्ट्स डेल्टा पाखरे डीएम्स डू नॉट वर्क जहाटा भी काम करंती अधा करंती सो कैन नॉट फुली रिलाय आ सबुट बड़ जिंस हमर केनाल सिस्टम डेल्टा रे बहुत वर्ष आगु अछि हीराकुद पूर्व 1870-80 मसियर हमर केनाल्स थिला महा हीराकुद आसिला पर हमर बेटर डेवलप्ड हे गयो हमर केनाल भी नदी भेला दिसिले बर्तन डीएम रे. सो जो एसआरटीएम डाटा बर्तन चिन्ही पारुनी स्पेशली डेल्टा रे नदी कोटा केनाल कोटा दियन जो गोटे बेला सांग करी पकई दोची. सो इट इज आवर जॉब नाउ रे बाबू ए लाइन टा एटा नदी ना एटा केनाल ताकू काटो सेटा लिभे की बाहर करो ताकू लिभे की बाहर कर करी हमें सिना बाहर पिक्चराइज विजुअलाइजेशन पे बाहर कर दोछु बट व्हेन दिस डाटा विल बी सब्जेक्टेड टू ए मॉडल लाइक विक और स्वाट व्हाट विल बी डन इट विल कंसीडर दैट एज ए रिवर. सो अगेन डेल्टा पाई बोली कोनोसी गोटे मॉडलिंग करिया पे जे कोनोसी रिवर रो दिस इज ए बिग लिमिटेशन. এইটা আমি যে প্রবলেম ହେଇଥିଲା ডিএম রে a failed experiment for catchment area delineation ହେଲା ଏଇଠି ମଧ୍ୟ ଦେଖିବ ଚିଲିକା this ଚିଲିକା on the one hand receives part of water from this ଦୟା ଭାର୍ଗବୀ river କି ପାଉଛି part of this particular system a catchment କିଛି ପାଣି ଆଣି ଦଉଛନ୍ତି ଏମାନେ ହଉଛନ୍ତି ଡେଲ୍ଟା ସିଷ୍ଟମ ବା ଡିଷ୍ଟ୍ରିବ୍ୟୁଟେଡ ନେଟୱାର୍କ ମାନେ ଏଇ ପାଣିଟା anastomizing ଏଇ ଫିଚରରେ କୋଉଠି କା ସହିତ ଜଏନ୍ ହେଇକି ଯୋଡି ହେଇକି ଆସୁଛନ୍ତି. The canal system which is here ତାଙ୍କ ପାଖରୁ ବର୍ତ୍ତମାନ ବେଷ୍ଟ ଫ୍ଲୋ ହେଇକି କିଛି ପାଣି ଧରିକି ରିଜେନେରେଟେଡ ୱାଟର ସିଆରସି କୁ ଷ୍ଟ୍ରିମ୍ ରେ ମିଶିକି ଆସି ପଡୁଛନ୍ତି. But apart from that, there is a western catchment on the other hand. ଋଷିକୁଲ୍ୟା ଆଉ ଆମର ମହାନଦୀ ମଝିରେ ହେଲା ସେମାନେ ଆସିକି ଜଷ୍ଟ ଲାଇକ୍ ଟ୍ରିବ୍ୟୁଟାରୀ ନେଚର ସେମାନେ ଆଣିକି ପାଣି ଦଉଛନ୍ତି. So supposing I will be now analyzing Chilka. Chilka kotu pani pauchi. See how big a confusion it is. Chilka is having primarily two different sources. One is it has its own independent western catchment which always can be analyzed. जे मोर मॉडल अछि सब अछि जो accumulation algorithm रे मु जानि दे एरिया टा आ गोटे एरिया होछि से भितर भाग होई के आछि प्लस ए मझिरो जे एरिया अछि समान तो दउछथि ए तीनटा एरिया को सेग्रीगेट करबा was the toughest challenge. How to know which particular area is which? ए भितर बतन तमर आइलैंड्स अछन ए भितर किछ आइलैंड्स अछन तो ताकू अगेन सेग्रीगेट करो ସେମାନେ କିଛି ପାଣି ସାଇଲେଣ୍ଟ ସମୁଦ୍ର ପଟକୁ ଦେଇ ଦଉଛି କିଛି ଚିଲିକାକୁ ଛାଡୁଛି. So divide that into two. How much you'll be giving to MFD? This MFD algorithm multi flow direction instead of D8 algorithm MFD algorithm apply କରିକି ସେ ଯୋଉ ଭିତରର ପେଜ ଗୁଡାକୁ ଆମେ ଡିସାଇଡ କରା ହଉଛି କେତେ ପାଣି ସମୁଦ୍ରକୁ ଯାଉଛି କେତେ ପାଣି ଚିଲିକାକୁ ଆସୁଛି. Look at the sensitivity part only. এই সফটওয়্যার को आधार करिकरी जहां भी challenges आसुची क्वेश्चंस आसुची how you had gone on resolving those things. Now also this is same story the चिलिका रो the बहुत बड़ा challenge हम पाखरे थिला LP finally comes मुझे कहिथिले एटा को हमर सापुआ केसटा you can see this मोर सापुआ स्टोरी कहिथिले केतळ अरे able to see through just like a snake माने से कहानी भलिया ए जो स्नेक रे से पडिवा कथा कोठी ऊपर पडिवा कथा ए पाखरे से पाखरे से कोड भूली जाउ से भूली के कोड से जाई कि पहुंचे ए आ गोटे जगह तापर हम रिएक्ट सेठी गलु गला पर सेठी सर्पेश्वर मंदिर अछंती जो साप महाशय एटी मुक्ति पाई जाइछंती ईश्वरकर जो स्वरूप तांको सेठी पूजा भी करा होछि तापर देखिलु जे सेठी नदीटी भी अछि ଆମେ ଗଲାବେଳକୁ ପାଣି ବି ବହୁଛି। କିନ୍ତୁ ସେ ପାଖରେ ଦ ହାଇଡ୍ରୋଲୋଜିକାଲି ସପୋଜିଂ ୟୁ ଲୁକ୍ ଏଟ୍, ଯେତେବେଳେ ନଦୀ ଇଭିନ୍ ମିନିମାଲ ବି ମନସୁନ ବିଗିନ ହେଇଗଲା, ଟିକେ ବି ଯଦି ମହାନଦୀ ଫୁଲି ଯାଉଛି, ସାପୁଆ ଆଉ ସେଇ ଆର ପ୍ରେସରରେ ଏଣ୍ଟ୍ରି କରିପାରୁନା। ଦି ବ୍ୟାକୱାଟର ଥ୍ରଷ୍ଟ ଇଜ ସୋ ହାଇ, ସାପୁଆ ଇଜ ଅନଏବଲ୍ ଟୁ ଏଣ୍ଟର। ନ କରିକିରି ଆଉ ଉପରେ ଗୋଟେ ମାଉଣ୍ଟ ଅଛି, ଏଇଟା ମାଉଣ୍ଟ ଅଛି ଏ ପାଖରେ, ଏ ମାଉଣ୍ଟ ଅଛି, ଏ ମାଉଣ୍ଟ, ଏଇ ମାଉଣ୍ଟ ପାଖରୁ ଏପଟେ ଯଦି ଠେଲି ହେଲା ସେ ପାଣି ଏ ଉପର ବାଟେ ଯାଉଛି, ଯାଇକି ଯାଉଟେ ପହଞ୍ଚିକିରି ସେ ପାଖରେ ପହଞ୍ଚୁଛି ପାଣି। ଏମିତି ଗୋଟେ ରେଲୱେ ଲାଇନ ଅଛି, ଗୋଟେ ବ୍ରିଜ ଅଛି, ରେଲୱେ ଲାଇନ ଓଭରଫ୍ଲୋ ହଉଛି, ଟ୍ରେନ ବନ୍ଦ ହଉଛି, ଗୋଟେ ଷ୍ଟେସନ ଅଛି ଏ ପାଖରେ, ଛୋଟିଆ ରେଲୱେ ଷ୍ଟେସନ ବି ଅଛି, ଟ୍ରେନ ବି ସେଠି ରହୁଛନ୍ତି। ସେ ମନ୍ଦିରଟା କଣ ସାର୍, ସେଠି ଆମର ସାଧା ସାଧା କଣ କଣ ମନ୍ଦିର, ଯୋଉ ଝୁଲା ବ୍ରିଜ ଗୋଟେ ଥିଲା, ଦର୍ଶନ ପାଇଁ ଯାଆନ୍ତି ମୁଁ ସମସ୍ତେ ଧବଳେଶ୍ୱର। ସୋ ବେସିକାଲି କଣ ହଉଛି, ଧବଳେଶ୍ୱର ପାଖରେ ମଧ୍ୟ ଗୋଟେ ଏଣ୍ଟ୍ରି ପଏଣ୍ଟ ଅଛି ତାର, ଏଇଠି ଗୋଟେ ଏଣ୍ଟ୍ରି ପଏଣ୍ଟ ଅଛି। ଆମର ଯୋଉ ଡିଏମ କଣ କରୁଛି, ଧବଳେଶ୍ୱରଟାକୁ ଆଇଡେଣ୍ଟିଫାଇ କରୁଛି, ଏଇଟାକୁ ଆଇଡେଣ୍ଟିଫାଇ କରୁନା, ବୁଝିପାରୁଛି। କିନ୍ତୁ ଧବଳେଶ୍ୱରକୁ ପାଣି କେତେବେଳେ ଯାଉଛି, ବନ୍ୟା ସମୟରେ, ଫ୍ଲଡ ସମୟରେ, ଯେତେବେଳେ ଏଇଟା ନଦୀ ଯେତେବେଳେ ଫୁଲି ଯାଉଛି, ଦିସ୍ ପର୍ଟିକୁଲାର ୱାଟର ଡଜ୍ ନଟ୍ ଗୋ, ସେଇଥିରେ ଓଭରଫ୍ଲୋ କରିକି ଏଣ୍ଟାର ଟେରେନ୍ ଭିତରେ ହେଇକିରି ସେ ଧବଳେଶ୍ୱର ପାଖରେ ଯାଇକି ନଦୀରେ ମିଶୁଛି। ସୋ ପାର୍ଟଲି ଦ୍ୟାଟ୍ ଇଜ ଟ୍ରୁ, ପାର୍ଟଲି वी आर ट्रू, ବୁଝିହଉଛି। ଗୋଟେ ଏକ୍ସପେରିମେଣ୍ଟ ବି କରିଦଉଛି, ବିକଜ ଦିସ୍ କ୍ୟାମେରାସ୍ ଦେ ଡୋଣ୍ଟ କମିଟ୍ ଏନି ମିଷ୍ଟେକ୍। ମତେ କିଏ ଗୋଟେ ବତେଇଲା, ବର୍ତ୍ତମାନ ଅଳ୍ପ ଦିନ ତଳେ ଫେସ୍ ପ୍ୟାକ୍ କରନ୍ତି, ସେ କଣ ଫେସିଆଲ କରିବା ପାଇଁ। ମୁଁ ଗଲି ଫେସିଆଲ କଲି ମାତ୍ର 7-8 ଦିନ ତଳ କଥା, ଫର ପର୍ଟିକୁଲାର ରିଜନ ମୁଁ ଫେସିଆଲ କଲି ରାତିରେ। ଆ ପୂର୍ବରୁ ଗୋଟେ ଫଟୋ ନେଲି, ଆଗ ନେଇଥିଲି ଗୋଟେ, ତାପରେ ମୁଁ ଆସି ଦର୍ପଣରେ ଦେଖିଲି ଫେସିଆଲ ଗୋଟେ ଅଧଘଣ୍ଟା 45 ମିନିଟ ବିରାଟ ପ୍ରୋସିଜର ପରେ, ଆଇ କୁଡ୍ ନଟ୍ ଫାଇଣ୍ଡ ଏନି ଡିଫରେନ୍ସ। ମଦରକୁ ଦେଖେଇଲି, ମିସେସକୁ ଦେଖେଇଲି, ସେମାନେ ଯେମିତି ଦୁଷ୍ଟ ସେମିତି ଦୁଷ୍ଟ ବୋଲି ସମସ୍ତେ କହିଲେ। ବଟ୍ ହ୍ୱାଟ ହ୍ୟାପେଣ୍ଡ ଦ ନେକ୍ସଟ ଡେ, ମୋର ଯୋଉ ଫେସ୍, ମୋର ମୋବାଇଲ ହଉଛି ଯୋଉ ଫେସ୍ ର ଏଇଟା ଆଇଡେଣ୍ଟିଫାଇ ଯୋଉଟା କରୁଥିଲା, ସିଏ ଆଉ ନେଲା ନାହିଁ ମୋ ମୁହଁ। ସେଇଠୁ ମୁଁ ଆଇଡେଣ୍ଟିଫାଇ କଲି, ଇଟ୍ ମେ ନଟ୍ ଲୁକ୍ ଇନ୍ ମାଇ ଆଇ, ମାଇ ମଦର ମେ ବି ରଙ୍ଗ, ଆଇ ମେ ବି ରଙ୍ଗ, ମିରରରେ ମୁଁ ଯାହା ଦେଖୁଛି ଦ୍ୟାଟ୍ ମେ ବି ରଙ୍ଗ, ବଟ୍ ଦିସ୍ ପର୍ଟିକୁଲାର କ୍ୟାମେରା, ଯିଏ ଆଉ ଗୋଟେ ଆସ୍ତୁଷ ଦାସ ଜାଣିଥିଲା କାଲି ରାତିର, ସିଏ ଆକୁ ଆଉ ଚିହ୍ନୁ ନାହିଁ। ଦ ପିକ୍ସେଲ ଭ୍ୟାଲ୍ୟୁଜ, ଦ ରିଫ୍ଲେକ୍ଟେନ୍ସ ଭ୍ୟାଲ୍ୟୁଜ ଅଫ ଦିସ୍ ପର୍ଟିକୁଲାର ଫେସ୍, ଦ୍ୟାଟ୍ ହ୍ୟାଜ ଚେଞ୍ଜ। ସେ ତାର ଆଲଗୋରିଥମରେ ପକେଇ ଗଣିତ ଦେଖୁଛି, ଦିସ୍ ଇଜ ଏ ଡିଫରେଣ୍ଟ ଭ୍ୟାଲ୍ୟୁ ଇନ୍ କମ୍ପାରିଜନ ଟୁ ଦ୍ୟାଟ୍, ବୁଝିହଉଛି। ସୋ ସିମିଲାରଲି ଆମେ ଯୋଉ ଡିଏମ କୁ ଖାଲି ଗାଳି କରିବା କଥା ନୁହଁ, ସିଏ ଠିକ ସେ ଆଇଡେଣ୍ଟିଫାଇ କରିଛି, ମୋଷ୍ଟ ଅଫ ଦ ଟାଇମ ମେଜର ଫ୍ଲୋ ସେ କୋଉ ପଟେ ଦେଖିଛି, ସେ ତାକୁ ନେଇକି ସେଇଠି ପୁରେଇ ଦେଲା ହେଲା। ସୋ ବିଟୱିନ୍ ଦିସ୍ ଏଣ୍ଡ ଦ୍ୟାଟ୍ वी हैव टू मेक ए डिस्टिंक्शन। Then the stream network generated from the DM fails to capture the distributary network, which I have already told, and that too इतने complex है जाए हम delta टा जोटा, because it is in a formation stage, पूरा पूरी finalized है नहीं। This is arcuate delta, गोटे पटे चिलिका पाखरे तमरा उतरे another जोटी गोटे लेक तियारी ही ची पानी को सेपटे नवा पे बोली की, से जो that's again another multiple delta system, और maybe another 1,000 years it will take to stabilize. So এই জিনিসটা কেবে হেলে মতে ডিএম নেই পারিবনি। ওয়ার্ল্ড মেনি প্লেসেস রে দিস ডেল্টা কো আনালাইজ করিবারে লিমিটেশন অফ আরজিআইএস ইজ অলওয়েজ এ চ্যালেঞ্জ। I am not going detail into this. Producing the spatial data from the point measurements, any raster, any point measurement, the point values ଆମେ ନଉଛୁ, ତାକୁ point କୁ first ଆମେ raster କରୁଛୁ, raster ଦରକାର ପଡେ vector କରୁଛୁ ବା polygonize କରୁଛୁ। ଏଇଥିରେ what are the challenges, ଆମେ point data ଆମର କୋଉ ଟାଇପ ର ଡାଟା ଅଛି, भाव प्रिसिपिटेशन डाटा। प्रिसिपिटेशन डाटा आजिका दिन में आईएमडी हमको दउची फ्रॉम 1901 टिल डेट 0.25 डिग्री बाय 0.25 डिग्री रो ग्रिड रे डेली एनालिसिस, डेली हमको रेनफॉल डाटा हम पाखरे अवेलेबल। सो सेही पॉइंट डाटा को नेकी बर्तमान फर्स्ट क्लिपिंग करिवि मो बेसिन रे, डाटा नै आसली, जति कि डाटा मो दरकार बड़ एरिया पे नै आसली, ताको बर्तमान मोर जो बर्तमान डेलिनेटेड बाउंड्री अछि, ए डेलिनेटेड बाउंड्री मो तो क्लिप करूची। While clipping, what methods one should adopt? ता ऊपर some discussion I think I am going to make. Even groundwater level ऊपर आमे किछि काम करथिलु ए केस रे, before going for a interpolation, any interpolation you need in order to delineate a boundary, value अछि एठी, value अछि सेठी, से तो हरिकरी linear interpolation करिवो कि IDW करिवो कि kriging करिवो, there are many 8 or 9 different algorithms। गोटा कले कोन हुए तापर I am going to discuss, but before that सुंदर मते WS रे जो first law of geography थिला कि everything is related to everything else, but near things are more related than distant things। এই যে philosophy को नेगिरी आमे create करथिले गोटे standard and most popular interpolation mechanism, that is IDW, inverse distance weighting। ଆଉ ଗୋଟେ ହଉଛି ତମର କ୍ରିଗିଂ। କ୍ରିଗିଂ ହଉଛି ଗୋଟେ honest linear ବାବାजी। ହେଲା ସିମ୍ପଲି ଆମେ ଯାହା କରୁଛେ ନର୍ମାଲି ଏଇଠି ଭ୍ୟାଲୁ ହେଲା 5 ସେଇଠି ଭ୍ୟାଲୁ ହେଲା 7 ଲାଇନରେ ଯୋଡ଼ି ଦିଅ ଏଇ ପାଖରେ ୟା ଡିଷ୍ଟାନ୍ସ ବାଇ ତା ଡିଷ୍ଟାନ୍ସ 5/7 କରିକି 5.65 ଆମେ ଯୋଉଟା ଷ୍ଟାଣ୍ଡାର୍ଡ ଯୋଉଟା କରୁଥିଲୁ ଦ୍ୟାଟ୍ ଇଜ କ୍ରିକିଂ ଦେନ୍ ଦିସ୍ ଇଜ ସ୍ପ୍ଲାଇନ୍ ସ୍ପ୍ଲାଇନ୍ ଡଜ୍ ନଟ୍ ଅଣ୍ଡରଷ୍ଟାଣ୍ଡ ଏନିଥିଙ୍ଗ ସ୍ପ୍ଲାଇନ୍ କଣ କରେ ଏଭ୍ରିଥିଙ୍ଗ ସୁଡ୍ ବି ସ୍ମୁଥ ଗୋଟେ କର୍ଭିଲିନିୟରିଟି ନେଇକି ସେ ତାର ସେ ଆନାଲିସିସ୍ କରିବ ତା ପାଇଁ ବୋଲି ଡାଟାକୁ ବି ଭାଙ୍ଗିଦବ ଏରର କରିଦେଇ ପାରିବ କୋଉଠି ଗୋଟେ ଗୁପ୍ଚା ହେଇଯାଇଛି ତାର ଫିଟ୍ ହଉନି ସେ ଏମିତି ଚାଞ୍ଚିକି ନେଇ ପଳେଇବ ସେ ଭ୍ୟାଲୁଟା ହାଇ ଭ୍ୟାଲୁ ତାକୁ କାଟିଦେବ ପାହାଡ଼ଟେ ଅଛି କଣଟେ ଅଛି ସିଏ ତାକୁ ମାନିବାର ନାହିଁ ବଟ୍ ଏଜ୍ ହୋଲ୍ ଏଣ୍ଟାୟାର ଥିଙ୍ଗ ୱିଲ୍ ବି ଲୁକିଂ ସ୍ମୁଥ ଏଣ୍ଡ ସମସ୍ତଙ୍କର ବିୟୁଟି ଅଛି ତମେ ବର୍ତ୍ତମାନ ରେନଫଲ୍ ଡାଟାକୁ ଇଣ୍ଟରପୋଲେଟ୍ କରୁଛ ନା ଗ୍ରାଉଣ୍ଡ ରିଆଲିଟି ଟୋପୋଗ୍ରାଫିକୁ ଇଣ୍ଟରପୋଲେଟ୍ କରୁଛ କି ଦ ଗ୍ରାଉଣ୍ଡ ୱାଟର ଲେଭେଲ ଗୋଟେ ବହୁତ ବଡ଼ ଏରିଆର ସେଇଠି ବହୁତ ପ୍ରୋବ୍ଲେମ ହେଲା ମୁଁ ଛୋଟ ଏକ୍ସାମ୍ପଲଟେ ବି ଦେଇଦଉଛି ଏଠି ଗ୍ରାଉଣ୍ଡ ୱାଟରଟା ୟୁଜୁଆଲି ସ୍ଲୋ ମୁଭିଂ ନଦୀରେ କଣ ଥିବ ଏବେ ବର୍ତ୍ତମାନ ଭୁକିନା ପାଣି ଅଛି କାଲି ସକାଳେ ଦେଖିଲା କିଛି ବି ନଥିବ ପାହାଡି ନଈ ତ ଘଣ୍ଟେ ଦେଢ ଘଣ୍ଟା ଭିତରେ ଗୋଟେ ବିରାଟ ଫ୍ଲଡ୍ ତାପରେ ପୁରା ଡ୍ରାଇ ବେଡ୍ ବି ହେଇଯିବ କିନ୍ତୁ ଗ୍ରାଉଣ୍ଡ ୱାଟର ଡଜ୍ ନଟ୍ ହ୍ୟାପେନ୍ ସୋ ଗ୍ରାଉଣ୍ଡ ୱାଟର ଇଜ ମୋଷ୍ଟ ସସେପ୍ଟିବୁଲ ଟୁ କ୍ରିକିଂ ଅର୍ ସ୍ପ୍ଲାଇନ୍ସ ପ୍ରାୟତଃ ପ୍ରାୟ କ୍ରିକିଂ ବଗେରା ସେଠି କରନ୍ତି ସେଇଠି କଣ ହେଇଛି ଯଦି ତମର ଆକ୍ୟୁଫରରେ ଯଦି ଡିସକଣ୍ଟିନ୍ୟୁଟି ଅଛି ଇଟ୍ ମେ ସୋ ହ୍ୟାପନ୍ ସ୍ପ୍ଲାଇନ୍ ଦେଇଛେ ଆମେ ବହୁତ ବେଶୀ ପାଣି ଥିବ ହଠାତ୍ ଏଠି ପୁରା ଜିରୋ ହେଇଯାଏ କାହିଁକିନା ଏଇଠି ବର୍ତ୍ତମାନ ଡିସକଣ୍ଟିନ୍ୟୁଟି ଏ ପାଣି ଏପଟେ ଆସିପାରୁନାହିଁ ଏ ପାଣି ସେପଟେ ବେସ୍ ଫ୍ଲୋ ନଦୀରେ ସିନା ବାହାରିବ ଏ ପାଣି ଏପଟେ କଣ୍ଟିନ୍ୟୁ କରିପାରିବନି ଆମେ ଯଦି ସ୍ପ୍ଲାଇନ୍ କରି ଯଦି ସ୍ମୁଥ କରିଦବା ସେଟାକୁ ତାହେଲେ ସେ ପାଣିଟା ରିଫ୍ଲେକ୍ଟ ହେଇଯିବ ଡାଉନ୍ ଷ୍ଟ୍ରିମ୍ରେ ସୋ ଦ୍ୟାଟ୍ ପର୍ଟିକୁଲାର ଡିସକଣ୍ଟିନ୍ୟୁଟି of the aquifer cannot be arrested so these are the challenges we have faced ମୁଁ ତ theory କି ବି ଯାଉନି after all ସାରିଦେବି ମୁଁ ଏଠି I will be completing it and I will be believing that because you are all exposed to this ବହୁତ ସମୟରେ କାମ କରୁଛ this weighted influence କଣ power function କଣ inverse distance ରେ ଆମେ ତାକୁ square ନେଇକିରି କଣ କରୁ neighborhood searching method କଣ these things you know but kriging is mostly autocorrelation methodology kriging ଟା basically ଆମର ground data ବାଲା ବହୁତ ୟୁଜ କରନ୍ତି ନର୍ମାଲି ସେମାନେ kriging କରନ୍ତି ଆମେ ସବୁ IDW କରୁ ଆମର ଯୋଉ ରେଞ୍ଜ ନେକ୍ସଟ ଆପଣ କଣ କରନ୍ତି ସାର୍ ଆପଣ ମଡେଲ ପ୍ରାୟ इंटरपोलेशन बेसिकली ଯେତେବେଳେ ଆପଣ ଇଣ୍ଟରପୋଲେସନକୁ ଆଡପ୍ଟ କରନ୍ତି ଆମେ ଯୋଉ କଲେ ବୈତରଣୀ IDW normally ଆମମାନଙ୍କର surface ବାଲା ଯୋଉମାନେ ଆମେ IDW କରୁ ground dot କରୁ they mostly prefer this kriging methods a spline is a typical mathematical function which minimizes the overall curvature curvature part ରେ ସେ smoothing ଗୋଟେ ଆଣେ all the oddities ସେ ସେଟା ସାରିଦିଏ ବର୍ତ୍ତମାନ you can see also from this ଆମେ ବର୍ତ୍ତମାନ ଆ ପାଇଁ ଯେତେବେଳେ ବିଭିନ୍ନ ଡିବେଟର ସମ୍ମୁଖୀନ ହେଲୁ ଏଇଟା ଆମେ ପ୍ରେଜେଣ୍ଟ କରାହେଇଥିଲା ସେଠି ମାନଙ୍କର କ୍ରିଗିଂ ଭର୍ସେସ୍ IDW the same thing how different both the two things are data remaining same you are doing a interpolation business for a particular sub-basin what identification କରିବା ପାଇଁ kriging kale you will be getting a separate result IDW kale you will be getting separate result ତା ମାନେ ହଉଛି even as a professor when you are giving an assignment to multiple students first of all please develop a protocol ଏ ସବୁ protocol develop ନ କଲେ ୟାର ଗୋଟେ ଆସିବ ତାର ଗୋଟେ ଆସିବ comparison ପାଇଁ there is no platform ଗୋଟେ particular framework ଭିତରେ one has to operate nothing is wrong and nothing is right ଆମେ ତ କେବେ ଦେଖିପାରିବାନି ground reality କଣ ଅଛି ବୋଲି we have to adopt a principle believe upon a particular algorithm but ଯାହାଟା ବି କରିବା in order to get the uniformity out of it we must first decide a protocol similarly ଆମେ ଏଇଠି ଏଇଟା ବି କରିଥିଲୁ this ତିନିଟା ମୁଁ comparison କରିଛି ଏଠି from that you can understand how smooth the spline is IDW ଆମ ମାନଙ୍କର most preferring thing this is a kriging linearly everything is varying which is more suitable for a subsurface groundwater movement ପାଇଁ this kriging is more applicable so same data set but the তিনিটা surface generate ଆମେ କରିଛେ by three different interpolation methods ରେ so this gives you a fair idea but when you are doing your work which interpolation method you are going to use now ଏଠି ଆମେ ଯୋଉ ଗ୍ରାଉଣ୍ଡ ୱାଟର ଡାଟା କରିଥିଲୁ ମୁଁ କାହିଁକି କହୁଛି ଆମ ପାଖରେ କିଛି ପଏଣ୍ଟ ଡାଟା ଥିଲା ସେମାନେ ଗୋଟେ ଆମ ଗୋଟେ ପର୍ଟିକୁଲାର ୱାର୍କ ଥିଲା 1985 ଅନୱାର୍ଡସ ବର୍ଷକୁ 4 ଥର ଗ୍ରାଉଣ୍ଡ ୱାଟର ଡାଟା ଆମକୁ ମିଳେ ପ୍ରି ମନସୁନ ପୋଷ୍ଟ ମନସୁନ ଲିନ୍ ସିଜନ ସମର ସିଜନ ଏଇ ସମୟରେ ଭିଜୁଆଲ ଫର୍ମାଟରେ ମିଳେ ୱାଟର ଟେବୁଲଟା ସରଫେସ ଟୁ କେତେ ତଳେ ପାଣି ଅଛି ବିଲୋ ଗ୍ରାଉଣ୍ଡ ୱାଟର ଲେଭେଲ ସୋ ତାକୁ ନେଇକି ଆମକୁ ଗୋଟେ କଣ୍ଟୁର ବନେଇବାକୁ ପଡୁଥିଲା ଦରକାର ପଡିଥିଲା ଗୋଟେ ରାଷ୍ଟର ଡେଭଲପ କରି ସରଫେସ ଡେଭଲପ କରିବାକୁ ପଡୁଥିଲା ଗ୍ରାଉଣ୍ଡ ୱାଟର ସରଫେସଟା ଦିସ୍ ଇଜ ନଟ୍ ଦିସ୍ ସରଫେସ ବୁଝିପାରୁଛି ପ୍ରତ୍ୟେକ ବର୍ଷ ପାଇଁ ଅଲଗା 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 ଆଲଗୋରିଥମ ଆମେ କରିଥିଲୁ ଏଇଟା ମୁଁ ଆଟ୍ରିବ୍ୟୁଟ ଟେବୁଲଟା ଖାଲି ଦେଖଉଛି ଏଠି ଆମ ପାଖରେ ଥିଲା ଗୋଟେ ୱେଲର ନାଁ ସେ ୱେଲର ଲାଟ ଲଙ୍ଗ ତା ସହିତ ଗ୍ରାଉଣ୍ଡ ୱାଟର ଲେଭେଲ ଆଣ୍ଡ ଲୋକେସନ ଏଇ ଡାଟା ପ୍ରୋସେସ କଲା ବେଳକୁ ଆମ ପାଖରେ ଯେ ଚ୍ୟାଲେଞ୍ଜ ଆସିଥିଲା which particular table we are going to give ମାନେ କୋଉ interpolation algorithm that you are going to give because the z value field which is to be interpolated in this case is groundwater level for a specific year 1986 ନା କଣ ଆମେ ଦେଖିଥିଲୁ ପୂର୍ବ ଟେବୁଲରେ ଥିଲା ଏଇଟା 1986 ନା 23 ଗୋଟେ particular date ପାଇଁ ଥିଲା So it will be the enormous amount of data you cannot imagine in so big a basin, around 22,000 well. So all this well data ଏଭଳିଆ format ରେ ଯାହାଟା କରିବ ପ୍ରତ୍ୟେକ ବର୍ଷ ସେମାନଙ୍କ ଡାଟା ତା ଭିତରେ ପଶୁଥିବ, surfaces will be generated. Surface to surface ର comparison ରେ ଦେଖାହବ ଯେ ଆଙ୍କୁ ଯଦି profiling ଆମେ କରିବୁ from 1986 up to 2020 ଏଇ ground water summer season ରେ କେମିତି vary କରିଛି ତାର trend etc needs to be established. which singularly ବି ଗୋଟେ thesis ହେଇଯାଇପାରିବ ଯଦି ଦେଖିବ ତମେ ଯଦି ସେ style ରେ। ଏଠି ଆମେ ଯେ output raster surface to be extracted for the area of interest ଆମେ ବାହାର କଲୁ ଏଠି finally ଆମର ଯୋଉ output ଟା by means of kriging IDW first ହେଇଥିଲା ପରେ ଆମେ kriging କରି ଯାଇ ground water table ଟା ବାହାର କରିଥିଲୁ। ବର୍ତ୍ତମାନ some of the tips I want to give you at this context ଆମର ଯୋଉ interpolation ର ଯୋଉ experience ରୁ ଯଦି aquifer discontinuity ଯଦି ଆମେ କହିଦେଲେ ଯଦି if it is present then the smooth surface of groundwater will not depict the ground reality. So never go for a spline, never go for your IDW and kriging. Go for other methods are there. Raw ରଖିଲେ ବି better. ଯେ ଥରେ ତମେ ଜାଣିଲ ଯେ discontinuity ଅଛି, put it raw and ତା ପାଇଁ ବୋଲି ଅଲଗା algorithms are available. Consider the spatial scale and resolution of your analysis. ମୁଁ କେତିକି area ନଉଛି, କୋଉ purpose ପାଇଁ ନଉଛି, what is my scale, what is my resolution. ତାପରେ only go for taking a decision about the interpolation method, which method you are going to use. Nothing that ସିଏ ନେଇଛି ମୁଁ ନେବି, ତା area ଅଲଗା, ମୋ area ଅଲଗା, ତାର point of interest ଅଲଗା, ମୋର ଅଲଗା, ସେ rainfall analysis କରୁଛି, ମୁଁ ground water କରୁଛି, ସେ ଅନୁସାରେ interpolation choosing is very important. Otherwise different and inaccurate results will be obtained. ଆମେ ଯେ LULC ଥିଲା ଆମ ପାଖରେ LULC ର ଇମ୍ପୋର୍ଟାନ୍ସ କାହିଁକି ଆପଣ ଏଠି ଏକ୍ସପେରିମେଣ୍ଟ କରୁଛନ୍ତି ଆମକୁ କୁହାହେଲା 1985 onwards every 5 year interval ରେ land use land cover patterns ବନେଇକି ଦିଅ of 21 different parameters ଆମକୁ ସେତିକି ମିଳିଲାନି ଆମେ ଯୋଉ ଆଣିଥିଲୁ ଏଇଟା LULC ବୋଧେ NRSC ଦେଲା NRSC ରୁ just ଆମେ ଯୋଉ ଆଣିଲୁ 5 interval ରେ ଆମେ କୋଉଠୁ ପାଇଲୁ ମୁଁ କହିଦଉଛି 5 6 ରେ ମିଳିଲା 11 12 ମିଳିଲା 15 16 ମିଳିଲା 21 22 ମିଳିଲା ଆ ପୂର୍ବରୁ 85 90 95 ର ଇଣ୍ଟରନ୍ୟାସନାଲ ସୋର୍ସ ରୁ ମିଳୁଥିଲା। These are the data which you have analyzed. এটা ଆମେ ହଁ these ଆମେ ସାଇଟ୍ ବି ଦେଇଛୁ ଏଠି these are ଏ ଯୋଉ other data କୁ ଆପଣ ଓକ୍ରିଜ ନ୍ୟାସନାଲ ଲାବୋରେଟୋରୀ ଡିଷ୍ଟ୍ରିବ୍ୟୁଟେଡ୍ ଆକ୍ଟିଭ ଆର୍କାଇଭ ସେଣ୍ଟର ORNL DASE ୱେବସାଇଟ୍ ରେ ଯଦି ପୁରୁଣା ଡାଟା ଦରକାର 1985-90 ରେ ସିଚୁଏସନ କଣ ଥିଲା କଟକର କଣ ଥିଲା ମହାନଦୀ ବେସିନର କଣ ଥିଲା ସମ୍ବଲପୁର କଣ ଥିଲା ସୋନପୁର କଣ ଥିଲା ଏବଂ ତା ସହିତ ଯଦି କମ୍ପେୟାର କରିବ ତମର ବିଲ୍ଡିଂସ୍ କେତେ ବଢିଛି ରିଆଲିଟି କେତେ କମିଛି ମାଇନ୍ସ କେତେ ହେଇଛି ଏଗ୍ରିକଲଚରାଲ ଲ୍ୟାଣ୍ଡ କେତେ ହେଇଛି ଲୋକ ରବି ଅଧିକା ବଢେଇଛନ୍ତି ନା କମେଇଛନ୍ତି ଅଲ୍ ଦିସ୍ ଡିସିସନ୍ସ ଆମେ ଯାହା ନବାକୁ ପଡିଥିଲା so a series of data set that had been analyzed by us and this soil data basically we got it from NBSS and LUP so ସେମାନେ soil data collect କରନ୍ତି ଆମେ ଯୋଉ soil data ଦରକାର ପଡିଲା ତାର ଏଇ parameter ତକ ନେଇକି କାମ କରାଯାଇଥିଲା initial abstraction field capacity wilting point permeability ଏଇ parameter ତକ built in କରିକି ଆମେ the grid ରେ same GIS format ରେ this was to be submitted to the model जो model पे ଆମେ ନବୁ SWAT ବି ନିଏ ଭିକ୍ ବି ନିଏ ସମସ୍ତଙ୍କୁ ଦରକାର ଏଇ ଯୋଉ ମଡେଲଟା ସଏଲ ର ଗ୍ରିଡ୍ ବାଇ ଗ୍ରିଡ୍ ବଟ୍ ୟାର ବୋଧେ 1 କିଲୋମିଟର ବାଇ 1 କିଲୋମିଟର ଗ୍ରିଡ୍ ରେ ଦେଇଛି NBSS and LP ଆମର ହଉଛି DM ଗ୍ରିଡ୍ ଟା 30 ମିଟର ବାଇ 30 ମିଟର even there are some particular temperature data ଟା ବୋଧେ ମିଳୁଛି high and low temperature daily that is also 1 kilometer by 1 kilometer so this is the last but one slide most probably ଆମେ ଯୋଉ rainfall data ଆଣିଥିଲୁ then ତାପରେ ମୁଁ just ଖାଲି ଛୋଟିଆ comparison ଟେ କରୁଛି this is a data set of 22 ଜୁଲାଇ 2018 actual ସେ ଦିନର ତାର ଆମେ normalcy ନେଇକି ଆମେ ଯୋଉ deviations ବାହାର କରୁ anomaly this is the anomaly feature ଆମ ପାଖ ରେକର୍ଡ ଅନୁସାରେ ଏତିକି ଇଏ ଦେଲା ବର୍ତ୍ତମାନ IMD ଦେଲା ଏତିକି whether to what extent it is to be relied or not relied ତା ପାଇଁ ମଧ୍ୟ ଆମେ anomaly error chart ବନେଇକି ରଖିଛୁ ଆମ ପାଖ ଡାଟା ଅନୁସାରେ କଣ IMD ର ଗ୍ରିଡ୍ ଯଦି ଆମେ derive କରୁଛୁ ତାର ଡାଟା କଣ so basically sum total how much is the error and finally I am coming to the last phase of my presentation undoubtedly ଆମେ ଏତିକି ସମୟ ଯୋଉ discussion କଲେ GIS is a very powerful tool it can give enormous support to us but it's a double-edged sword it has the capacity to injure you to overwhelm you to abandon you to astonish you by the results that it gives ତା ପାଇଁ ଗୋଟେ ମାତ୍ର ସଲ୍ୟୁସନ ହଉଛି ଯୋଉ କାମଟା କରୁଛ ତାର ରିଆଲିଟି ତାର ଗ୍ରାଉଣ୍ଡ ଟ୍ରୁଥିଂ ନ କରିକି ସିମ୍ପଲି ଡେସ୍କଟପ ରେ ବସିକି GIS ର ଆଉଟପୁଟ କୁ ନେଇକିରି ବହି ବାନ୍ଧନ୍ତୁ ନାହିଁ ବୋଧେ ଆମେ 4 ଥର 5 ଥର ଯାଇକି ସାପୁଆ ବୁଲିକି ଆସିଲା ପରେ we could discover ମୋର ଯୋଉ ଫେସିଆଲ ଥିଓରି ମୁଁ ଜାଣିଲି ଯେ ନା ସେଟେଲାଇଟ ଏତିକି ବି ଭୁଲ କରିନି ସେ ଗାଁ ଲୋକ ଆମକୁ କହିଲେ, ସାର୍ ଆପଣ ଦେଖୁଛନ୍ତି ସିନା ସାର୍, ଏ ଗୋଟେ ବଡ ବର୍ଷାଟେ ହେଇଯାଉ ଆଜ୍ଞା, ଏ ପାଣିଟା ଏପଟୁ ବନ୍ଦ ହେଇଯିବ ଆଜ୍ଞା, ସେପଟେ ଚାଲିବ। ସେପଟେ ତ ନଦୀ ନାହିଁ, ସେ ରେଲୱେ ଉପରେ ଆଜ୍ଞା, ଟ୍ରେନ ବନ୍ଦ ହବ ସେତିକି ସମୟ। ତାପରେ ଆମେ ଜାଣିଲୁ ଯେ ନାଇଁ, ଦେयर ଇଜ ଆନାଦର ପାଥୱେ, ନଦୀ ନିଜେ ଡିସାଇଡ କରିଦେଇଛି ସେପଟେ ଯିବ, ଯଦି ଏପଟେ ତାକୁ ବଳ ନ ମିଳିବ। ଏଇଟା ଚାଲିଛି, ଦିସ୍ ମେଥଡୋଲୋଜି ଇଜ ରନିଂ, ଏବଂ ସିଏ ତାକୁ କ୍ୟାପଚର କରିଛି ହେଲା। ସୋ ଇଟ୍ ଇଜ ନଟ୍ ଦ୍ୟାଟ୍ ଇଜ ଅନେଷ୍ଟ। ସୋ ଏଇଭଳିଆ ମାନେ ଜିଆଇଏସ୍ ସହିତ when I'm gaming, when I'm planning, when I'm thinking, when I'm strategizing, ଏସବୁ ଯାହା ଯାହା ବି କରୁଛି, when I'm putting a diplomacy into it, when I'm creating a governance out of it, when I'm developing a protocol based on GIS, ଯାହାଟା ବି କରୁଛି, it's very very essential to have a ground truth touching over it, and let us wait, many other things will be further simplified in future, ଯୋଉଟା ମୋ ପାଇଁ ଚ୍ୟାଲେଞ୍ଜ ଥିଲା, ଯାହା ଯାହା ଆମ ମାନଙ୍କ ପାଇଁ, maybe in 5 to 10 years hence from today, new versions will come and those things will be addressed in a much easier manner. Thank you so much.
କିଛି queries ଅଛି ପିଲାମାନେ, ଯୋଉମାନେ queries ଅଛି କି? ନିଶ୍ଚିତ ଭାବରେ ତମେ କାମ କରୁଛୁ, ନହେଲେ ମୁଁ ଇଣ୍ଟରଫେୟାର କରିବି ହେଲା, ମୁଁ ପଚାରିବି ତମକୁ।
ନହେଲେ ଗୋଟେ କାମ କରିବା, ଖାଇଲା ବେଳକୁ ଯଦି
ସାର୍,
ପିଲାମାନେ ଯଦି ଅଛନ୍ତି, you are fully free to interact with me directly or indirectly, formally or informally.
thank you, sir, for this kind of highly knowledgeable ideas, highly knowledgeable share your thoughts. It is very difficult that three people were giving this kind of knowledge to you. So when it is an integration of training and teaching, then perhaps you might understand that how the GIS was and how if field people also can go to such an extent. One of the things I suddenly interested that we shall undertake this software study. And we also would have taken the supervisor study as a grant work out of our interest. And this software is also a challenging task, and definitely we shall be taking care of. And Sir has told that feel and see. I shall be telling that there are two indices in infiltration indices we call. One is phi index, one is W index. And perhaps these fields in they play this kind of role. Why phi index? Phi index tells that there is an average value of loss, average value of loss, and W index, that is another significant indices, but but that undertake that what are the depression storage, what are other losses they undertake. But when coming to phi index, it assumes that everything is plain. So by adopting phi index, what we are doing? We are making a average value. We are not going every time that depression storage to be counted. So field sync almost play this kind of role. So other things that reconditioning of the DM. Presently, I was working in the Uttarakhand Fort and Jodi, and last 15 days I was in a dilemma that because of my GIS expert who is working with me, he has told me, sir, there are a number of problems. My river flow is not continuing when I am making the model. So I thought, why it is not right? I have told that you show me, then I have given that DM to two, three persons. Why please see whether there anything wrong in that. So nobody has told affirmative. So everyone told them, no, sir, this is a warning error, this error, that error. In that way, everybody, I have said to I have two persons also. But the same way they have replied. Then I have sorry. I have gone through the literature and other things, and I found that yes, the stream bonding is possible, and you try with the stream bonding. The moment I have tried the same thing, same modeling, the stream bonding, and by filling the kind of the gaps I have filled, personally I have verified, rechecked the DM, then I found that the river again got the modeling done, everybody was happy. So, Sir has rightly told that the things should be continuing and you have to understand your problem. And particularly projection system and this kind of interpolation, that depends upon your choice and what kind of work you are working. And for that also you have to make literature survey and the result, your result should be implicating in the field also. So that is highly necessary, and please take care of your GIS result. Not only that, whatever you want, that is your answer. No, that should be verified. That should be validated. Otherwise, it is up on you. So, thanks again, sir, because you have worked at this high position with the thing that these are supervisory roles. Only you have to manage everything. No, you are worked in that way. So we are very happy and thanks that you have come here and delivered. So again, thank you, sir. Thank you.
So now we are going to start our session, second session. Today's second session, we have guest Dr. Mahendra Kumar Bhuya, retired EICD DO Department of Water Resource. I would like to introduce him with you all that he was working as an engineer in chief in the Department of Water Resources, Odisha, having expertise in hydrology and water resource sector. 35 plus in experience in the field of academic, education, and industrial structure, design, planning, and executions of all sorts of water resource structures. So, after 2 minutes, we will start our second session. Thank you.
গেল না, কখন এলো? ଏବେ ହବ ଦେଖନ୍ତୁ। ହଁ, ଏବେ ଗଲେ, ଦେଖ ବଡ ଗଲେ।
ଆଗିପାରିବ ମାଉସ ଭିତରେ
ମାଉସ୍ ନାହିଁ ସାର୍, ଇଏ ଅଛି
ମୋड
ସାର୍।
ଅଛି ମାଉସ
ହଁ, ମୁଁ ବାକି ସାର୍ ପେନ୍ ଗୋଟେ ସାର୍ ପେନ୍ ଡ୍ରାଇଭ୍ ଇଏ ଅଛି ତ ସାର୍, ଏଇଟା ଏଇଟା କପି କରିଦେଇଛି।
କପି କରିଦିଅ।
ମାଉସ୍
ମୋଟା ନେଇ ଆସିବି, ମୋ ସେଟଟା ନେଇ ଆସିବି। ଠିକ ଅଛି କର।
ଖାଲି ଖାଲି ମାଉସ୍ ସାର୍, ସାରଙ୍କର ମାଉସ୍ ଟା ଖାଲି।
ମୋଟା ଅଛି ମୋ ସବୁ।
ସାରଙ୍କୁ ପେନ୍ ଡ୍ରାଇଭ୍ ଦେଇ ଦେଇଛୁ ସାରଙ୍କୁ।
ଓ ସାର୍ ହଁ ସାର୍, ଖାଲି ଦେଇଦେଇଥିଲି।
ମାଉସ୍ ସାରଙ୍କୁ ଏଇଟା ଦେଇଦେବା।
ସାର୍ ନା ଏଟା ନେବେ କି ସାର୍? ପଏଣ୍ଟର
ପଏଣ୍ଟରଟା ସାର୍ ମାନେ ଚେଞ୍ଜ କରିପାରିବେ, ମାଉସରେ
ନା
ଆପଣ କେତେ
ମାଉସ୍
ଚେଞ୍ଜ?
ମୁଁ ଏଥିରେ
ଓ ସରି ସରି ସାର୍।
ଟିଚର କୁଆଡେ ଗଲେ? ଆମର ଗ୍ରେଟ୍ ଅନଲି ସାର୍ କୁଆଡେ ଗଲେ? ତାହେଲେ ଆଉ 2 ମିନିଟ୍ ଅପେକ୍ଷା କରିବା। ହୁଁ
ଚା ଟିକେ ପିଇକି ଆରମ୍ଭ କରିବା ନା? ଚା ଟିକେ ପିଇକି ଆରମ୍ଭ କରିବା।
ହଁ ଦିଅ ଦିଅ।
ସାର୍ ଟିକେ ଟିକେ କରିକି ଆରମ୍ଭ କରିବା। ଆଚ୍ଛା ପିଲାମାନେ ଆସ, ସାଙ୍ଗେ 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 5 ମିନିଟ୍। କଣ କହିବ? ଦେଖି କରିପାରିବ।
After that, we will start our second session. Second session, we will go for a training session for only for 5 minutes. So, you have
ପୁରା ସ୍କ୍ରିନ୍ ଟା ସେୟାର
yes, user
ଯେହେତୁ ସ୍କ୍ରିନ୍ ଆମର ଯେହେତୁ OBS ହଉଛି ହେଲା, ତ ଆମକୁ OBS ମେଥଡ ରେ ହିଁ ଆମକୁ ସ୍କ୍ରିନ୍ ଶୋ କରିବ। ଏବେ ଦେଖ ସପୋଜ ମୁଁ ଧର ଏଇଠି କରୁଛି ହେଲା, ଇଏ କଲି ହେଲା, ଏଇଟା କଲି ଡିସପ୍ଲେ ସେଟିଂ। ଆପଣ ଏଇଟା କୋଉଠି ପକେଇଛନ୍ତି? ହଁ ଦେଖିଲେ ଏବେ ଚେକ୍ କରୁଛୁ। ହଁ ଆମେ ସେଇଟା ଦେଖୁଛୁ। कोई नहीं पूरा भीड़ जगह में এখানে সকালে ইয়েটা চেক করতে বলো। চলো চলো
ହଁ ହଁ ନା
କହ ଟିକେ ଟେମ୍ପରେଚର କମ କରନ୍ତୁ।
ନର୍ମାଲ କରିଦିଅ ଯେତିକି ଥଣ୍ଡା ଅଛି ଆଉ।
ନାଇଁ ପୁରା କଟି ଯାଉଛି। ନାଇଁ ତ ଠିକ ଅଛି। କଟି ପୁରା ସ୍କ୍ରିନ୍
ପାଣି ପିଅନ୍ତୁ ସେଟା ମୁଁ ଆଉ ଗୋଟେ ବୋତଲ
ମୋ ମୁଣ୍ଡକୁ ମୁଁ ନିଜେ ମଝିରେ ମଝିରେ
ନାଇଁ
ଆରେ
ସାର୍
ଦେଖ ମା
ହବ
ପାଠଟା କୋଉ ଲେବୁଲକୁ ଚାଲିଗଲାଣି ଅଣ୍ଡରଷ୍ଟାଣ୍ଡ he is an engineering chief but he has done this kind of business
ଯୋଉଟା ସାର୍ ପ୍ରୋଜେକ୍ଟଟା ସାର୍ ମୁଁ କହିଲି ସାର୍ ସେଇ ସାର୍ ସେଇ
ସେଇଟା ତମେ ଜାଣିବା ଦରକାର ଯେ ପାଠର ଲେବୁଲଟା ମତେ ହେଇ
ତମେ ଆସୁନ କଣ ପାଇଁ ଆଗରୁ ଏବେ ଆସିଛ
ଆଉ ତ ସବୁ କେମିତି
ଆଉ ସମସ୍ତେ
ହଉ ତୁ ବସିବୁ ନା ଯିବୁ ହଁ ଗୋଡ ଖଟ ଖଟ କରି ଯୋଉ ଚାଲୁଛି ଯେ ଗୋଟେ ଦେବି ଏଥର ମୋ ଇଚ୍ଛା ହଉଛି ହାଣି ଦେବି ସେ ଗୋଡକୁ ଯୋଉ ଗୋଡ ଖଟ ଖଟ ହଉଛି
ପିଲା ପଳେଇଲେ ମୁଁ ତାଙ୍କୁ ଅଟକେଇଲି ତାଙ୍କ କ୍ଲାସ ଥିଲା
ସେ ମତେ ଅଟକେଇଲେ ତାଙ୍କ କ୍ଲାସ
ଏଠି ଗୋଟେ ଅଣ୍ଡରଷ୍ଟାଣ୍ଡିଂ ଲେବୁଲ ଟା ସେଇ ଲେବୁଲକୁ ନ ନେଲା ଯାଏ ଏ ପାଠଟାକୁ ଧରିବା କଷ୍ଟ
ସିରିୟସ୍ ସାର୍
ହେଲା
ସେ କ୍ଲିୟରଲି କେତେ ଡେପ୍ଥ ଯାଇକିନା ବୁଝଉଛନ୍ତି ପୁରା
କେତେ
ନର୍ମାଲାଇଜ
ଡେପ୍ଥ ଟାକୁ
କରିକିନା
ଯିବାର ଅଛି ଏବଂ ସେଟା ଇଏ କରିବାର ଅଛି
ପୁଣି କେତେ
ମୁଁ
ସ୍ମୁଥଲି
ସେ ଭାବୁଛି ହଁ, କାଳେ ମୁଁ ଲାଇନ ଚେଞ୍ଜ କରି ଗୋଟେ ଭୁଲ କରିଦେଲି ମତେ ହେଲେ ସେ କାମ
ହଁ
କରିଥାନ୍ତି
ସାର୍ ସେଟା କେତେ ଇଣ୍ଟରେଷ୍ଟିଂ ଆଉ
ଆମେ
ପ୍ରାକ୍ଟିକାଲ
ଏଠି କଣ
ଜିନିଷ
କରୁଛେ
ସେଇଆ।
ସୋ ଟିଚିଂ ଆଣ୍ଡ ତାକୁ ପ୍ରାକ୍ଟିକାଲି ଆପ୍ଲାଏ
ବହୁତ
କଲା ବେଳକୁ
different।
କେମିତି ଜିନିଷଟା ହଉଛି
ଥିଓରି ଥିଓରି ହେଇକିନା ସାର୍ ମାନେ କିଛି ଖାଲି
ଜୋର ସେ
ସେଟା
କିଏ
ଦେଖି ଦେଖି
7 ପାଇଲା କିଏ 8 ପାଇଲା କିଏ 10 ପାଇଲା ସେ କହିବ ମୁଁ ଆଉ ଥରେ ପାଇବି ସେ ପିଲା କହିବ ମୁଁ ସାର୍ ଏତେ ଲେଖା क्या लिखा है
ଠିକ ଅଛି
हाँ
ଠିକ ଅଛି ସାର୍
ନା ପିଲା କହୁନାହାନ୍ତି ସାର୍ ମୁଁ 3 ପେଜ
ଭଏସ
ଲେଖିଛି
କମେଇଛ
अबे
ନା
3
ବନ୍ଦ
पेज क्या
କରିଦେବେ
लिखा है
ଭଏସ
ପଢିବ
ଭଏସ
ସେଇଟା
ବନ୍ଦ
ପଢିବ
କରିଦେବେ
क्या लिखा है
ସାର୍ ଭଏସ ବନ୍ଦ କରିନାହାନ୍ତି
Huh? Yes. Okay. So as I told you, plastic concrete means any concrete which is in the wet form, that is plastic. But in case of the standard concrete, what happens after final setting time? It gets hardened. So this is no longer plastic. But this plastic concrete will behave forever as plastic concrete. That means some sort of the, compression and rebound will be occurring there. And then how to achieve it? So this problem we encountered in one of our project, that is Kanupur irrigation project of district of Keonjhar. And these matters are referred to NIT, IIT also, but they denied to take up this assignment as because in literature hardly some mention about this plastic concrete there. Very few, not all, not in the compiled shape also. Even your Bureau of BI score has not also recorded it, right? So me and my executive engineer, Mr. R.N. Rai, he's also here. We worked for 2 years to finalize the specification of this plastic concrete, right? The seepage barrier. The other word is the seepage barrier. Seepage barrier means which arrests the seepage. Okay. So seepage, how to arrest that loss of water from the reservoir. So you have to put a barrier, and that barrier should be of plastic concrete. Okay. So the rest part of today's presentation, I have structured in this way that I will be referring to a case study, and the case study is from Kanupur irrigation project, and these are the subheads like internal erosion, then diagnosis of the seepage problem, the types of seepage barriers, concrete definition in detail I will be discussing. Then what will be say wall geometry, and what are the structural design, how to select the material, and how to be their mechanical properties. And then the last part, the least part, the easiest part is the construction methodology and the equipments, right? All these things we will be covering one by other. Internal erosion. What do you mean by that? Internal erosion means from the dam body, if water as well as the soil particle gets lost, if the soil particles migrates and water gets lost, then it is called internal erosion. That erosion means how it is the regions of the internal erosion will be either anthropogenic, I mean the man-made, or some natural. And the man-made regions are we the engineer who have constructed that wall. If they have not done it properly, then you are responsible for that. That means the engineer is responsible. That is man-made problem, right? Then the ground itself. Ground means the foundation. Foundation over which the dam is standing. If some problems are there, some geological problems are there, that you are not responsible for that, but nature is responsible. But you cannot change it. So you will adopt some remedial measures for that. Here in this case, you look at this. The figure shows two parts. The top one, the superstructure, and the bottom one is the substructure. And the substructure consists of some cohesionless soils. That means some sandy layer or something like that, through which water will be getting lost. And the superstructure, we are constructing a or dam by layer, and we are compacting it. If there is some problem with there, if the adequate safety measures you have not taken, you have not constructed in the proper way as per the specification, that means there will be some problem which will create havoc in the after completion, after impoundment of the reservoir. And this sometimes the how this problem will be manifested either in the superstructure or in the substructure, or from the superstructure to the substructure, or within the interface of the substructure and the superstructure. I mean the interface between the superstructure and the substructure, right? So similarly, I'm coming to the causes. What will be the causes of this internal erosion? There may be some referential settlement, some hydraulic fracture. What is that? You are constructing, providing some concrete structures like head regulator, etc., within the dam body. If the bonding between the two are not done properly, then there will be a seepage path, and through which water will be get lost as well as the soil particles. Even if the water is lost, no problem. Some capacity will be reduced, but if the soil particles gets migrated, then that will be endanger the stability of that. So we have to be very conscious about that. Then interruption in field placement. Suppose you are laying a layer of earth, compacting it. If you are leaving it in midway, not completed, and next day you are coming, then again you are complete the rest part. There will be a problem. Why? There will be some difference in the soil moisture of the soil, and that will give you another problem. So these are some of the reasons I'm discussing. Then pervious lift in an embankment. Lift means if the soil is of cohesion type, sandy type. If the soil sand accumulation is more, then it will be porous also. So while selecting the construction material, you have to be extra conscious. Desiccation, drying. This is a laboratory word. Desiccation is drying, right? The soil, foundation moisture in the soil that you are putting there, you are compacting there. If there is a big difference, that also gives some sort of defects. So before placing the external soil over existing soil, you have to maintain the same soil moisture in the field, right? Then dispersion means there's some chemical type of soil. When it is watered, it gets flowing, like your saline soil. Chemical, those soils which are rich in sodium that will easily move. Those are soil of materials, those type of soil are to be avoided. Then some geological defects will be there, and ultimately, if there is some natural reason that the earthwork induced cracking because of earthwork, if there is a differential settlement, that will also give some sort of a problem there. So in that case also, internal erosion will take place. Now our discussion will be confined to the foundation only. Forget about the superstructure. We will assume that the engineers have built the superstructure as per specification, right? No compromise has been made. But the foundation, that is not within my control. I can take care of that, but I cannot remove the total problem associated with the foundation completely. I may adopt some sort of precautionary measures. Here in this case, what will happen? Soil erosion, internal erosion will initiate from the downstream side. It gets manifested in two forms. One is heave, another is blowout. So long the leakage from the foundation appears in a point, then only that will happen. That will be showing it is getting expanded upward. That is a heave. But the moment the hydraulic gradients, the critical hydraulic gradients exceeds the buoyant weight of the soil column, at that point, it will simply blow out. So after that, what will happen? This will take the particles. This will take out the water, and a capillary will be. I mean, the conduit will be built up, and that conduit will progress towards the upstream side. And upstream side, when it gets connected to the reservoir storage, water will wash through. And after that, that conduit will be the diameter will increase, their height will be increasing, and it will towards move towards the superstructure. So it will collapse and then the dam break. So these are some fundamental things. You might have come across these things at your degree level also, in soil mechanics also. There is nothing new about it. Now I will be coming to my problem. Now the case study begins. Case study is the Kanpur, as I told you, it is irrigation, Kanpur irrigation project. It is a dam project. The dam is of 3.46 kilometer long. There is a spillway of from Chennai 1155 to 1425. Here is the Chennai 0, 1155, the beginning of the spillway, and it gets extended to 14 and 25. And there is a hillock here.
Yeah, very good.
This is the hillock, and the river here, right? And the river here is there are two branches. One tributary is Sona River. My cursor is not visible, no? କଣ କେମିତି କରନ୍ତି ରେ ବାବୁ ଦେଲୁ ଏଇଠୁ ମୁଁ କେମିତି ଦେଖେଇବି ମତେ ଏଠି ଦେଖାଉଛୁ ଓକେ ଆଚ୍ଛା two rivers are visible. One is a tributary of the other. The river, main river is river Baitarani, moves from this side, and there is another tributary. This is Sona River, and the river, dam is located just at the confluence point of the both the rivers. And near the hillock, the river gets diverted, then it goes downstream, and the spillway is connected to the river in the downstream through a spill channel. Right? This is all about the year. Then I am coming to the problem. You see, when we were constructing the left abutment of the spillway, my chief indicated something. What is that? He looked at the cross section cross section part. He noticed some layer. He asked me, "What is that?" I told him at that time I was the executive engineer there. Sir, it is soil. So do you mark any difference here? So I told him no, no difference. And I was not aware of the problem. So he scolded me like anything. You see, look at this. This is a sandy layer, and this sandy layer is very, very dangerous. So for the stability of the dam is concerned. So what happened? Then what? A precaution measure our predecessors had taken there. Already by that time the dam is over. The dam has been almost constructed up to 90%. But the foundation indicates like this. Is it not a seepage path? If it is a seepage path, then what will happen to the stability of the dam? What precaution measure we have adopted? And after those who have worked there, though they were still working there, they told us nothing. We have never noticed. That was a gross mistake. So what he went through all the documents related to the dam from different sources. I mean, geological study done by Geological Survey of India, Central Water Commission, all the authorities, those who were concerned with that, all the documents were referred, and he cried like anything. What happened? What mistake we have committed? What answer will we will be giving to our successors once the dam will be impounded? The very next day it may fail. So the matter was referred to Central Water Commission, right? I'm showing those layers in detail. Look at this slide. You see, there are continuously four layers. The bottom one was thicker. The thickness varies from almost 1.5 meter to somewhere it is 10 meter, right? And the top three, all relatively of lesser thickness, but those are also very, these are all seepage paths. We call it buried channel. And the material in this portion consists of but sand, silt, very lesser fines like silt and clay, mostly pebbles of bigger size up to the extent of 150 millimeter, and some pebbles, bali goroda, ଯୋଉଟାକୁ ଆପଣମାନେ କହନ୍ତି bali goroda, those type of materials. And this combination, the soil matrix itself is a very, very porous. Then the question arises, why at the during the construction time, why we people are not taking care of those things? What foundation treatment we have taken? Usually, if anticipating there is no problem in the foundation, hardly we go for cotton grouting up to a depth of 6 meter, up to a depth of 6 meter, not beyond that, right? But this problem persists there below 6 meter than the downstream. Look at this figure. The bottom one is hard rock. Then the this is the weathered rock. Then pebble layer. Then again clay. Again pebble layer. Like that. And at the top there is a earth dam that we have constructed. So what happens when we are putting an structure across that? We are going up to the level of hard rock. That means only in the length of that structure, I mean the spillway, we have gone up to the hard rock. That means all these pebble layers have been disconnected. But whatever the other the rest portions, there we have done nothing. You see, this is the longitudinal profile. Look at this tract yellow area from the chain edge 120. I think this is 120 something. Huh? 120 to 1100 something. Look at this thickness, height of the pebble layers. And it is of varying size. Somewhere it is not at all present. Somewhere the depth varies up to 20 meter also. One, two, three portion. They are very porous, very thick in depth, and others are very thin. But even three channels are there. That means there is a buried channel from the downstream to upstream. So what we thought that this is to be cut off. Whether it was those things are not indicated previously, we refer to the Geological Survey of India report of 1993. The one geologist, Mr. R.N. Ghosh, when we refer to his document, we came across this. I'm reading that at around RD 1050, that means nearer to the spillway. This gravel horizon, suspected buried channel, terminates against a subvertically disposed basic rock, probably dolerite dike, which was probably the limit of the right bank of the then river channel. That means 11, the RD channel is 10445 meter, and that the pebble layer ends in the right dike of the right portion of the river. That means what happens? Our spillway in the now at present spillway in the left side of the river. It indicates that the river has changed its course from the left side to the right side. I'm coming back to here. From now the river is flowing in the right side of the hillock. But as per his report, It was once upon a time, maybe some million years ago, it was flowing in the left side of the river. That means it has changed its course. So these depositions, this stratification has occurred, which is a riverbed material. The rock soil matrix is river material, bed material. Then that is porous. The last one I'm reading. This highly pervious buried channel will pose serious problem to the dam after impounding water in the reservoir. If this horizon is exposed anywhere within the reservoir, as well as at the downstream of the dam axis, this will not only give rise to considerable leakage but also appreciable pore pressure, endangering the stability of the earth depth. He suspected that there is a pebble layer, but it might be connected with the river in the upstream as well as the downstream. So we searched in the field if it is really connected. We found that along the this Luna river, it is directly connected to the river. That means river water is not only flowing in the main river but also seeping through and contributing to the main channel, that is river Baitran, in the downstream. So it is a clear cut dangerous situation. So the matter was communicated to Central Water Commission. So then who is Central Water Commission? Why not we? Because they are the apex authority in India to take any set of final decision. So for water resource construction are concerned, for all the states, they are the authority. We so we cannot take a dangerous step. It is better to refer the matter to them. Let them give the solution. Ultimately, whatever they suggest, we will do that, right? But we, I mean me and my team, was mainly led by Mr. R.L. Rai. We thought that, sir, let us have some more investigation. So what we did, we engaged a geophysicist. By electrical resistivity method, they will determine where are the body channel, what are their extents. So one company was hired from Delhi. They did their study. And their main objective was some 2D electrical resistivity. That means internal resistivity distribution of dam, its a foundation will be identified and the area of saturation will be identified, right? Another is the streaming potential. Identify the seepage path not noticed by visual inspection. It is not visible, but this streaming potential by method, they will tell you that it was moving like this. I am not expert of that. We took the help of them, right? I am not a physicist. Those are doing their specialization in earthwork, I mean geology. They are aware of these things.
Geophysical engineering. Geophysical engineering.
Geophysical investigation, right? And as for their report, they told that there are 4 locations where these buried channels are existing. One, two, three, four. This is indicated in the drawing. And the first one, the green portion, it has been intercepted by construction of the spillway. But all other trees are there, right? So what we did after at that time we became sure that yes, there are 3 buried channels, and the geology says that, geophysics says that. So our next duty is to measure the permeability. If the permeability is within acceptable range, then nothing to do. If it is beyond the acceptable range, we goes beyond, then we have to do something extra. So you adopted some predictive permeability methods. Predictive, some empirical equations will be utilized, and based on that, the permeability will be calculated. If it is within the limit, okay. No, if you it has gone beyond that, this will be addressed. So, what are the how the empirical equations are derived? We are using the grain size distribution, porosity, degree of saturation, bulk density, clay content, organic material content, and other fractal properties. And some previous research are there. They have given some equations. So based on their equations, we carried out our investigation. Mainly, we selected three equations. One is Kozenik-Karman-Beer equation from some for tortuous movement of water. Tortuous means not straight line. Tortuous. I mean the KIA, the Darcy equation is straight line movement. But water never flows in a straight line. It goes follows the seepage path. This somewhere upward, somewhere downward. That path is called tortuous path. So this equation is depending on that. Another is Chapuis method. This is related with the D10, the grain size distribution, 10% passing, 90% withered. In grain size distribution, when we are sieving the soil material, if that 10% is retained passing through, then it is that size is called the D10, right? Then another equation, Peng-Shu and Bombing equation. These are not there in your literature. So these are only available in your journal papers. Not no textbook speaks about this. So based on that, we adopted some grain size distribution. We collect the soil sample. We in the laboratory we did it, and these are the some size of the particles: D10, 30, D50, D60, like that. Curvature of the coefficient of curvature and coefficient of uniformity. All these things were determined in the laboratory, and using these parameters, we could calculate the permeability range falls between 0.812 to 5.61 10 to the minus 5 cm per sec. Okay, so you have to classify that soil. So we use the USBR description. What the USBR specification says that if the permeability value lies between 10 to the power 2 to 10 to the minus 4, then it is called highly pervious. 10 to the 4 to 10 to the 8, 5, this is semi-pervious. And beyond that, 10 to the 5 minus 5 to 10 to the 9, then it is impervious. Now you look at this at the large bottom three lines. We have got observed Q, the observed permeability written from the water loss test of the foundation. Then predicted Q by using those equations, we have also predicted those ranges. Another is the fractured rock permeability. Now it shows that our predicted value as well as the observed value falls within the pervious zone. So three things are clear. One is finding of the GSI. Other finding is from the geophysical method, and the third one is from our predictive method. That shows that yes, we also agree to come to the same point that it is highly pervious, so it needs some remedial measures. So what was decided that we will put some seepage barriers. There are various type of seepage barriers. So what are those? Clay bentonite cutoff is there, diaphragm wall is there, cement chemical grout is there, upstream blanket, sheet piling. Broadly, these are classified in the three categories. Clay bentonite cutoff. That means you have mixed clay and bentonite and put it as a barrier, vertical wall, construct it, then it will be act as a barrier. But you see, the extent of the, I mean, the depth of that layer is from ranging from 0 to 45 meter or 50 meter approximately. So can you excavate up to such a distance, such a depth? If the bottom layer, if you are providing 1 meter at the bottom, how much width will be at the top? So it will be almost a reverted dam. So this is not, this is rejected. Diaphragm wall, yes, that is one part. Chemical grout. So for chemical grouting is concerned, first thing comes to mind is the efficacy of the method. The man who is executing the work, if we are suspecting whether the work has been done properly or not, that makes us unsure whether whatever we have done is acceptable or not. So that is a doubtful method. We rejected it. Upstream blanket. Upstream blanket you are providing, but it will resist the vertical movement of water, more vertical seepage, not the horizontal seepage. The horizontal layer is there. It is connected to the river. It is this part is also connected to the river. Only if you are putting the blanket at the top, the water may not seep through vertically, but it will be passing through the. E. So it is a auxiliary measure, not a main measure. The sheet pile. Sheet pile also is also effective, but once it come across some boulders, it cannot penetrate through. It is stuck up there. So that is also not possible. So only option left is only diaphragm wall. Again, diaphragm wall is of two types. The rigid diaphragm wall and the flexible diaphragm wall. If concrete is rigid, clay is flexible. If you make it, if you provide RCC, that becomes more rigid, right? So the only thing is left to us is now we have to go for the flexible type of material. So based on that, what Shiroshi suggested that you better go for a diaphragm wall of plastic concrete at a distance of 5 meter from the dam toe, and it will penetrate up to the rock level, even embedded for a depth of 1 meter into the fresh rock. So the automatic the question comes, what do you mean by fresh rock? Is it weathered rock, or it is soft rock, or hard rock? There is a definition for hard rock. If the RQD, raw quality designation, have you come across this word? Raw quality designation is more than 75%, then it will be termed as fresh rock. They put it a single line instruction, but for us it is a hell of problem. RQD 75 means it is as good as your very hard rock, fresh rock, granite hard rock. Is it possible to even excavate at a depth of up to 1 meter, at a depth of 50 meters below the ground level? That was also a challenging job. So that was accepted. Now they given two symbols, either you for grouting or for a diaphragm. But grouting we rejected. Why? We refer to one paper, journal paper, Carroll. I'm reading that. Carroll further stated that soil with mean the particle size D50 is greater than 2 mm with negligible fines would be uneconomical to be grouted. With the above mentioned criteria regarding the groutability, it can be concluded that pebble layer in the left embankment of the Kanupur Dam, although easily groutable, may be uneconomical since D50, I mean the mean size of the particle, is 7 mm with a negligible fine. I mean, no fines are clay, and within that material clay and silts are not available. In our case, it is more than 7 mm. If it is more than 2 mm, this is uneconomical. So from on economic ground, it was rejected. So we went for this. Option number two. This is a diaphragm wall of 1 meter wide, extended up to the fresh rock level. The bottom level, rock level is varying. Depth, width is 1 meter. Why 1 meter? Why not zero point 0.6 meter? Why not more than that? That is also again a question mark. There must be some logic behind it, but the logic is not stress related. construction related. If you put a thin layer, thin layer of plastic concrete, so you have to excavate the trench within this, with this much width, up to the depth. Up to what extent? Maybe somewhere 100 meter also, maybe 50 meter also, and that wall has to go vertical. So it is not possible. So they provide some wider one. That is 1 meter. Even in our collaborative of Andhra Pradesh, they have constructed with a thickness of 1.5 meter. Wider is better to execute. Thinner is very difficult to execute. And the configuration is like this. The plastic concrete wall will be kept at the top, and over which a layer of 2 meter layer of this clay blanket will be provided. So this was almost finalized. Even the technical advisory committee with the committee within our department approved this one. So next part is that we will go for construction. So regarding as regards to the specification of this diaphragm wall construction, one is material finalization, methodology finalization. You have to write something, no? Right? You have to write something in the document. What you will write? When you say that it is concrete, concrete is depended by what? M something. M for mix, something the stress, the characteristic strength. Maybe M10, M15, M20 like that. So we do not know what will be the characteristic strength of the concrete. Should I write 5 or 10? No. Should I write 2.5? No. Even if previously you might have not heard any concrete below M10. But in this case, I am coming to the next slide. I have made a comparison between the rigid concrete, plastic concrete, right? That first of all, let me tell you about the plastic concrete definition. Plastic concrete is characterized through a high deformation capacity under load, which is of great advantage when ductile walls are needed under significant bending strains due to unequal deformation of the cutoff wall, large annual reservoir fluctuation, or significant seismic events. It is assumed to be a linear elastic material. When you are plotting your stress and strain diagram, looking at the plot of the graph, what you are determining, this part is go straight almost in a horizontal center by a straight line, then it falls, comes down, then it gets flatter, right? Based on which the slope of the straight line gives the Young's modulus. These are your area, not my area. I am talking only remembering something and telling you. Okay, so it is our basic assumption of that stress and strain plot will be linear elastic. No constitutive law has been framed for plastic concrete till date. Neither Bureau of Indian Standard (BIS) code is ever, nor any other organization, British code, nowhere it is clearly depicted about the specification of the plastic concrete. Yes, there are some many few publications. Whoever has made some experiment, they have mentioned something, but that has not been never issued as a authoritative document for others to follow. Now coming to this, what is the difference? Type of material for standard concrete. It is both RCC and PCC. But for plastic concrete, it is only PCC, no RCC. Once you add reinforcement, it will become rigid. That is not allowed. Material, same material. But in case of plastic concrete, bentonite is a must. Unless you add bentonite, it cannot be flexible. It will be rigid. Our intention is to make it flexible so that once the water load comes in the reservoir, there will be some difference in the settlement, and that settlement will cause some bending to the dam as well as to its foundation. So according to the waterfall that we have provided, it will also take that flexural shape. So it has to be a ductile, malleable concrete. It should never set. Okay. Then, in case of a standard concrete, the maximum size of the aggregate reaches up to 160 millimeter. In case of plumb concrete, 160 millimeter. But here in this case, the maximum size is 22 mm, and mostly it is 12.5 mm. Right? Grade. What is the grade? For standard concrete, it's M10 and above. For plastic concrete, is hardly M.5 to 2.5. That means strength is not the criteria. Deformability and its rebound is the criteria. Strain, standard concrete, almost 0.2 to 0.3%. What here in this case, 0.5 to 1% in unconfined shape and up to 4% in the confined shape. Your modulus of elasticity. These things I have derived from the Europe IS 456 for normal standard concrete. But for other cases, for plastic concrete is 4 to 5 times the elasticity of adjacent soil. If if we fall within that, then there will be a separation between the two, and no separation between the soil and the cutoff for is allowed. Permeability may not be considered for standard permeability, but in our case it was very low, of the order 10 to the minus 9 to 10 to the 10 meter per second. Environment is for standard concrete, it may be exposed, may not be exposed, unexposed or exposed, but in plastic shape, in case of plastic concrete, it is never exposed. It is always below the ground because it is used for the foundation treatment. Member thickness accordingly varies, and for plastic concrete, it is 60 cm to more. Initially, some for lesser depth right from wall, some 60 cm which was used, but this has been never again. They are not being followed nowadays. The thickness is more 1 meter or above. Then comes to the testing procedure. How to test those material? Plastic concrete cannot be put in the category of concrete. It can also not be put in case of soil. It is neither soil nor concrete. Not pure soil, not pure concrete. So some mixed procedure will be followed. The testing procedure will be structural and geotechnical. Concepts are structural, but the testing procedures are geotechnical. Whatever equipments you are using in the soil laboratory, that will be utilized. And these are the same thing. We are using it for, we have finalized our specification. Same thing I have already discussed. Then coming to the mixed design. Your strength is decided. Your strength is decided, and in order to achieve those strength parameters, you have to decide the proportion of the material. How to do that? That is done through a mixed design. So for this purpose, with varying size of the aggregate content, cement content, admixture content, some 225 samples were decided, and out of some those some big slabs were, I mean the specimens were cast and tested in the laboratory, and which specimen conforms to all the test criteria, those will be utilized in the field. This is the laboratory setup. The yeah, specimen size of 100 mm at the diameter and 200 mm the height. Some samples were prepared and tested, and it is being tested for sorry. These are the test photographs. At a failure, we are using getting the strain, stress, and the permeability. The same thing. Unconfined strength, unconfined on a confined strength, then permeability. All these tests being conducted, and Yes. Here. Out of the 15 mix samples, mix number 13, 14, and 15 conforms to all the test requirements. So we are we have to operate in this area, mix 12, 13, and 14. And we adopted the mix number 13 for execution of the work. Right? This is all about the theory, design, design part. Now I am directly going into the construction part. I have depicted a flow chart here. The first one, the geotechnical investigation, then grouting, then guide work, working platform, grabbing, trenching, and plastering concreting. These are the main events, and the side events are some parallel events are there. Now you have to go for the trenching operation. Trenching means there is a equipments. It will go excavating with a width of 1 meter from the top to the bottom. I mean 1 meter up to inside the hard rock. This will go move like this. Something will be excavated there. Once it reaches the pebbles, what happens? You observe. The sides will start collapsing. That means you have to stabilize the sides, right? For that, what you will do? If these are all heavy machineries, when you operate those heavy machineries, if you are giving some impact to the ground, that's how. So far it is clay, it is okay. The sides will be stable. But once you go down and enter into that pebble layer zone, the sides will be collapsing because of its cohesion property, right? So if the sides collapse, you cannot go for proceed further. That is to be stabilized, and that is being used by grouting. If your thickness width is 1 meter, that means some extra width will be grouted. Will be make harder, and within that you have to excavate only 1 meter wide trench. Dam grouting, these are another again a specialized area. Dam grouting, even I have not, I have also never used. I am using those words only. Mr. Better, the expert is our Mr. Rai. He can tell you. Here in this case, this is a dam grouting. Dam grouting means TUA merchant grouting. The grouting material is clay, I mean bentonite, sorry, but the grouting material is bentonite and cement. And the manchet means a rubber sleeve. And then there is a tube, that is a perforated tube. And some in between, intermittently, some manchet is connected with that. That's a rubber material. Okay. The next picture, I'm coming to that one. First, the configuration of the grouting profile. You see, these are some holes, grout holes are there. The configuration is at a distance of 1.5 meter from grout hole to grout hole, but put in a staggered manner. Staggered, not straight line. Staggered. This here, like that. And the distance is 1.5 meter apart. This is the sequence of time grouting is first the drilling, then you install a dam pipe, then there is a sle- sleeve. You have to grout the sleeve. Then when the entire thing is the sleeve is filled up, then you remove the casing pipe. Then you start grouting. It grouts from the bottom. A bulb-like things will be formed there, and the width is enlarged, and you push the grout from the bottom to the top. So long you covers the pebble layer zone. So this width is around more than 2 meter. Within that, you have to excavate only 1 meter. Unless you do that, you cannot excavate. What will happen? The sites will collapse. Now the real construction. They are all precautionary measures. As our BIS code provides a provision for two guide walls. It is a L type of RCC section of M20, placed at 1 meter apart. uh, Within that, your place will be excavated. And then what is the necessity? The general question arises: if you are excavate, why should you put a guide wall there? The machineries that you are utilizing and the methodology you are utilizing does not allow you deviate from your alignment. That is why these are some guide walls are there. You have to operate it within this, right? This diaphragm wall has to be vertical, perfectly vertical. These are some photographs constructed in the site. A type of sections erected with a separation of 1 meter, which is the thickness of the cut-off wall. Now I am coming to the this equipments. You look at these equipments, so heavy, not easy to handle. The main equipments are two things: grab and the cutter. What is grab? Grab means just like two buckets are there. They are simply excavating and taking out the material from the bucket. They are throwing it. But that grab will not be effective when you go for excavation in rock or the weathered rock course. Even some stiff clay that may not be easy also to construct. That in that case, you have to replace it with a cutter. Cutter means it will not only cut that individual isolated pebbles, it will also cut the hard rock below. See the shape of the cutters and the erection for operating those cutters. Other units are descender and bentonite source. What is descender? When you are excavating, the soil you are throwing away. But when you enter into rock, how can you judge whether you have reached up to the hard rock level or not? That means the whatever material is being churned out at the bottom, that will be transported through pipelines to a descender unit, and it will be segregating in two parts. One is from less than 70 millimeter particles, another is from less than 5 millimeter particles. By looking at those material, you can judge in which layer you are, what is the type of rock, whether it's granite or not, hard rock or weathered rock, whatever it may be. If the material is finer, then you are going through weathered rock. When you receive the aggregate share, then it is called you are this is the granite part. I mean you are within the hard rock level. So by measuring the depth also you have to see that how much you are inside in the hard rock level. This is nothing to worry about it. They're only for I am showing you the construction part. Construction part is not important for you people. That is important for us, those who are working the pit, not for you. Then this panel, how you, you see the length of the cutoff wall is around 1 kilometer, 1050 meters. Can you excavate at once? No, you have to take up in case of in panels. So panels means some primary panel and the secondary panel. They are put a distance apart, some specified distance. Primary panel, then leaf space, and then again primary panel. And after these two panels are constructed, in between you have to go for a secondary panel, right? So in that way, you will cover all the entire length of the diaphragm wall. Yes, this is a working platform. The heavy machinery that you are utilizing for the construction is not operable in normal field. That means you have to go for a very robust construction to which can take the load of this heavy machineries. That means you have to construct the road also of the required width. The requirement maybe around 20, 15 or 20 meter like that, Mr. Rai. What is the width of the 20? 20 meter. 20 meter. And you have to do a roadway which is nothing inferior to a highway. Even more than that, there are certain layers. The bottom layer, top layer, some GSP, granular subbase like that, except bitumen surface, over which only this machinery will be operated. And the most part is, the important part is the verticality of the diaphragm wall. It is being measured during excavation, also after excavation also. You see, look at this. There is an equipment which is attached with the grab or cutter, that is called B-tronics. And another test is there, codent test, how much it to check whether it has deviated beyond the tolerance limit. These are the equipments. These are attached with the these are the some test equipments attached with the instrument also. And it is giving the codent test gives you a printout like this. By looking at the printout only, you can judge how much it has deviated from the vertical. The first part, you see that two dotted lines are there, total vertical lines are there. And the black portion is the deviation. At the bottom, here there is a deviation, smaller deviation from the dotted line. The black boundary is deviated slightly from the dotted line. And then the other side also, similarly, it has come inside. That means you have to measure this deviation. And that deviation is allowed only with a tolerance of 1 in 200 meter. That means one error is applicable, is acceptable within a depth of 200 meter. But here it is very, very minor deviations are there. The deviations are there. So it is acceptable. So our pit excavation is okay, no problem. Now we will go for, yes, go for concreting. But before concreting, you have constructed the primary panel, and you are going for the secondary panel. What you will do? You see, first I have constructed the two primary panels, and from the sides we have trimmed it, and secondary panel overlaps by a thickness of 200 mm both sides. That means if it is 2.8, point 2, point to this side, point to this side. So 2.4 is left. Again, the other primary panel, point 2 is cut off, and from that to this will be filled up with the secondary panels, and it is to be clean, proper, so that no soil should stick to the vertical surface of the wall. For that, we are using this wire brushes. You say, can you handle these equipments? They're very, very heavy. These wire brushes are lowered up and down so that if any soil particle sticks to the wall, it will be cleaned properly. Now, ultimately, the concreting. The concreting in either trimming, concreting is done either double trimming method or single trimming method. If the width of the panel is 2.8 meter, go for single trimming. If it is more than that, 2 point, more than 2.8, then you have to go for double trimming method, right? Then, moreover, one question arises before concreting. If you exceed your width of the primary panel, that means if the length of the pit is more than 2.8 meter, then can you ensure the stability of the cavity? No. First of all, we suggested that it will be of 2.8 meter. But why to limit to 2.8 meter? Maybe more than that also. You can go up to 6 meter also. But without ensuring the safety of the diaphragm wall, safety, excavation pit, you cannot go for that. For that, you have to go for stress analysis. And in our case, the matter was referred to IIT Chennai. IIT Chennai conducted a test, conducted analysis, stress analysis, and they ensured that yes, our findings tells that you can go up to 6.7 meter, 6.7 meter, not more than that. So ultimately, when we started, the panel length was 2.8 meter, but ultimately we went for 6.7 meter. That means the length of the primary panel increased from 2.8 to 6.7 meter. Now your construction part is over. You have to go for the capping. But the guide wall you have provided, that is to be removed. It has to be dismantled to be removed. And this your the operating platform, which was constructed as a roadway, that was also to be removed. And you have to fill up those areas with compacted soil, which is equal to the drain specification. That means 95, not less than 95% proctor density. And over that, a blanket, soil blanket will be provided, which is of thickness 2 meter. That is also equal to the proctor density of the dam. And the whole thing will be treated as if this is an integrated part of the previously constructed dam, right? So I told you what is plastic concrete, why it was utilized, and why we people at the site did it. This is nothing less than a research work. All, the diagnostic part is more important than prescribing a simple solution. Solution is very simple, but as if you are when you approach a doctor, what he is suggesting for? He is suggesting from some tests. Based on that test, he is writing some medicines. The second part is of lesser importance than the previous part. If it is not there in the documents, even in your course, in your textbooks, then we have to do it ourselves. What we did here, we refer to IIT, even NIT Rourkela. They also did accepted this assignment. We approached them also. They said no, we will not do that. So whenever you are working in the field, you will come across so many problems whose solution is not available in your text. But academics, what they do, whatever, whenever some problem comes, they will go through some paper, some textbooks, some paper. If it is not there, if it is there, okay. If not there, no, we don't have time. No. But we can, you see, you are our advisor. You cannot escape that responsibility. In such a case, we accepted the challenge and we provided the in-house solution to that. So I derived utmost satisfaction when it was constructed and this year it was completed. The, now the last part, we suggested, we constructed. How it will behave, we do not know. We have to then previously whoever has done, whoever have executed similar work, what they have achieved, overall they say that the performance is it is effective up to 95%, nowhere less than 95% throughout the world. But in our case, can I say that it is yes, it is effective if my construction methodology is correct, if I have not done it properly, if my study is not free from error, then how can I ensure before impoundment of the reservoir? Can I check it? No. Go for impoundment, go for some instrumentation that will give you that the level difference between the upstream and the downstream and the quantity of water that is shipping through, you quantify, then only you will say whether it is effective or not. So you have to wait for that. And even I searched through many literature, nowhere it is available. So everybody is telling that it's not possible. Wait. भगवान पे भरोसा रखो छोड़ दो उस पे that will tell you whether you have done it correctly or cost 200 crores. One silly mistake. One silly mistake. Our predecessor in the field, they ignored those documents given by the Geological Survey of India. Did not went through that. That's why we invested money. Just that. And the time we consumed around 4 to 5 years. 5 years. The problem I have raised before Reliance Rautala in the year 2012. At that time it was identified. But in 2024, the work on remote method was completed. How much time it took? 12 years. So pre-construction survey investigation is very, very important. Then the actual construction phase. Actually, we the engineers would have been beheaded for such a mistake. If it be a private farm, we must be roaming the streets also. Okay, this is all about my topic. Thanks. Thank you very much.
The geological investigation, that means overall data and other things was complying all this problem or not?
କହିଥିଲା ଆମେ ତିନିଟା ଷ୍ଟେଜରେ କରୁ ନା ପ୍ରଥମେ ଜିଏସ୍ଆଇ କରି ଦେଇଥିଲା କେବେ 1993 ରେ ତାପରେ ଆମେ ସେଟାକୁ ତାଙ୍କର ରିପୋର୍ଟକୁ ଆମର ଇଞ୍ଜିନିୟର ସେମାନେ ଇଗ୍ନୋର କରିଦେଇଥିଲେ ଦେଖିନଥିଲେ 2012ରେ ସେଇଟା ଆମର ଜଣେ ଚିଫ୍ ଇଞ୍ଜିନିୟର ସେଇଟାକୁ ଦେଖିକି ସେ କହିକି ସେ କହିଲେ ଯେ ଆମକୁ କଣ ଗୋଟେ କିଛି ଗୋଟେ କରିବାକୁ
ତାମାନେ ସାର୍ ଆମେ କଣ ଜିଏସ୍ଆଇ ଏଟାକୁ ଆଉ ରିପୋର୍ଟ କରୁନା ଏମିତି ଆଉ ବି କୋଉଠି
କରିବା କଥା ଦ୍ୟାଟ୍ ଇଜ ବାଇଣ୍ଡିଂ ଅନ୍ ଅସ୍
ସେଇ ଗୋଟେ ପର୍ଟିକୁଲାର
ସେ ଗୋଟିଏ ସେଇଟା ଯଦି ଆମେ ପ୍ରଥମରୁ ଯଦି ସେଇଟାକୁ ଯଦି କରିଥାନ୍ତୁ ତାହେଲେ ଆମେ ତ ଯୋଉ ଡ୍ୟାମ ର କଟ ଅଫ୍ ତିଆରି ହୁଏ ସେଇଠି ହିଁ ଦେଇ ଦେଇଥାନ୍ତେ ସେ ଦେଲୁନି ଯୋଉଥିପାଇଁ କି 5 ମିଟର ଅପଷ୍ଟ୍ରିମ୍ ଅଫ୍ ଦ ଡ୍ୟାମ୍ ଟୁ ଇଟ୍ ୱାଜ କନଷ୍ଟ୍ରକ୍ଟେଡ୍ ଆଉ ତା ପାଇଁ 200 କୋଟି ଟଙ୍କା ହୁଏତ 2005 ଯେତେବେଳେ କନଷ୍ଟ୍ରକ୍ସନ ଆରମ୍ଭ ହେଲା ସେତେବେଳେ ହେଇଥିଲେ ହୁଏତ 40-50 କୋଟି ଟଙ୍କାରେ ହେଇଯାଇଥାନ୍ତା ହେଲା ଯାଇକି 200 କୋଟି
ଡିଜାଇନ କଣ ଚେଞ୍ଜେସ୍ କରି
very, very, very typical problem. ଯୋଉଟା କି କେବେ ହେଲେ ମାନେ ଏଭଳିଆ experience
ମୋର ଚାକିରି କାଳ ଭିତରେ ଯାହା ମୋର ଏଣ୍ଡ ପାର୍ଟଟା ଏଇଥିରେ କମ୍ପ୍ଲିଟ୍ ହେଲା ଗୋଟେ ପର୍ସନାଲ ସାଟିସ୍ଫାକ୍ସନ ଡିରାଇଭ୍ କଲି ଯେ ଗୋଟେ ପ୍ରୋବ୍ଲେମ୍ ଦ୍ୟାଟ୍ ଟୁ ହେଡୱାର୍କସର ଗୋଟେ ପ୍ରୋବ୍ଲେମ୍ ଯୋଉଟା କି ଆମେ ନିଜେ ସେଟାକୁ ଆଇଡେଣ୍ଟିଫାଇ କଲୁ ମାନେ କନସିଭ୍ କଲୁ ତାପରେ ରେମେଡିଆଲ ମେଜର୍ସ ଆମେ ନିଜେ ଡିସାଇଡ୍ କଲୁ ଇଭେନ୍ ସ୍ପେସିଫିକେସନ ବି ସେଣ୍ଟ୍ରାଲ ୱାଟର କମିଶନ ଦେଲା ନାହିଁ ତାକୁ ମଧ୍ୟ ଆମେ ନିଜେ ସବୁ ଓନ୍ଲି ଆମେ ଦି ଜଣ ରାୟ ବାବୁ ଆଉ ମୁଁ ବସିକି ଯେତେ ଲିଟରେଚର ଯାହା ଯାହା ଜର୍ନାଲ ପବ୍ଲିକେସନ ଯାହା ଯାହା ତାକୁ ହିଁ ଇଏ କରି କରୁ and this plastic concrete concept has appeared after 1990 before 1990 it was not there.
Yes, sir. Thank you so much. Now I would like to call Professor Anil Karasar to give token of thanks to sir and Dr. Ashutosh sir also, Engineer Ashutosh sir also.
Sir,
Uh,
sir, sir.
two short persons who are challenged FP and another person who has challenged a big geotechnical problem and addressed also. It's not he has opened up that problem, but he has also addressed and completed it. Finally, that is all. In the very beginning of our service also, I was till I'm going to close my career, the Kanpur Dam is still under construction stage. And thanks to SAP that who has found that problem, detected that problem, and addressed also. So our Thailand also talented. So when we are thinking big of this GIS, and GIS is also having certain limitations and how to exercise those limitations and how to capitalize or how to show that yes, that is also all. So these two personalities and thanks that Sar is also having with his team and the team is there, I am there, and other team members are there. It's very good that Sar have just tried on these things and done that also. So thanks Lord Sir, and we are having the opportunity that you are with us. Thank you, sir. So now it is a token of appreciation. So I shall be inviting two delegates that Engineer Ashutosh Das and Dr. Mohendra Guya, the Engineering Chiefs of Water Resource Department, this token of appreciation. And after that, we shall be having a very small program. Uh,
Okay. Mobile number? Okay. Yes, ma'am. Yeah. Yes, sir.
And no doubt, it is for the students, those who are working in the field of remote sensing and GIS. And when you are searching for an imagery, then we think that a lot of problems are there. So, in order to resolve that, another technique, new technique presently continuing, that is Google Earth Engine. The Google Earth Engine is such a tool that whenever instant imagery can happen. Suppose you are interested for a particular date, imaging a particular date, then it is very easy to find it in Google Earth Engine. So my guide once in the hotel Mayfair, he has come to Qatar for a leak problem. He has told me that particular thing what happened. And he told me that you just start watching on Google Earth Engine so that imagery you can get all those images in a very short period or very easily you can get. So how do you do that? So I have told one of my students that whether you will be working on five students are working on Google Earth Engine, and she is one of them. And she is also an assistant professor of this university. Ms. Abhay Naik, Mrs. Abhay Naik. So she will be showing that how Google Earth Engine will be useful in delineating in deriving the satellite imagery, so that you can utilize in your subsequent research works. very easy. So now it is over to Abhay Madam. She will be showing how to deal with Google Analytics. And for that, you need some Java, knowledge of Java language. So you can
ठीक है वही करेंगे हाँ 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 इनको भी लेना मैं करूँ से
For giving me this opportunity to share something related to this Google Earth engine. So before that, we should know what is Google Earth Engine. What is Google Earth Engine? It is a cloud-based platform for planetary scale environmental data analysis. As we know that there is a three type of modes where we can analyze in a service, that is SaaS, AS and PaaS. Here, AS is it is an infrastructure as a service. PaaS is it is a platform as a service. And the SaaS is it is a software as a service. As we know that Google Earth Engine, it is the this Google Earth Engine, it is a platform based service. So what are the features? Here we can see that is a very powerful tool. It has a storage of the petabyte of data and powerful processing capabilities and a collaborative environment, and the application we can apply that in to analyze the forestry management, climate change analysis and disaster risk assessment. So what are the benefits? Here we can analyze, we can use that for the sustainable development, remote sensing capabilities and scientific research. For case studies, I have considered only three parts, that is the climatic change studies. Here the researchers are doing analyzing the global temperature trends and the environmental shifts, and for forest monitoring, Global Earth Engine has been used to monitor the deforestation rate in the existing forest. Then urban growth analysis, the platform aids in studying urban expansion and its impact on natural resources and ecosystem. The what are the challenges we are going to face? That is the data complexity, the dealing with massive geospatial data sets poses challenges in data storage, processing, and the visualization. The computational demands, the performing large-scale geospatial analysis requires significant computational resources and expertise. The technical skills also required because for to run this Google Earth engine, we need some amount of code knowledge, then maximize the by using the programming to maximize the platform potential. And for future, we can develop some data accessibility and advanced machine learning techniques and enhance the user interface. The potential collaborative collaborations are by using this Google Earth engine, we can collaborate with the government agencies, research institutes, and the environmental organization for the further data utilization. Then expanded application. The platform may expand its application to support the precise agricultural, water resource management, and the natural disaster response. The conclusion is the limitation and opportunities, environmental impact, and how we're going to encourage the continued exploration and utilize the Google Earth engine for addressing the global environmental challenges. As we know, the Landsat are the basic agency, the USGS is the basic agency who are supplying the Landsat data. It developed from 1970 from Landsat 1, and it is from 1970 to 78 up to 2015. It is Landsat 8 is launched, and in nowadays Landsat 9 is launched in 2021. Here the sensors are 1, 2, 3, 4, 5 up to 7, and these are the satellites and its resolution. And in Landsat 4 the resolution is up to 30 meter, and Landsat 8 and Landsat 7, by using the panchromatic system we can reduce the our resolution up to 15 meters. Next is Modi is also providing water resource, water data by he has two satellites on board, that is Terra and Aqua. The Terra and Aqua are viewing the entire Earth's surface every 1 to 2 days. The Modi's instrument provide data in 36 spectral bands, and the resolution of this Modi's are 250 meter, 500 meter, and 1000 meter. This is the GRACE satellite. It is a sun synchronous orbit and twin satellite system. It has two satellites, and the coverage is four total global. It will cover the spatial resolution of this GRACE satellite is 300 to 400 kilometers. Temporal coverage, it starts from the 2002 March 17 to the present. Then this is the anomaly detection monthly map from the GRACE. This is the long-term average map. It is also found from the GRACE. This is the whole observation from GRACE, the whole world we can see from this GRACE satellite. This is how it looks. This is the map, and this map is collected from the Jet Propulsive Laboratory, California Institute of Technology, that is SMAP. This is the soil moisture active passive, and the potential application area of this map is weather forecasting, drought, flood and landslide, agricultural productivity, and human health. This is the global mapping of soil moisture to enhance the accuracy and temporal resolution. The mission acquires these measurements for at least 3 years with the global coverage. This is what I have done by using this Google Earth engine. Here I have extracted the wetland of Cuttack city from 2016 and wetland of 2023 of Cuttack. Here we can see the wetland style. It is reducing. Let's start the Google Earth engine. By using this site, we can sign up the Google Earth engine. After signing up, we'll get this type of interface. Here there are, first is the search data, and then this cursor is visible. So here, in this box, we can import the data which is available in the Google Earth engine. There are a lot of products are available, and it is given by different type of agencies like NASA, NASA, and this is the research data, search data, and this one is doc is written here. It is API documentation, and this one the script. Here we can save the scripts, and this one the asset management manager. Here we can save files, and this is the geometry tool, and this one the zoom. If we want a zoomed view, then we can use this one, and this is the JavaScript. This one the run button. This is the inspector. In inspector we can find out each and every points value, and this is the task. Here we can manage the input output data, and this is the console output. In the console output we can get the data related to output and inputs. So see, after signing off, we'll get this type of website. Here we have the code editor and the documentation. If we'll click the documentation, and after that if we'll click the data catalog, we'll get these are the data available in the Google Earth engine, like surface temperature, climate, then atmospheric weather. There are a lot of data we'll get. Imagery data also we'll get. Let's say let's click on this Landsat. collection 2, we have different type of Landsat data. If I will click, let's say Landsat 8 VLI, again we will get different. For example, this surface reflectance, top of atmosphere, raw images. These are the available data, and it is provided by different agencies. If we click one Landsat 8 Level 2 Collection 2 Tier 1, the data set is available from 2013. Although this means here the Landsat 8 is launched in 2013, that's why it is available from the 2013 to 2024. And this is the snippet. By using this code, we can run this in the Google Earth engine. If you can click in the band, we'll get the different type of bands. Image properties also available in this, and the terms and use. Here, this data is provided by the USGS Geological Survey, and these are the codes. For this JavaScript, we can use this code to extract this Landsat 8 in Google Earth engine. So let's move to our Google Earth engine code. This one is our code. Let's say if I want to search something Landsat 8. See, whatever data we want, we can search that in the search bar, and directly we can access that by this way. And if you want to select one geometry, let's say I want to search Sambalpur or Odisha, India, it will directly move to our Sambalpur zone. And if we want to take one save file, then we can directly click. Here there are different type of icons. One is by draw a line, this is a polygon, and this by rectangular one. By using this, we can directly cut this save file, and we can change the color by this way. I want to take the lightest color. By putting this, we can visualize this, and this is I can change because I have already written this code. We can change this into ROI, that is the region of interest, and by clicking this run button, we can run that. So this is our required area, and this is the NDWI. NDWI means it is the normalized difference water index. By when we're going to use the setting button, we'll go to the setting button, and we can customize that up to 100% stretch, 98% stretch, 90% stretch. According to our requirement, we can stretch up to any percentage. Let's say I'm stretching that into 98%, and here we will get the colors options. We can change that up to like red color, then green color. We can give many types of colors. We can add also, let's say the yellow color, and apply. We can import also. We'll get that into here, and we can change this by this color. And how we're going to download that? We can move to the task manager, and again we need to run it. We'll get this one. By running this, we have to give 130 meter, this one, then we'll run.
It will take 1 minute or lesser than 1 minute time. It is done. If we'll click the source script, it will directly connect to the script area. And if I'll do click on the open in drive, then it will directly move to my drive. This one. So I will directly download this one, and we can access that into ArcGIS. File out. Okay. It's taking time. ArcGIS, it is a heavy software, that's why it is taking a lot of time. So I can say that it is after downloading whatever requirement we have, we can fulfill that requirement by using the search. Okay. I can. Thank you.
Very good, Abhay, man. And one announcement I celebrated that now IRS Dehradun along with NRSC, they are also make a program on this. It is on rural teaching, it is on health insurance, it is on trade jewelers. So they have one training on some also. So get ready, we are thinking around during the month of March or April, we started with that kind of program. Another sector also we have investigating with our team that we are also going to work on CFD, computer and flow dynamics. That is also we are introducing, and this time few students are BTech, they have also worked on CFD. And also a hands-on program will be that, and we are in touch with the open form people, those who are working on open analysis, and we will invite them to space and so that our students will be learning how to work on safety. Because most of the explorations are not being done. Those are the academic purpose, but we are just implying it on the practical field. So now these Rake, Ranas, Rake, HMS or whatever this Google are teaching, we are just applying all this in practical field. And as today, just we are discussing that how the practical problems our senior engineers they have encountered, and in that way also our students, those who are learning now, and they will be definitely be doing that kind of DM learning. So your mind should be working that way. Coming and what for him from another part of him started meeting at the launch, and those will be interested for the study that tour program, field visit program. Please give your name so that the vehicle will be arranged after. And what you are thinking, the Veerampur Dam, Chitlima hydropower, and nearest areas, those who are we can see that most of the hierarchy structures are there. These things will be shown to you. We are thinking that 5.5 we have thought, and please give your name so that it will be useful. So let us come together that we shall be taking a group photo. Thank you. Please come.
Thank you, sir. Thank you, everyone, for your coaching attention. Lunch is ready. Please join us on lunch. This session is over. Tomorrow we will meet again. Thank you.
Hmm. Photo. Every live stream. With who?
ସ୍କ୍ରିନ୍ ଖାଲି ସେୟାର କରିବାର ଅଛି ଆଉ କିଛି ନାହିଁ। ଏଠି ମୁଁ ଲାଇଭ ଷ୍ଟ୍ରିମିଂ ଟା ବନ୍ଦ କରିଦିଏ ଏତିକି ଭିତରେ। ଲାଇଭ ଷ୍ଟ୍ରିମ୍